Hi everyone, welcome to PrepFusion. So in this video you are going to study about region of convergence in S plane as well, in Z plane as well. So usually we think that region of convergence is just outer to the outermost pole or inner to the innermost pole. But no, it is way more than that. So it would be roughly around 7 hours of video. In this 7 hour of video you are going to see all kind of possible signals and sequences, and you would see their region of convergence in S plane and Z plane, and you will also see that how S plane and Z plane are related. So complete discussion is going to be there, but this is not a comprehensive video, right? Like this is not a video which is recorded 7 hours in one go. There were different kind of videos. From different kind of videos, whatever the part that is necessary, that I have cut down and joined all of them, and then this video is coming. Are you able to understand this point? Like this is not the complete 7 hour of video, but flow will not be broken. You will not feel like that, sir, flow is broken. It is just that whatever that is necessary for the topic region of convergence, that I have put here. Okay, so you are going to understand about region of convergence, but in between there will be cuts, because some part I have to erase, because that part is not necessary for region of convergence. So in this video you are going to just study about region of convergence, but there are some prerequisite. You need to have the idea of Laplace transform and Z transform. Like no one can watch this video from zero. If you don't even know what is Laplace transform, what is Z transform, like at least you should know what is pole zero, or at least you should know the basic meaning of ROC. Like what do you mean by region of convergence? So if basics are clear, then only you should watch this video. So this is not for the for those guys who are starting from zero. This is not for those guys who will start Laplace transform and Z transform from zero. If you want to start it from zero, that means you need to study it from comprehensive course. So in comprehensive course, everything I have taught. Now from the comprehensive course video only, whatever that is necessary for ROC, that part I am putting here. Okay. So for that you need to have the basic idea of Laplace transform and Z transform. And surely you should watch this video completely, because mostly those guys who have already studied this topic, they only will be watching this video, right? If you have already studied Laplace transform and Z transform, then only you will be watching this video. So you can watch it in a quick manner. This 7 hours of video will take you roughly around 3 to 4 hours, and I can tell you at least 10 new points you are going to learn. No matter from wherever you have studied, at least 10 new points, and just by looking at the sequence, just by looking at the signals, you will be able to tell the ROC. Just by looking at that, without even using the pen, you will be able to tell the ROC, no matter whether it is in S plane or Z plane. So you can watch it in a quick manner. You can watch all the signals, you can watch all the concept that I am teaching. So if you have already studied it, it will be useful for you. If you are starting from zero, then it is not useful for you. Okay, you need to have a basic idea of Laplace transform and Z transform. So let's get started. First we will see Laplace transform, and then we will see Z transform. Thank you very much. Yeah, welcome back. So now we are going to see the finite duration and a finite amplitude signal. Okay, so this is a finite duration signal. That means it is there from -1 to 1 only. After that it is 0, and before -1 it is 0. And amplitude is also finite, which is 1. Amplitude could be anything, but it cannot be infinity, right? So what will be the ROC for finite duration and finite amplitude signal? So our first target is to find out the ROC, and then we will see how do we find out its Laplace transform. So Laplace transform will be very easy. So let's first see how we will find out the Laplace transform. Okay, so xt can be written as, x of t can be written as u of t plus 1 minus u of t minus 1. Say yes or no? Xt can be written in this manner, right? U of t plus 1 minus u of t minus 1. U of t plus 1 minus u of t minus 1. Well and good. What is the Laplace transform of ut? Laplace transform of ut is 1 by s. What will be the Laplace transform of ut plus t naught? That would be e to the power s t naught divided by s. So similar thing is happening here. E to the power s t naught value is 1 divided by s, minus e to the power s t naught divided by 1. What is the value of t naught? That is minus 1 divided by s. So what you are getting? X of s as e to the power s minus e to the power minus s divided by s. Now what you have studied, that if you do any shift, if you make any shift, then your ROC should not change. So here you will say that, sir, my ROC is sigma greater than 0. For this particular thing, my ROC is sigma greater than 0, because ut is having a ROC of sigma greater than 0. So if I am doing any shift, then it should not change the ROC. And this guy is also saying that sigma should be greater than 0, right? So practically whatever that we have studied, according to that, the ROC should be sigma greater than 0, because shifting will not change the ROC. Ut is saying that my ROC should be sigma greater than 0, so this will also have ROC sigma greater than 0. Now this is having ROC sigma greater than 0, this is having ROC sigma greater than 0. Now what you need to take? You need to take the intersection, right? So if I take the intersection, then what will be the intersection? What will be the common area? Common area will be sigma greater than 0 only. But this is wrong. Why it is wrong? Because it is a finite duration signal. So for finite duration signal, something else is happening. What else is happening? Let's try to understand that. What is the location of pole here? What is the location of pole? Pole of x of s. Do you really think that if I put the denominator equals to 0, so this should be my pole? No. This example we have already seen. This is not a pole, because what is the value of x of s at s equals to 0? If we put e to the power 0 minus e to the power minus 0 divided by 0. So e to the power 0 is 1, e to the power minus 0 1 divided by 0. So 0 by 0, which is indeterminate form. So for that, what you need to do? You need to apply the L'Hopital rule. So limit s tending to 0. Upper side differentiated, downward also differentiated. Put s equals to 0, what you are getting? What you are getting? 2. That means this is not a pole. So surely there is no finite pole. If I make the S plane, in the S plane there is no finite pole. There is no finite pole. So can you show the pole anywhere? What we felt, first we felt that sigma should be greater than 0. Here what will be the pole? For this particular function, what will be the pole? S equals to 0 is the pole. Because if you put s equals to 0 here, e to the power 0 will be 1, 1 divided by 0 will be infinity. So yeah, that was the pole. S equals to 0 was the pole. So first we thought that sigma greater than 0 should be the ROC for this one, and sigma greater than 0 should be the ROC for the other one as well. So both are having the same ROC, which is sigma greater than 0. So what will be the common part? This will be the common part. But the new function became finite duration signal. And now if it is a finite duration signal, we got to know that there is no finite pole. There is no finite pole. This s equals to 0 is not a pole. We thought that s equals to 0 will be a pole, but no, this is not a pole. Pole will be at infinity or minus infinity, I don't know. Pole can be at infinity or minus infinity, I don't know. If the pole is at infinity, if the pole is at minus infinity, or pole could be at infinity. Here we can check that the pole will be at infinity only, I guess. Because if I put e to the power infinity, yeah. So pole will be at infinity. Okay, or it could be at minus infinity, I don't care. I don't care where the pole is. But what do we know? From the pole, either we will look towards plus infinity or we will look towards minus infinity. So if we are standing at minus infinity, if my pole is at minus infinity, so what I will say? Look towards plus infinity. Because I cannot look towards minus infinity because I am already at minus infinity. So what I will say? Look towards plus infinity. That means this should be the ROC. So what is the ROC? Entire S plane. And if I am standing at plus infinity, so what I will say? Look towards minus infinity. Look, what do we do? There is a finite pole. What do we do? If there is ut, so we look towards plus infinity. And if there is u of minus t, we look towards minus infinity. Say yes or no. But now what we are doing? We are already standing at either plus infinity or minus infinity. So if I am standing at minus infinity, I have to look towards plus infinity. So if I look towards plus infinity, this is the region I am covering. That means entire S plane I am covering. And if I am standing here, so I will look here. That means again I am covering the entire S plane. So what is the ROC? ROC is entire S plane. Okay. So what is the ROC? ROC is entire S plane. But let's understand with respect to graph. What you need to do? You need to multiply this xt with e to the power minus sigma t. E to the power minus sigma t. You need to multiply xt with e to the power minus sigma t. If I take sigma greater than 0, if I take sigma less than 0, if I take any random value of sigma, so only two kind of graphs are possible, right? E to the power minus sigma t can have two kind of graphs. For sigma greater than 0, it will have this kind of graph, that at t equals to infinity it will decay. And for sigma less than 0, what kind of graph it will have? At t equals to infinity it will throw infinity value. So these two kind of graph I will have. Now what is happening? This graph, what is this? This is the graph of e to the power minus sigma t. This is the graph of e to the power minus sigma t only. So this graph will be multiplied with a finite duration signal. This graph will be multiplied with this particular signal. Now what this particular signal is saying? That between minus 1 to 1, I am throwing the value equals to 1. Otherwise I am throwing the value equals to 0. So if you multiply this particular graph with this graph, then what will be the resultant graph? The resultant graph will be this much only. The resultant graph will be this much. After that everything will be 0, or I should cut like this. After that everything will go to 0. After that everything will go to 0. This part, everything will go to 0. Only this much part you will get. So xt multiply with e to the power minus sigma t, what you are getting? You are again getting a finite duration signal. So if you multiply a finite duration signal with the exponential signal, the resultant signal will be finite duration only. So this is finite duration only, and surely it is absolutely integrable. Absolutely integrable for sure. Similar thing you can do with this one as well. If I multiply this particular signal with xt with e to the power minus sigma t, where sigma is less than 0, so what will happen? Between minus 1 to 1, it will throw the value 1. That means 1 will be multiplied with this particular graph. 1 will be multiplied with this particular graph. Rest all the portion will throw to 0. Rest all the portion will throw to 0. Rest all the portion will throw to 0. Only this much graph will be there. Rest all the portion will be thrown to 0. So if I multiply a finite duration signal with e to the power minus sigma t, no matter whatever the value of sigma is there, if I multiply a finite duration signal xt with e to the power minus sigma t, no matter whatever the value of sigma is there, the resultant signal will surely be a finite duration signal only, and as finite duration signal is surely absolutely integrable. So for every value of sigma, this is becoming absolutely integrable. You took sigma greater than 0, you took sigma less than 0, surely your signal xt dot e to the power minus sigma t is absolutely integrable only. So what I will say, for every value of sigma, xt dot e to the power minus sigma t is absolutely integrable. And this is our target. That's why we were multiplying our xt with e to the power minus sigma t. So for all other signals, we were getting some condition that sigma should be greater than 2, sigma should be greater than 0, sigma should be less than minus 2, sigma should be less than plus 2, sigma should be less than plus 3. But here what we got to know, that no matter whatever the value of sigma you take, it is always absolutely integrable. That means the ROC is entire S-plane. What is the ROC? ROC is entire S-plane. So for a finite duration signal, the ROC is entire S-plane. So for finite duration plus finite amplitude, amplitude should also be finite. For finite duration plus finite amplitude signal, ROC is entire S-plane. Okay. So how will I make the ROC? I will make the ROC in this manner, that it is entire S-plane, complete S-plane it is. Entire S-plane. Okay, so this was the mathematical one. So first thing we got to know that shifting will not change the ROC. Yeah, that is right. Shifting will not change the ROC. But when you make the signal after shifting, after adding, subtracting, if your signal is becoming a finite duration signal, then the ROC would become entire S-plane. Because I know that if I multiply any signal xt with e to the power minus sigma t, surely it will be a finite duration and finite amplitude signal only, which is surely absolutely integrable. Okay, so that was a very good point. Okay, and a very simple point as well. So if you see any finite duration signal, always you will say that my ROC is entire S-plane. And next task could be that you need to denote your finite duration signal. You need to denote your finite duration signal in terms of ut, rt, delta t. In any kind of signal you can denote it, right? So here I saw that this can be denoted in terms of ut, u of t plus 1 minus u of t minus 1. So I know that ut will have a Laplace transform of 1 by s. So u of t plus t naught will have a Laplace transform of e to the power s t naught divided by s. So that I wrote down, and from there I got this x of s. So if someone is asking me what is my x of s, then this is what I will say, that this is my x of s with the ROC of entire S-plane. Okay. Let's see another question. If xt is impulse function, then what will be its ROC and what will be its x of s? So can you let me know the ROC? Very simple. What you need to do? Xt with e to the power minus sigma t. What is your xt? Xt is delta t. E to the power minus sigma t. T minus 0. Basically, how it can be written? T minus 0. T minus 0 and delta, in place of this t, I will put 0. do you remember this particular thing, xt dot delta t? What that would be? X of 0 dot delta t, right? T minus 0, this 0 goes here, x of 0 delta t. So similar thing I am doing. This is a signal, e to the power minus sigma t is a signal. You can call this signal as yt. So what you are doing? This 0 you are putting here. So e to the power minus sigma into 0, what that would be? 1. So what you are getting? Delta t, right? So xt multiplied with e to the power minus sigma t, where your xt is delta t. So if you are multiplying your impulse function with e to the power minus sigma t, you are getting the impulse function again, which is absolutely integrable, right? Do you know minus infinity to infinity mod of delta t dot dt? What it will throw? It will throw 1 only. So yes, it is absolutely integrable. Integrable, right? So no matter whatever the value of sigma you put, no matter whatever the value of sigma you put, what is happening? Sigma is being neutralized with 0. Sigma is being neutralized with 0. So no matter whatever the value of sigma you are putting, sigma here is making no impact, because if you multiply any signal with xt, what is happening? Here you will put t, so e to the power 0 will be 1 only. So sigma is making no impact here. So here also you got to know that it is absolutely integrable for any value of sigma. Sigma. So what do you think? What is your ROC? So again your ROC is entire S plane. Okay. So this is what we have thought with respect to diagram or with respect to the common sense. But we have a method as well. What is the method? You find x of s. Then what do? You find out the pole, and then you locate the pole location, and based on that you can find your ROC. So let's try finding out x of s, and from there we will get a pole. Okay. So let's find x of s. So what will be your x of s? Minus infinity to infinity x of t e to the power minus st dot dt. Minus infinity to infinity xt is delta t e to the power minus st dot dt. What is the property of delta t? T minus 0, 0 will be put here. So what you will be getting? Minus infinity to infinity delta t, 0 will be put here, dot dt. So minus infinity to infinity delta t dot dt. So what is this? 1. So what is your x of s? 1. What is your x of s coming out to be? 1. What was its Fourier transform? What was the Fourier transform of delta t? Delta t was having a Fourier transform of 1, and delta t is having a Laplace transform of 1 as well, with the ROC being entire S plane. Entire S plane. Okay. So both Fourier transform, Laplace transform, both are 1 only, and ROC is entire S plane. Why it is entire S plane? Can you see? What is the location of pole? There is no finite pole, right? Denominator you need to put equals to 0. Here what is the denominator? Denominator is 1. Can you put 1 equals to 1? 1 equals to 0? No. What is our target? Always what do we do if this expression is written and I ask you to find out the pole? You put denominator equals to 0. So s equals to minus 2. That is the pole. Here what is the denominator? Denominator is not even a function of s. It is a constant value. So there is no finite pole. Right? So what I will write down? No finite pole. And if there is no finite pole, that means surely your ROC will be entire S plane only. So if there is no finite pole, that means your ROC is entire S plane. Okay. So ROC is entire S plane. In that manner I can show it. So it is entire S plane. So from here onwards, you will remember what is the Laplace transform of delta t. That is 1. What was the Laplace transform of ut? 1 by s. What is the Laplace transform of tut? That is 1 by s square. Right? So now you need to find out x of s for this particular function and for this particular function, and along with that you need to tell the ROC as well. So is it a finite duration signal? No. That is going towards plus infinity. So surely it is not a finite duration signal. Right? So we need to find out the ROC. That we will find out. Don't worry about that. Is it a finite duration signal? Yes. This is a finite duration and finite amplitude signal. Finite duration plus finite amplitude. That means what will be its ROC? ROC will be entire S plane. entire S plane. What about this one? Let's first find out the x of S. So how will you write down your x of t? How can I write down my xt? Here what is the slope? Slope is 1. Slope is 1. And from where it is starting? It is starting from -1. So can I write down r of t plus 1? With the slope 1, you are starting from -1, r of t plus 1. I hope you remember all these kind of things. In the basics of signal, we have studied everything. So r of t plus 1, and then here the slope becomes 0. So at point 1, the slope becomes 0. So minus r of t minus 1. Is there any sudden drop? No, there is no sudden drop. That means ut will not come here. So that's it. This is your xt. R of t plus 1, because there is a slope of 1. There is no sudden jump. If there was a sudden jump, that means if I write down xt here, so what really happened? There is a sudden jump of 2 at t equals to 0. So 2 ut. Then there is a sudden decay of 2. That means minus 4 u of t minus 2. At t equals to 2, there is a decay of 4. And then at t equals to 4, there is a increase of 2. So increase, decay, increase. Right? 2 minus 4 plus 2. ut, u of t minus 2, u of t minus 4. Amplitude you can see 2 minus 4 plus 2. That will be 0 only. And here slope 1 minus 1. So eventually the slope is becoming 0. So here the slope was 1. Here the slope has become 0. If there was a decay in the amplitude as well, let's just say if the signal was like this, then what I would have done? There would have been a decay of 2. So minus 2 u of t minus 1. So that I don't need to do. In the basics of signal, we have studied everything. Like more than 20 examples we have solved there. So no need to worry about that. So from here, can I find my x of S? What is the x of S for RT? That is 1 by S square. So what it will be for RT plus T naught? E to the power S T naught divided by S square. So here what I will get? E to the power S T naught value is 1 divided by S square minus e to the power minus S divided by S square. Is that okay for you? Right? So what is the x of S you are getting? E to the power S minus e to the power minus S divided by S square. You feel like that S equals to 0 will not be the pole, but it will be the pole. Okay? So have some patience here. But here what do you see? X of S 2 divided by S minus 2 e to the power minus 2S divided by S. Oh, okay, it is not 2, it is 4. Here amplitude is 4 e to the power minus 2S because of this minus 2 divided by S plus 2 e to the power minus 4S divided by S. This is your x of S, and when you put S equals to 0, you will find out that this is not a pole. Okay, so S equals to 0 is not a pole here. Not a pole. Not a pole. Because if S equals to 0 is a pole, then ROC would have been something different. But I know that here ROC is entire S plane since it is a finite duration signal. So if it is a finite duration signal, then you don't even need to find the pole. Entire S plane. Okay. But here I need to find out the ROC. Here I need to find out the pole because I know that here ROC will not be entire S plane. So let's find out x of S is. मेरी गर्दन का कुछ करना पड़ेगा. I have to do something with my neck. Why it turns down when I write down? Does this happens with you as well? That when you write down it turns down. I don't know how I build up this habit. So e to the power S minus e to the power minus S square divided by S square. If I put S equals to 0, I can clearly see that it will throw 0 by 0 form, right? If I put S equals to 0 here, it will be throwing 0 by 0 form. So I need to apply L'Hopital rule. But twice I will have to apply L'Hopital rule because e to the power S, e to the power minus S divided by 2S. So if I put e to the power 0 plus e to the power minus 0 divided by, okay, twice I will not have to apply. That would be 2 by 0 is equals to infinity. I am getting infinity here. At S equals to 0, I am getting the infinity answer. This is what I wanted. When I put x of S at S equals to 0, I applied the L'Hopital rule because 0 by 0 form I was getting. So I applied the L'Hopital rule e to the power S plus e to the power minus S. So I put S equals to 0. As e to the power 0 is 1, e to the power minus 0 is also 1. And then divided by 2 into 0. 2 divided by 0 is infinity only. So yes, I am getting infinity. What does that mean? That yes, it is a pole. S equals to 0 is a pole. S equals to 0 is a pole. what I is a pole. Okay, so let's show this pole on S plane. So how will I show this pole on S plane? Here I will show the pole on S plane. S equals to 0 is a pole. So this is a very good conclusion that we have got, that S equals to 0 is a pole. Now what I will do? I will draw a line which is passing through this pole. Now I need to check whether my ROC will be either towards this side or it will be towards this side. ROC will be towards this side or towards this side. So where will be the ROC? What do you think? The ROC, if there was UT, the ROC was looking towards this side, and if there was U of minus t, the ROC was looking towards this side, right? So where does the UT look? UT look towards plus infinity, and where does U of minus t look? U of minus t looks towards minus infinity. UT looks towards plus infinity, U of minus t looks towards minus infinity. Where this graph is looking? Towards plus infinity only. This graph is looking towards plus infinity. So here, where will be the ROC? It will look towards plus infinity only. There you. So what is the ROC? Sigma greater than 0. Let me explain you by one more way. Okay. So this was our graph, right? This was our xt. So can I break down my xt in these kind of two manners? Can I break down my xt in these kind of two manners? In which kind of two manners? I am breaking down my xt. A finite duration signal plus a step. What I am doing? A finite duration signal minus 1, 1, this point is 2, this is 1, this point is 2. So my xt is a finite duration plus finite amplitude signal plus shifted version of step plus shifted version of step. Are you able to understand this point? This is my xt, a finite duration signal plus shifted version of step. Now what is the ROC for a finite duration and finite amplitude signal? Sigma greater than 0, right? What is the ROC for a finite duration and finite amplitude signal? Sigma greater than 0. And what is the ROC for a shifted version of step? If you shift it, that doesn't mean your ROC will change. So what is the ROC of a step? Okay, sorry, really sorry, the brain fade moment. What is the ROC of a finite duration and finite amplitude signal? That is entire S plane. Really sorry, I was thinking something else. Okay, entire S plane. ROC of finite duration plus finite amplitude signal is entire S plane. What is the ROC of a step signal? Sigma greater than 0. And if I shift my step signal, will the ROC change? No. If I shift my step signal, ROC will not change, because if I shift my step signal, then this is the Laplace transform I will be getting. Again, the pole is at 0 only. But here you shifted and added and subtracted. So you did two operations, shifting and addition subtraction as well. So because of that, it became a finite duration signal and your ROC became entire S plane. But if you only shift, then your ROC will not change, right? If you only do the shifting operation, then ROC will not be changing. So here what I am doing, here only my UT is shifted by 1. UT is right shifted by 1. So this is 2u of t minus 1. This is 2u of t minus 1. So here this guy is saying that your ROC should be entire S plane, and this guy is saying that your ROC should be sigma greater than 0. So what one guy is saying? So someone is saying that ROC should be entire S plane. Someone is saying that ROC should be entire S plane, and someone is saying that it should be greater than 0. Someone is saying that it should be greater than 0. So what will happen? What is the common area? Common area is sigma greater than 0 only, right? So common area is sigma greater than 0. So you understood here, right? What is the ROC? So ROC here will be real part of S should be greater than 0. So two method I have told you. First one, you can look at this graph. First you find out the pole. Where is the pole? The pole is at S equals to 0. Then you look at the graph is looking towards plus infinity. So my ROC will also look towards plus infinity. So ROC is sigma greater than 0. But if I don't even want to find out the pole, I don't want to find out the pole, what I want to do, I want to think intuitively that how will I think that this can be broken into a finite duration signal and a shifted version of step. So finite duration signal will say that ROC will be entire S plane, but the shifted version of step will say that ROC should be sigma greater than 0. ROC should be real part of S greater than 0. So one is saying entire S plane, one is saying that real part of S should be greater than 0. That means what will be the common area? Common area will be real part of S greater than 0. So without even finding out the pole, without even doing any calculation, just by looking at the graph, I can tell that the ROC will be sigma greater than 0, real part of S greater than 0 for sure. Is that okay for you? All good? All fine? Let's move to the next topic. What is the next topic? Next topic is you need to find out the Laplace transform of a repetitive signal. That means your signal is being repeated. This particular portion is continuously being repeated. So kind of I can say that this kind of signal is known as oscillatory signal. The signal is oscillatory, right? The kind of it is oscillatory only. Oscillatory means again and again it is being repeated. If I ask you what is the value of xt at t tending to infinity, what is the value? You cannot say because it is oscillatory, right? The graph is oscillatory, xt is oscillatory. So if I ask you what is the value of xt at t tending to infinity, can you tell me the value? Someone will say value could be this value could be 1.5, value could be 0.5, 0.7. Someone will say value will be 1. Someone will say value will be, sir, 0.3. Anyone can tell any value. Someone will say value will be 0. So at t tending to infinity, can you tell the xt value? No. That means the graph is oscillatory. So this is known as oscillatory graph. So any value it can take. But if I make the graph ut, and if I ask you what is the value of ut at t tending to infinity, what is the value? That is 1. For sure it is 1. Because it is always 1. If I draw the graph of RT, and if I ask you what is the value of RT at t tending to infinity, you will surely say it is infinity only because it is continuously rising. If I draw the graph of e to the power t ut, if I ask you what is the value of e to the power t ut at t tending to infinity, it is infinity only because it is continuously rising. But if I ask you what is the value of sin t at t tending to infinity, what is the value of sin t at t tending to infinity? So graph is like this. You cannot tell at infinity as well, it will be oscillatory only. So this is known as oscillatory graph. Okay. Since the values are oscillating again and again at infinity, that's why it is known as oscillatory. So signal xt is oscillatory. Well and good. What do you think? What should be the ROC? Think with respect to graph. xt being multiplied with e to the power minus sigma t. Do I have anything here? No. So xt being multiplied with e to the power minus sigma t, right? You have two kind of graph, sigma greater than 0, and for sigma less than 0. Should we see the mathematics first or should we understand the graph first? By the graph you would have understood what do I want. Surely I want sigma greater than 0, right? This is a repetitive signal which is repeating in the right side. This is a right sided signal, right? This is a right sided signal. So it is repeating in the right side. So what kind of graph I will get? For sigma greater than 0, what kind of graph I will get? And for sigma less than 0, what kind of graph I will get? So I know the nature of graph for both of the conditions. For sigma greater than 0, this would be the graph. And for sigma less than 0, this would be the graph. If I multiply this particular graph with this graph, what will happen? At infinity, the value is going down to 0. And here, the increasing value will be nullified by this particular 0. So 0 will be multiplied with this increasing value. So this increasing value will be nullified. And after that, these kind of graph I will keep on getting. And at infinity, they will go down to 0. That means it will become absolutely integrable. But for this case, this part will be nullified by the 0. But here what will happen? These will keep on rising up. These triangles will keep on rising up. But here the triangles will keep on decaying. Right? Although this will not be the correct waveform, the correct waveform will be in this in between, it will be there. Okay, since this is a positive value only, so positive will be multiplied with positive, it will throw positive only. So no need to make the envelope. So this is in this manner the graph will keep on going down. So it will become absolutely integrable. But here what is happening? If you are multiplying with sigma less than 0, that means at infinity the value is rising up. So what is the desirable condition? This is the desirable condition. That means your ROC will be real part of S greater than 0. right? Say yes or no. But how will I find it mathematically? Let's do it mathematically. So mathematically, how will you find out the Laplace transform of this kind of signal? How will you do that? So first what you will do, you will break it down into one signal only, one part only. And then you will say that this part is being repeated. What I am saying, I will make a signal yt. I will make a signal yt. Yt in which manner? In this manner. I will make a signal yt in this manner. This is my yt signal. So I am just putting this common part which is being repeated. So this part is being repeated, right? So this is 0 to 2. This part is 1. And this part is also 1 only, right? Okay. So now can I am calling this as yt. This is my yt. So can I write down my xt as y of t plus y of t minus 3, right? No, y of t minus 2, y of t minus 2 plus y of t minus 4 plus y of t minus 6 and so on. How I am doing it? If you shift this graph y of t minus 2, what will be the graph of y of t minus 2? This 0 will be shifted to 2, this 2 will be shifted to 4 and this point will be 3. Then what will be t minus 4? 4 to 6, 5, 1, and you need to add them up. So 0 to 2, then 2 to 3, then 4 to 6. In that manner you will keep on getting these triangles. So can I write down my xt as in this manner? Yt plus y of t minus 2 plus y of t minus 4 y of t minus 6. Surely I can write it down, right? So what would have been your x of s? X of s would have been y of s plus e to the power minus 2s y of s plus e to the power minus 4s y of s plus e to the power minus 6x y of s and so on. Then y of s I am taking common, 1 plus e to the power minus 2s plus e to the power minus 4s plus e to the power minus 6s and so on. So what is this? This is a GP. This is a GP, right? With the value of r. Here what is the value of a? 1. What is the value of r? E to the power minus 2s. And do you remember the sum of infinite GP? That is a upon 1 minus r. A upon 1 minus r. But this formula is only true if your r is less than 1. Mode of r is less than 1. So this formula, sum of infinite GP, that is a upon 1 minus r, that is only true if your mode of r is less than 1. So you wrote down this particular thing, that here this is your x of s. This is what you are writing down. The x of s is y of s. Y of s we will find out from this particular expression. So y of s divided by 1 minus e to the power minus 2s. This is what you are writing down. But this is only true if your mode of r is less than 1. What is your r? E to the power minus 2s. So e to the power minus 2s, mode of e to the power minus 2s should be less than 1. What is e to the power minus 2s? Sigma plus j omega should be less than 1, right? So I have to do this calculation here. So from here I am doing it. E to the power minus 2 sigma into e to the power minus 2 j omega should be less than 1. Do you agree to this point? In place of s you are putting sigma plus j omega. Now a into b, then there is a mode. So e to the power minus 2 sigma mode and then e to the power minus 2 j omega mode should be less than 1. What is the value of this one? Mode of e to the power j theta, always 1. So this is 1 only. This is 1 only, right? So this value is 1 only. So mode of e to the power minus 2 sigma should be less than 1, right? Here what should be the value of sigma now? E to the power minus 2 sigma. Can you draw the graph of e to the power minus 2 sigma versus sigma? Sigma versus e to the power minus 2 sigma. So at sigma equals to, I am not drawing it with respect to t, no, I am drawing it with respect to sigma. So at sigma equals to infinity, it will throw 0 value. At sigma equals to 0, it will throw 1. At sigma equals to minus infinity, it will throw infinity only. And you want this value to be less than 1. That means you want this region. Here the value is greater than 1. Basically, if your sigma is greater than 0, then this value will be surely less than 1 for sure. Because at sigma equals to 0, the value is 1. At sigma equals to minus 1, at sigma equals to minus 1, the value will be e to the power 2, which is greater than 1. You want the value to be less than 1. That means you want the sigma to be sigma to be greater than 0. If sigma is greater than 0, let's just say sigma is 1. So what value you will get? E to the power minus 2, which is less than 1. E to the power minus 2 will be 1 by e square, which is less than 1 only, right? You want it to be less than 1. This is the condition. E to the power minus 2 sigma, mod of e to the power minus 2 sigma should be less than 1. What does that mean? That means sigma should be greater than 0. This is basic mathematics, right? And even if you don't understand this mathematics, then I have told you to draw the graph between e to the power minus 2 sigma versus sigma I am drawing. So this kind of graph I will be getting. I know that I need the value to be lesser than 1. That means I need the value of sigma in this region. That means sigma should be greater than 0. So from here, what is the ROC that we are getting? What is the condition that we are getting? The important part is, what is the condition? What is the condition we have got? That our sigma should be greater than 0. Or I can say, real part of S should be greater than 0. This is the condition we have got. Right? Let's find out y of S as well now. So what is our yt? You do it on your own. I will take a break. Okay, I will drink some water. You do it on your own. You write down the expression of yt, and from there you find out y of S. So you can do it on your own. After that, we will again continue our discussion, and you will let me know what will be the ROC of this particular signal. Okay. Yeah. So could you write down the expression of yt? So expression of yt would be RT minus 2R of t minus 1 plus R of t minus 2, right? RT slope is 1. Here what is the slope? Slope is 1. Here what is the slope? Slope is minus 1. And now here what is the slope? Slope is 0. So you started with slope 1, then slope became minus 1. So 1 minus 2, slope became minus 1. Then again the slope became 0. So minus 1 plus 1, the slope became 0. So this method we have already seen in our basics of signal. We know how to write down this yt. So what would be my y of S? Y of S would have been 1 by s square minus 2 e to the power minus s divided by s square plus e to the power minus 2s divided by s square. So this would have been your y of S. So from here, can you write down your x of S? So my final answer of x of S is coming out to be ys divided by 1 minus e to the power minus 2s. So my ys is 1 minus 2 e to the power minus s plus e to the power minus 2s divided by s square into 1 minus e to the power minus 2s. So this is the x of S you are getting. 1 minus 2 e to the power minus s plus e to the power minus 2s divided by s square into 1 minus e to the power minus 2s. S equals to 0 is a pole or not? That we don't know, right? If I put s equals to 0 here, 0 by 0 form I will be getting. 0 by 0 form I will be getting. If I put s equals to 0, s equals to 0 here, then you put s equals to 0 here, what it will become? 1 minus 2 plus 1 divided by 0. Then I need to apply the L'Hopital rule and all these kind of things I need to do, and I will get to know whether s equals to 0 is my pole or not. So I am not sure whether s equals to 0 is my pole or not. I need to apply L'Hopital rule. Okay, so should we do it? But one thing I know, that some more poles I will be getting, and all the poles will be on j omega axis. What I am saying, more poles I will be getting, and all the poles will be on the j omega axis. What do I mean by that? For getting the pole, what you need to do, you need to put this part equals to 0 as well. For getting the pole, what you will do, you will put the denominator equals to 0. So if you put s square equals to 0, that means s equals to 0 you are getting. But if I put 1 minus e to the power minus 2s equals to 0, what I will be getting? E to the power minus 2s equals to 1. That means my 2s should be equals to j 2n pi. Did you understand this point? E to the power minus j 2 pi, what is the value? 1. E to the power minus j 4 pi, what is the value? 1. E to the power minus j 6 pi, what is the value? 1. a to the power plus j 2 pi, what is the value? 1. A to the power plus j 4 pi, what is the value? 1. That means if minus 2s is equals to j 2n pi, where n is any integer, I am not sure if n is 0, then what will be the case? If n is 0, then what will happen? S becomes 0. So s equals to 0 is a pole or not, that I don't know, but surely these are the poles, no one can stop it. So from here what you are getting? S equals to j n pi minus j n pi. So basically minus sign doesn't matter here, because n is already plus minus. N is already plus minus 1, plus minus 2, plus minus 3, so this minus sign will not matter. So basically at every j pi, at every j n pi, I am having a pole. So what I need to do, I need to add a page. I will take down this page. So here I am getting that surely my poles will be at s equals to plus minus j n pi. What is my x of s? My x of s is, this is here, from here only we are getting the ROC, right? From here only we are getting the ROC. But we are doing more things, like what if we find out the poles? From the poles, what kind of ROC we will get? Someone will have a doubt that, sir, till this point you are finding the pole and from there you will telling the ROC. But here only you are telling the ROC. Yes, this is one of the way. Other way was the graph. From here also you could tell the ROC. But what about the poles? So what you are getting to know that at plus minus j n pi you are having the poles. I am not sure about s equals to 0. So forget about s equals to 0 as of now. But surely at plus minus j n pi you are having the poles. And what is your x of s? X of s is 1 minus 2 e to the power minus s plus e to the power minus 2s divided by s square upon 1 minus e to the power minus 2s. So let's take any value. If I put s equals to j pi here, what I will get? S equals to j pi, if I get minus j2 pi divided by j pi square 1 minus e to the power minus j2 pi. So 1 plus 2 plus 0 divided by this, whatever the value it is, and then this is 0 only. So what is the answer I am getting? Infinity only. So basically I was just checking that if I put j n pi here, what impact it will make. If I put j n pi here, what will be the answer I will be getting? This is what I was checking. But a to the power j pi is 1 actually, sorry, this is 1, this is 1, and a to the power minus j pi is minus 1, so 1 plus 2 plus 1, so what I am getting? 4 by 0, that is infinity only. But if I put j2 pi, then there would be issue, right? In place of s, if I put j2 pi, what will happen? 1 minus e to the power minus j2 pi plus e to the power minus j4 pi divided by j2 pi square 1 minus e to the power minus j2 pi. So what this will be? What will be this value? 1 minus this value will be 1 only. E to the power minus j2 pi is 1 only. What will be this value? This value will also be 1 divided by, this is some 4 pi square, whatever it is, I don't care, 2 pi square, whatever it is, minus sign is there, whatever it is. What this value will be? This value will also be 1. So it is becoming 0 by 0 form. So again you need to apply the L'Hopital rule. So for j pi I don't have any issue. J pi, for j3 pi I will not have any issue. For j5 pi I will not have any issue. Same goes in the negative direction as well. So I will not have any issue with these guys. But if plus minus j2 pi is there, plus minus j4 pi is there, then I am getting that I have to apply the L'Hopital rule. So all these calculation should not be required. In the examination hall you would know that since it is a right sided signal which is continuously repeating, if I multiply with e to the power minus sigma t, so sigma should be greater than 0, or from here as well we are getting the condition sigma should be greater than 0. But if someone asks you to find out the pole, then you could get to know that plus minus j pi plus minus j3 pi plus minus j4 pi, there is no issue. But the issue is becoming with plus minus j2 pi plus minus j3 pi plus, sorry, plus minus j2 pi plus minus j4 pi, and issue is becoming with s equals to 0 as well, right? So basically there has been no issue with 2n plus 1 pi, where n belongs to any integer. There is no issue with this particular thing. But for the others I need to check at some points. Basically for others I need to apply the L'Hopital rule. So let's apply the L'Hopital rule. Let's differentiate it. What we can do? We have to differentiate. So let's differentiate L'Hopital rule. So we are checking at s equals to 0. Let's check at s equals to 0. Let's check at s equals to 0. So what I need to do, I need to apply the L'Hopital rule, right? This is the differentiation. And what is this? This is your s square minus s square e to the power minus 2s. So what I will be getting? 2s minus s square e to the power minus 2s into minus 2 plus e to the power minus 2s into 2s. So what we are getting? 1 plus 2 e to the power minus s minus 2 e to the power minus 2s divided by 2s minus, this will become plus 2 s square e to the power minus 2s plus 2s e to the power minus 2s. Again, if you put s equals to 0, there is some problem or not? No. Now if I put s equals to 0, there is no problem, right? Because if I put s equals to 0 here, what it will become? 1 plus 2 minus 2, right? Divided by s equals to 0, 0, 0, 0. So 1 divided by 0, what it is becoming? Infinity only. So yes, s equals to 0 is also a pole here, right? Did I do the calculation correctly? Let's check again. So what I was doing, I was applying the L'Hopital rule. So I need to differentiate upper side and downward side. So 1 plus e to the power 1 plus 2 e to the power minus s minus 2 e to the power minus 2s divided by 2s minus now s square e to the power minus 2s. So first one as it is, differentiation of the second one, plus second one as it is, differentiation of the first one. So 2s minus s square, this will become plus 2s square e to the power minus 2s, and then here there will be negative sign, sorry, this sign will be negative, minus 2s e to the power minus 2s, right? So after applying the L'Hopital rule, this is what I am getting. After applying the L'Hopital rule, if I put s tending to 0 here, here also limit s tending to 0 is going, here also limit s tending to 0 is going. So if I put s tending to 0 here, so 1 plus 2 minus 2 divided by 0 plus 0 plus 0. So 1 by 0. So I am getting infinity only. So yes, this is a pole. This is a pole. So for s equals to 0, I had to check. Similarly, for s equals to 2 pi, 4 pi also I need to check. So let's check for s equals to, let's check at s equals to j2 pi, j2 pi, right? So let's check at j2 pi. So here only I will put the value of j2 pi. So 1 plus 2 e to the power minus j2 pi minus 2 e to the power again 2 pi divided by, it will become some value that I don't care. It will be some whatever it is, j2 pi plus 2, let's keep it s square only, j2 pi s square e to the power minus j2 2 pi minus 2 j2 pi e to the power minus j2 2 pi. Okay. So basically e to the power j2 pi, that would be 1. This would also be 1. So what I am getting, 1 plus 2 minus 2 divided by this anything it is, 2j2 pi, whatever it is, I don't care, plus then I am getting 2. Basically this term will go to 1, this term will also go to 1. So what I am getting, 2s square I am getting downward 2s square I will get. E to the power minus 2s will go to 1, e to the power minus 2s, both will go to 1 only, right? So this 2s and this 2s will get cancelled out. So downward you will get 2s square. So basically this you will be left with. Downward you are left with 2s square, j2 pi square. So now what you are getting, 1 divided by some value, which is surely not infinity. So it is not a pole. So similarly, s equals to plus minus j2 pi plus minus j4 pi, these will not be the pole, not poles, right? But s equals to plus minus j pi, those were the poles for sure, because at those points what was happening, plus minus j pi here, plus minus j pi, so this was becoming 1 minus 1 0, and on the upper side you are getting a finite value. So 1 finite value divided by 0, it was becoming infinity only. but here we did not get infinity. I tried putting j2 pi here. So at j2 pi, this guy is becoming 1, this guy is also becoming 1. So 1 plus 1 minus 2. So you are getting 0. And at downward also, if I don't apply the L'Hopital rule, then downward as well, I was getting 0 only. But when I applied the L'Hopital rule, after that, this is the final expression I am getting. I have done the differentiation. So now if I put plus minus j2 pi or plus minus j2 pi or only plus j2 pi if I put, so 1 plus e to the power j2 pi, this would be 1. This would also be 1. So 1 plus 2 minus 2, so upper side I am getting 1. Downward what will happen? This will become 1 and this will also become 1. Say yes or no, right? So 2s and 2s will get cancelled out, 2s square will be remaining. So downward it is not becoming 0, it is becoming some finite value. This will be some finite value which will be minus 4 pi square. That I don't care, it will be some finite value. So finite value divided by finite value, it will never go to infinity. So they are not poles. So what do you understand, what all are the poles? So this is the pole, along with that s equals to 0 is also a pole. So if you make the pole 0 diagram, then these are the poles you will be getting. Which poles you will be getting? S equals to 0. Are you really sure that s equals to 0 is a pole? You can again check. If you put s equals to 0 here, if you put s equals to 0 here, 1 plus 2 minus 0, 1 only divided by 0, 0, 0, everything is 0. Okay, everything is crystal clear. There is no calculation mistake. I hope there is no calculation mistake. Nothing is wrong. So s equals to 0 is a pole. Then plus j pi plus j3 pi in that manner. Infinite poles are there. Plus j pi plus j3 pi, s equals to 0 is a pole. Minus j pi minus j3 pi minus j3 pi. In that manner, downward as well there are poles. So these all are the poles. Okay, so what is the next task? You always draw a line from these poles. You always draw a line from these poles. And then you look at the signal. Where the signal is looking? Signal is looking towards plus infinity. So my ROC will also look towards plus infinity. So what is my ROC? This is my ROC. This is my ROC. So ROC is sigma should be greater than 0. So here there is this ROC. So by finding the poles, this is how you will find out the ROC, which is becoming a tougher task, right? This was a tough task to do. You need to find the poles in this manner, which was a tougher task to do. But this can help you in control system. In control system, you have to find out the poles. So here you find out the poles. Poles are coming at 0 plus minus j pi plus minus j3 pi plus minus j5 pi. Okay. And one more thing you saw here, it was a oscillatory signal. So for an oscillatory signal, what kind of poles you are getting? Complex, right? And they are complex conjugate as well. Plus minus j pi plus minus j3 pi plus minus j5 pi. So this thing we will relate. We will write down one conclusion, but later on we will see that. But as of now, what was our target for this particular, from this particular question, from this particular discussion, what is the target? Let me tell you the conclusion. So there is a right side signal which is repeating. This is a right side signal which will keep on repeating. So what should be the ROC? From here only you can get to know the ROC. If you put sigma greater than 0, your job is done. Right? Because if I put sigma greater than 0, then this repeating part will be decaying. Right? And it will become absolutely integrable. How will you find out the Laplace transform? So for that you need to pick one signal and that will be repeated. The same thing we have done in Fourier transform as well. Pick one signal which will keep on repeating. So yt plus y of t minus 2 plus y of t minus 4. So in that manner we are getting. From here as well there was a condition. What was the condition? That this mode of r should be less than 1. So what is the mode of r here? R value is e to the power minus 2s. So e to the power minus 2 omega into e to the power minus 2j omega should be less than 1. So mode of e to the power minus 2 sigma, mode of e to the power minus 2j omega should be less than 1. This value is already 1. So this should be less than 1. So from there we draw a graph. Which kind of graph we draw? We draw a graph. From there we get to know that our sigma should be greater than 0. E to the power minus 2 sigma versus sigma graph we draw. So we know that our sigma should be greater than 0. So if our sigma is greater than 0, then this value will be less than 1. Okay. So our ROC is sigma greater than 0. So here I am writing down my final answer. This is the final answer with the ROC being real part of s greater than 0. Okay. Right. Now similarly what we are doing? We are just shifting the signal. Right. So let me call it some other signal zt. So I am calling this signal as zt. what you need to find ZS and ROC. So I have just shifted the signal. This is again right sided repetitive signal only. This is again your right sided signal which is repetitive, right sided signal. It is looking towards plus infinity, that means it is right sided signal plus repetitive. It is repeating signal which is looking towards the right side. Along with that, it is oscillatory as well. Or I should say, here I should mark that it is oscillatory. Oscillatory means at t equals to infinity, you cannot tell a finite value. Well and good, right? What should be its ROC? Sigma greater than 0 only. One thing you can think by the graph. If you multiply with this particular graph, what will happen? Here this guy will look like this, and then later on it will keep on decreasing. So yes, sigma greater than 0 will work for it. Or what you can think? What is your ZT? ZT is x of t plus 2 only. So if xt is having a ROC of r, so what will be the ROC of x of t plus t naught? That will also be r only. So shifting will not change the ROC. So it is not certain that the signal should start from t equals to 0 only. The signal can start from anywhere, but where it is oscillating, it is oscillating towards plus infinity. The signal is oscillating towards plus infinity. That means signal is oscillating in the right sided direction. Where the signal is oscillating towards plus infinity, right? So ZT is x of t plus 2, or you can say Z of s is e to the power 2s x of s. So whatever the answer you are getting, this would be your Z of s. So this is our Z of s. So I don't need to tell the answer. If this question is coming in the examination hall, what I will do? I will pick this one. Then what I will do? Same process I will repeat. Whatever the process I have repeated here, that same process I will repeat, and I will tell the x of s value. Or here it would be Z of s value. Right? Here what you would have done is that you could have told that your ZT is, if I say this is my YT, so my ZT would have been y of t plus 2 plus YT plus y of t minus 2, y of t minus 4. In that manner it will keep on going. So what would have been your Z of s? That would have been y of s into e to the power 2s plus y of s into 1 plus y of s e to the power minus 2s plus y of s e to the power minus 4s, and so on. So what would have been your Z of s from here? Z of s would have been y of s a upon 1 minus r. What is the value of r? E to the power 2s only. The same expression, okay, it is e to the power minus 2s, sorry, e to the power minus 2s. A is e to the power s, and what is the value of r here? E to the power minus 2s. So a upon 1 minus r. So this is the answer we are getting. Previously what was the, and this answer is equals to x of s into e to the power 2s only, right? And when you applied this particular formula, so with this formula you applied one more thing, that your sigma should be greater than 0, because when I was applying this formula, so from here I got this condition that my sigma should be greater than 0. So here also there is sigma greater than 0. So only conclusion is, if you have shifted the signal, that doesn't mean it will change anything, right? The ROC will be sigma greater than 0 only, just the final answer will change. The final answer will be e to the power 2s x of s. So Laplace transform will change, but the ROC remains the same. Now you let me know what will be the ROC for this one. Sigma less than 0, right? The ROC will be sigma less than 0. Very easily we can think. This graph you multiply, and this graph you multiply. So if I multiply the graph which is decaying in the minus infinity direction, so it will keep on decaying like this. That means this will become absolutely integrable. But here what will happen? Okay, both are the same graph, really sorry. But in this one what will happen? It will keep on increasing like this. So this is the graph for sigma greater than 0. This is the graph for sigma less than 0. So sigma less than 0 will work. So what will be the ROC? ROC will be sigma less than 0, right? Now you should be habitual that this much analysis you should be able to do on your own. So ROC will be, real part of s should be less than 0. So what is this? This is left sided signal. This is also oscillatory only, because at t equals to minus infinity, if I ask you at t equals to minus infinity, what is the value of xt? You will say, sir, I cannot tell. So this is the oscillatory graph only. right? So again, in the similar manner, we can find out its expression as well. What we will do, if we need to find out what is our x of s, if I need to find out the Laplace transform, then what we will do? We need to find y of t. This is our y of t. This is 1. This is y of t versus t, right? Now y of t is being repeated. So how you can write down your xt? Your xt is yt plus y of t minus 3 or t plus 3, right? Y of t plus 3, sorry, plus 2, really sorry guys. The center is at minus 1, which is shifted to minus 3. That means it is being shifted left. So here plus sign will come. Y of t plus 4 and so on. So x of s will be y of s plus e to the power 2s y of s plus e to the power 4s y of s and so on. So y of s is coming common, 1 plus e to the power 2s plus e to the power 4s and so on. So it would be 1 upon a minus r, where a is 1 and what is r? R is e to the power 2s. So this is your x of s. Right? No doubt about that. No issue. But the condition should be that mod of r should be less than 1. That means mod of e to the power 2s should be less than 1, which will be e to the power 2 sigma e to the power 2 j omega, mod here as well, and then mod here as well should be less than 1. This is already 1 only. So mod of e to the power 2 sigma should be less than 1. Can you draw the graph of e to the power 2 sigma versus sigma? Yes. At sigma equals to infinity, it will throw infinity only. At sigma equals to minus infinity, it will throw 0. So this kind of graph you will be getting, and at sigma equals to 0, the value will be 1. So if you want the value to be lesser than 1, that means sigma should be less than 0. So from here what you are getting, sigma should be less than 0. There you go. Now the only task is you need to find y of s. So let me copy this on the next page. The task is I need to find y of s. So can you find y of s? Previously I have just find out the expression for the inversion of this, right? This one. Just if I take the mirror image, I will get this particular expression. So if this is my y of s, if I know where is my y of s, if this is my y of s, then what would be my Laplace transform of this particular expression? Y of minus s. Say yes or no. If I call this as pt, so my pt is y of minus t for the previous example. Are you able to understand this point? Or forget about it? If directly this question is coming that yt is there, you need to find y of s. What you will do? You need to write down the expression of yt. So pause the video and write down the expression on your own. You need to write down the expression of yt in terms of rt, right? Because what is the slope here? Slope is minus 1. What is the slope here? Slope is plus 1. So you know how to write down the expression, right? So pause the video and write down the expression on your own. Here what will come? R of minus t will come. R of minus t part will come, right? Or from here as well I can write down the expression. Basically what will be your R of y of t? That would be R of t plus 2 slope of 1, then R of t minus 1, then plus 2r of t. Say yes or no? Oh sorry, not 2r of t, 1r of t only. Really sorry, r of t only. What did I do? Here the slope is plus 1. So r of t plus 2. Then the slope became minus 2. So slope became minus 1. At which point? At breakpoint of minus 1. So slope became minus 1. So plus 1 minus 2 will become minus 1. Then the slope became 0 at t equals to 0. So in the basics of signal we have seen it, right? So what would be your y of s? Y of s would have been, it would have been e to the power 2s upon s square minus 2 e to the power s upon s square plus 1 upon s square. So this would have been your pi of s, right? RT is having 1 by s square plus 2, RT is having 1 by s square plus 1 e to the power s, and RT is having 1 by s square only. So what would have been your x of s? X of s would have been e to the power 2s minus e to the power 2 e to the power s plus 1 divided by s square upon 1 minus e to the power 2s. Where will be the poles, 0, pole location, and all these kind of things you can do on your own, right? Pole 0, now I'm not gonna locate for you. Okay, so those poles and 0 you can locate on your own, because this much calculation we will have to do. Okay, so I told you the technique that s equals to 0 will surely be there, but s equals to 0 there is no confirmation, so we need to apply the L'Hopital rule. From here what we were getting plus minus j2 n pi, so plus minus j n pi I was getting, but again I got to know that at plus minus j2 and pi there was an issue, plus minus j2 pi, 4 pi, 6 pi, 8 pi, there was an issue, we were not getting it to be infinity, so those were not the poles. So here also did two same analysis you have to do. What you will do, you will put this equals to 0, so s equals to 0, and from here e to the power 2s equals to 1, so 2s will be equals to j2 n pi, that means s will be equals to j n pi. So now you will check at plus minus j pi, you will check at plus minus j2 pi, and you will check at s equals to plus minus 0 as well, and 0 is not plus minus, so you will check at 0 plus minus j pi plus minus j2 pi, and then you will tell whether at 0 there is a pole or not, at plus minus j pi there is a pole or not, and at plus minus j3 pi there is a pole or not. From here I can see that at plus minus j pi there will not be any issue, because at plus minus j pi what will happen, this will become 1, this will become plus 2, this will become minus 1, and downward it will be 0 only. So yeah, plus minus j2n plus 1 pi there will not be any issue. There could be an issue at what point? The issue will be there at one thing I can, yeah, it will also have the same poles and 0 only, because if this is, if this was our signal xt, now what is our signal? Now this is our signal, right? This is our signal, so we have just inverted the signal, nothing else. We have just inverted the signal. So previously if I was having a pole at j pi, now my pole will be at minus j pi, and previously if I was having a pole at minus j pi, now my pole will be at plus j pi. Previously if I was having a pole at 0, so now it will be at minus 0, which is equals to 0 only. Previously if I was having a pole at plus j3 pi, so I will have a pole at minus j3 pi, because I told you whatever the pole x of s will have, the x of minus s will have just the opposite pole, right? X of s plus 2, the pole is at minus 2, x of minus s plus 2, the pole is at plus 2. So previously what you got for the previous expression where xt was right sided, so for that you got the pole location at 0 plus j pi plus j3 pi plus j5 pi minus j pi minus j3 pi minus j5 pi. So here also you will get the same thing, plus j pi will be gone to minus j pi, plus j2 pi plus j3 pi will be gone to minus j3 pi, and minus j3 pi will be gone to plus j3 pi, minus j pi will be gone to plus j pi, right? So here also the pole location will be same only, right? So here also I can draw the this calculation and everything you can do on your own, but I can draw the diagram. Sigma j omega. Okay, so pole was at 0, there was a pole at minus j pi which has gone to plus j pi, plus j pi has gone to minus j pi, then there was at 3 pi minus 3 pi, and in that manner it will keep on going. Okay, so this was j3 pi, j pi 0 minus j pi minus 3 j pi, and in that manner it will keep on going. And why I am looking towards here? Because where my signal is looking? My signal is looking towards minus infinity, so this will also look towards minus infinity. So this is our ROC. Okay, and these are the location of poles. So all the poles I will join, and then I will draw the what I will do, all the poles I will join, and after that I will draw the ROC. Okay, so this is the x of s I am getting, and if I just shift it, what will happen? What is this? Let's call it PT. Let's call it PT. So what is your PT? PT is just shifted towards the right. So PT is just shifted x of t minus 2, nothing else. Okay. So here also ROC will be sigma greater, or here I should write. So here also the same thing will be happening. What will be your P of S? P of S will be x of s e to the power minus 2s, whatever the answer that you get. And what will be the ROC? ROC will be real part of s should be less than 0, because just by shifting the ROC will not change. And by the graph as well you can understand the same thing. How will you understand the same thing by the graph? That if I multiply this graph, then this part will be rising up, but the rest of the part will be slowing down. So sigma should be less than 0. If these are slowing down, that means this will become absolutely integrable, right? So this is also done. Now for periodic signal, can you let me know what will be the ROC, or will the Laplace transform converge? For periodic signal, will the Laplace transform converge? What will happen? If you multiply it with e to the power minus sigma t, okay, xt is being multiplied with e to the power minus sigma t, where sigma greater than 0 and sigma less than 0, two cases are there, right? What is the graph for sigma greater than 0? This is the graph for sigma greater than 0. And what is the graph for sigma less than 0? This is the graph for sigma less than 0. Now this graph is being multiplied with this graph. So what will happen to these parts? These parts will keep on decaying. These parts will keep on decaying. But here these parts will keep on rising up. Right? These will keep on rising up. So surely it is not absolutely integrable. What is this? This is your xt into e to the power minus sigma t. And what is this? This is also your xt into e to the power minus sigma t versus t. What do I see? This part will keep on rising up, although this part is being decayed, right? But this part is rising up. So this is both of the portion not absolutely integrable. So there is no such sigma possible, no such sigma possible for which x of s converge. So for a periodic signal, you cannot define the Laplace transform. Sine omega naught t, is it a periodic signal? Yes. Laplace transform is Laplace transform do not converge. Cos omega naught t, is it a periodic signal? Yes, does not converge. Sin omega naught t ut, is it a periodic signal? No. This is a repeating signal, right sided. Sin omega naught t ut, repeating signal, right sided. Sin omega naught t ut, somewhat like this. Repeating signal, right sided. What was the ROC? Real part of s greater than 0. Where do we go? Sin omega naught t ut. Sin omega naught t ut. Sin omega naught t ut. What it was? Right sided signal plus repeating. Right? So what was the ROC? Real part of s greater than 0. Sin omega naught t u of minus t. Repeating signal in the left side. Repeating signal in the left side, what was the ROC? Real part of s less than 0. So here also, what do we show? Repeating signal in the left side, what was the ROC? ROC was real part of s less than 0 only. So every dots are being connected now. Say yes or no. You are able to connect every single dot, right? How do we write down all these kind of things? Everything you are able to connect. And for periodic signal, Laplace transform do not converge. So statement 1, for periodic signal, Laplace transform do not converge. Yes, fine. Right sided signal which is repeating, that signal will be oscillatory. Along with that, the ROC will be real part of s greater than 0. Left-sided signal, which is repeating. So that signal will be oscillatory. Along with that, ROC is real part of s less than 0. By the graph, by the pole location, by every single thing, I am proving that the ROC will be real part of s greater than 0 or less than 0. So by any mean, you can understand that. And here also you can understand. Here also how you can understand that it can be broken into a right-sided signal which is repeating dot ut plus a left-sided signal which is repeating dot u of minus t. So this will throw sigma greater than 0 and this will throw sigma less than 0. What is the common portion? No common portion is there. We did that thing here, no? Sin omega naught t. What do we write down? Sin omega naught t ut plus sin omega naught t u of minus t. So sin omega naught t ut was throwing real part of s greater than 0 and sin omega naught t u of minus t was throwing real part of s less than 0. And there was no common part. What does that mean? There was no common ROC. That means Laplace transform does not converge. So for periodic signal, Laplace transform does not converge. Okay, well and good. So this we have seen for the repeating signal. We started with right-sided signal which was starting from t equals to 0, but it is not necessary that it will start from t equals to 0. It can start from any other point as well, but it is repeating in the right side direction. That means here the ROC will be real part of s greater than 0. Then we saw if it is repeating in the left side direction, it's not necessary that it will start from t equals to 0. It can start from anywhere, but if it is repeating in the left side direction, that means ROC will be real part of s less than 0. And if it is repeating in the both of the direction, if the signal is repeating in both of the direction, that means it is oscillatory in right sided as well, left sided as well. If it is oscillatory in both of the direction, what does that mean? That it will never converge. That means x of s will not be possible. I hope the conclusion of this discussion is clear to you. A very, very important discussion. What do you think? What will be the ROC of these signals? How you can break it? Finite duration plus finite amplitude, okay, plus shifted version of step, right? This much part will be finite duration plus finite amplitude. After that, this much part is step. So what this much part will say? This much part will say that ROC is entire S plane, and this much part will say that ROC is sigma greater than 0. So entire S plane, sigma greater than 0. What is the common part? Sigma greater than 0. That means what will be the ROC? Real part of S should be greater than 0. So here the ROC is real part of S should be greater than 0. Is this repeating signal? No. This is finite duration. Here the duration is ending. After that this is 0. Here also it is 0 only. So at t equals to plus infinity, at t equals to minus infinity, it is throwing 0 only. At plus infinity as well it is throwing 0. At minus infinity as well it is throwing 0. So this is a finite duration signal. So what it is? Finite duration plus finite amplitude. So ROC entire S plane. This is repeating signal, right sided signal which is repeating, right? So what will be the ROC? Real part of S greater than 0. What about this one? This is a finite duration plus finite amplitude signal. Along with that, it is a left sided signal which is repeating. Till this point it is finite duration plus finite amplitude. Till this particular point it is finite duration plus finite amplitude. After that what this is? Left sided signal which is repeating. So this will say that ROC should be entire S plane. What this will say? Left sided signal plus repeating signal. This should say that ROC would be real part of S less than 0. That means what will be the ROC? Real part of S less than 0. Those who are studying this subject for the second time, they will be able to appreciate that what kind of content it is, right? I hope those who are studying for the first time, they will not be able to appreciate this kind of content, but those who are studying for the second time, they would know that this much depth they will not be getting anywhere, right? So I hope you are enjoying it, and if you are enjoying it, if it is possible for you, then write down the message in the Telegram group that this kind of content is there in our platform. Although you have taken the paid course, that means surely you know the quality of this particular platform, but you try to write down in the Telegram group as well, that let people know that this kind of signal system can also be taught, because ROC is a very, very important thing. You should know that where your Laplace transform converges, because we study Laplace transform in our network analysis as well, in control system as well, in analog electronics as well, but in signal system only you actually get to know the depth of Laplace transform, right? So here you get to know that this is finite duration plus finite amplitude. This was saying entire S plane, but left side is signal which is repeating, that was saying real part of S should be less than 0. So this is the ROC, right? Because common part will be this only. What about this one? This is a finite duration signal plus shifted version of ut plus shifted version of u of minus t as well. What I am saying, this is your finite duration plus finite amplitude, one part, plus shifted ut, shifted step, shifted ut I will write down, plus shifted u of minus t as well. So this will say entire S plane. This will say sigma should be greater than 0, and this will say sigma should be less than 0. No common part. No common part. One is saying sigma greater than 0, one is saying sigma less than 0. If it was ending here, then I could have said that real part of S greater than 0. Or if it was ending here, then I could have said that real part of S less than 0. But it is being extended in both of the direction. So there is no common part. That means X of S does not converge. Right? I hope this content reaches more and more people. People should start trusting the platform, right? I hope they will trust the platform. Yeah. So this is your xt. Here this xt can be written as u of minus t plus e to the power t u of t, right? So here this will say that sigma should be less than 0. What this will say? Sigma should be greater than 1, right? Because the pole will be at 1, sigma should be greater than 1. No common ROC. No common ROC. That means Laplace transform does not converge. Here also I should have written no common ROC. You understood, right? E to the power t ut u of minus t. So this is saying that sigma should be less than 0. This is saying that sigma should be greater than 1. Right? So there is no common part. What about this one? This xt can be written as u of minus t plus e to the power minus t ut. So here sigma should be less than 0, and here sigma should be greater than minus 1. So less than 0, greater than minus 1. That means what is the ROC? So what is your region of convergence? From 0 to minus 1. So this is the ROC for this particular question, right? Now here there is conclusion of everything. So if there is finite duration signal plus a finite amplitude signal, finite duration plus finite amplitude is also necessary. So what will be the ROC? Entire S plane. Entire S plane. Now next what I am saying, a right sided signal which is neither decaying to 0 nor it is decaying to, nor it is shooting up to infinity. A right sided signal which is neither decaying to 0 nor it is shooting up to infinity. So it could be oscillatory, or it could be just like a step. This is a right sided signal which is neither decaying to 0 nor decaying to infinity. Are you able to understand this point? Or it could be this kind of signal, or it could be this kind of signal. A right sided signal, neither decaying to 0 nor shooting up to infinity. Right sided signal, neither decaying to 0 nor shooting up to infinity. Not right sided, not tri-sided. This is also not right sided. So right sided signal which is neither decaying to 0 nor shooting up to infinity, it could be oscillatory at infinity or having a non-zero constant value. So it could be oscillatory or it is having a non-zero constant value which is 1. Example, sin omega naught t ut, cos omega naught t u of t minus 1, like it could be shifted as well, or any right sided repeating signal with finite amplitude, anything it could be, right? So what is the ROC for all these kind of signals? Real part of s greater than 1. Sorry, real part of s greater than 0. Or you can say real part of s should be greater than 0. Although this conclusion and everything will not be used anywhere, but when you revise, you just need to revise this slide. So you will think, okay, right sided signal which is neither decaying to 0 nor shooting up to infinity, that means it could be UT, or it could be sinusoid signal, or it would be any signal with the finite amplitude, like this kind of signal. That means ROC will be real part of s greater than 0, right? A left sided signal which neither decays to 0 nor shoots up to infinity. A left sided signal which is neither decaying to 0 nor shooting up to infinity. Similar thing, whatever that I have written for the right sided, the same thing I have written for the left sided, nothing else. So real part of s should be less than 0. A both sided signal where none of the side decays to 0. A both sided signal where none of the side will be decaying to 0. Both sided signal, both are not decaying to 0. So what it may have constant value like this, basically xt equals to 1. So there was no common ROC, right? Or it could have something like this, no common ROC, or it could be oscillating in both of the direction, again no common ROC, right? So all the example I have written, sin omega naught t, cos omega naught t, 1 e to the power 2 mod of t, or any periodic signal, no common ROC. That means Laplace transform does not converge. What about this one? Rest all, like e to the power minus 2t ut. So it is right sided signal which is decaying to 0. E to the power 2t ut. Right sided signal which is shooting up to infinity. Right sided signal which is shooting up to infinity. So I never said that right sided signal shooting up to infinity, that means the ROC will not converge. No. A both sided signal which is not decaying to 0. A both sided signal which is not decaying to 0, that means Laplace transform will not converge. But a right sided signal which is shooting up to infinity, then Laplace transform may converge. And for e to the power 2t ut, Laplace transform converges for sigma greater than 2, right? So notice this point very clearly, that where Laplace transform will not converge, both sided signal which is not decaying to 0, it can have any constant value, it could be oscillatory, or it could be shooting up to infinity. A both sided signal which is not decaying to 0, a constant value it is having, or oscillatory value it is having, or it is shooting up to infinity. So there Laplace transform will not converge. But if there is only right sided signal which is not shooting up to, not decaying to 0, it is shooting up to infinity, but it is only left sided, at the right it is only right sided, at left side it is 0 only, but right sided it is shooting up to infinity, still Laplace transform will converge. Laplace transform may converge, right? Or it is a left sided signal, or it is a left sided signal where it is shooting up to infinity, then also your Laplace transform may converge. So only the condition where Laplace transform will not converge, that is both sided signal not decaying to 0. Here also you can see both sided signal, so it is not shooting up to infinity, no, it is having a constant value. This value could be 2, this value could also be 2. So it is having a constant value, but it is not decaying to 0. So a both sided signal which is not decaying to 0, there Laplace transform will not converge, right? But rest all the cases you need to do the analysis. And what is the analysis? Find poles, find pole, then what do? You see ut or u of minus t. So if there is u of t, that means you will look towards plus infinity, and if there is u of minus t, then you will look towards minus infinity. So is the concept of ROC being clear to you or not? So every single case I have taken in the examination, from tough to tough question may be asked, but it will not be asked apart from these cases. 100% guarantee I can take. And these I have taught after a lot of analysis. Otherwise, this repeating signal and non-repeating signal, these are taught in a very rough manner, no matter wherever you study from. Okay, but here every single case we are seeing, for every single case 2 to 3 method we are seeing. Like by the graph you can see, by finding the pole, or by any other condition also you can see, by breaking down into finite duration plus repeating signal, or finite duration plus shifted version of step. So in that manner we are going to see everything, right? Okay, so one point, this was the important point, that where Laplace transform will not converge, that being a both sided signal, it is not decaying down to 0. So surely your Laplace transform will not converge. The signal may be oscillatory, or it is tending towards infinity, or it is having a finite value. But if it is not tending, or it may have a finite non-zero value. Okay. So what kind of signal? A both-sided signal which is either oscillatory or having a constant value, or it is shooting up to infinity. But if it is decaying to zero, a both-sided signal, if it is decaying to zero, then Laplace transform will converge. Otherwise, it will not converge. Okay. And left-sided signal which is neither decaying to zero nor shooting up to infinity, having a constant value or oscillatory value, then real part of s less than zero. A right-sided signal which is neither decaying to zero nor it is shooting up to infinity, having a constant value or a oscillatory value, then real part of s greater than zero. Finite duration, finite amplitude, entire s plane. Okay. And for rest of these cases, like e to the power 2t, e to the power minus u of t, e to the power 2t sine of 3t. So for these cases, we have already seen it, right? For these cases, what do? You find out the pole, then you locate the pole location, then you look at ut and u of minus t, and based on that, you decide whether you will look towards a plus infinity or minus infinity, and based on that, you make your ROC, right? So this was a very good discussion on ROC, right? Now we will continue this discussion. The kind of discussion will move towards ROC only. Okay, so you need to find x of s, and then you need to tell the ROC. Okay, so a very good discussion will continue. So here as well, we will find out the Laplace transform of some standard signal, and in between we will see some properties as well. So again, we will find out Laplace transform of some standard signal only. So next video will be based on Laplace transform of these signals. Then what I will do, I will just shift these signals. Okay, just a shifted version of these signal. What kind of ROC you will get, what kind of a plane you will get. So from there as well, we will make a good conclusion. So these are not the question which will be asked in the examination hall, or it might be asked in the examination hall as well. But from here, whatever the conclusion we are going to make, that conclusion is very important. So let's meet in the next lecture. Thank you very much. Yeah, hi everyone. So now we need to solve this question. Solving this question is not important. You can solve it very easily, but the conclusion that we are going to make, that is important. So have some patience and solve it with me. So 4 questions are there. In this one question, 4 questions are there. For all of them, you need to find the Laplace transform. Along with that, you need to tell the ROC. So let's go with the A. So I need to find the Laplace transform. So e to the power 2t will have 1 upon s minus 2. E to the power minus 3t ut will have 1 upon s plus 3, and then there is a minus sign. Then e to the power minus t ut will have 1 upon s plus 1. 1 upon s plus 1, right? So we can solve it. S minus 2 into s plus 3 into s plus 1. I hope you know how to solve it. So s minus 2, so s plus 3 into s plus 1 minus s minus 2 into s plus 1 plus s minus 2 into s plus 3. So s square plus 4s plus 3 minus s square plus s plus 2. Basically here what would have become s square minus s minus 2. Because of this negative sign, it has become minus s square plus s plus 2 plus s square minus s square plus s minus 6, right? Yeah, and divided by s minus 2 into s plus 3 into s plus 1. So what we are getting, this and this is getting cancelled. So s square 4 5 6, s square plus 6s 3 plus 2 minus 1 divided by s minus 2 into s plus 3 into s plus 1. So this is the Laplace transform we are getting, s square plus 6s minus 1. I hope this is the same answer, s square plus 6s minus 1. Okay. Now what about the ROC? Since there is ut, so what this will say? Sigma should be greater than 2. What this will say? sigma should be greater than minus 3. And what this will say? Sigma should be greater than minus 1. So one is saying sigma should be greater than minus 1, sigma should be greater than minus 3, and this guy is saying that sigma should be greater than 2. So can you draw the pole 0 diagram? Can you draw the S-plane? If I draw the S-plane, this is how the S-plane would look like. There are 3 poles. There are 3 poles, minus 3, minus 1 and minus 3, minus 1 and plus 2. So from all the poles I am drawing a line. From all the poles I am drawing a line. So minus 3 is saying that this minus 3 guy, this is coming from UT. This minus 3 is also coming from UT only. So what it will say? It will say that look here. Right? What minus 1 will say? Minus 1 will also say that look towards plus infinity. And 2 will also say that look towards plus infinity only. So what is the common part? Common part is this one. So this is the final ROC. This is the common part. So this is your ROC. Your ROC is real part of S should be greater than 2. Okay. Another thing, can you let me know what kind of signal is that? Everything is UT, UT, UT. Right? Everything is UT, UT, UT. So surely it is right-sided signal, right? UT. That means they will be looking towards plus infinity. So surely it is right-sided signal. From where it is starting? For t less than 0, it is 0 only. Since UT will start from t equals to 0 or t greater than equals to 0. UT starts from t equals to 0. So for t less than 0, it is 0 only. That means it is causal signal as well. So it is right-sided and causal. Are you able to understand this point? Why it is right-sided? Because of UT. And why it is causal? Because it is starting from t equals to 0. Before that it is 0 only, right? What about this one? U of minus t, U of minus t, U of minus t. That means they will be looking towards minus infinity and minus infinity. That means it is left-sided. And from where it is starting? It is starting from t equals to 0 and it is going towards t equals to minus infinity. U of minus t. Starting from t equals to 0 and going towards minus infinity. That means here it is 0 only. So what does that mean? It is anti-causal. Now just let me know what about this one. There is u of minus t as well, there is u of minus t as well, and there is u of t as well. So some part will be here and some part will be here as well. U of minus t, u of plus t. So it is both sided signal. And if it is both sided signal, it has to be non-causal, right? Because for t greater than 0 as well it is non-zero, and for t less than 0 as well it is non-zero. What about this one? There is ut, there is u of minus t as well. So it is both sided. Along with that, it is non-causal as well. Okay, so all these conclusions will be used somewhere. So have some patience. Have some patience. By the end of this lecture, you will feel very, very good. Well and good. So for A, we have find out the transfer. For A, we have find out x of s. Along with that, we have plotted the ROC as well. For B as well, you will get the same x of s. Why is that so? What is the Laplace transform of e to the power 2t? 1 upon s minus 2. Then you will see there is u of minus t. So another extra sign should be there. So that is there. So e to the power 2t ut. So 1 upon s minus 2. Then e to the power minus 3t u of minus t. So 1 upon s plus 3. Because of u of minus t, another negative sign will come. So minus 1 upon s plus 3. Then here e to the power minus t u of minus t. Because of u of minus t, another negative sign should be there, which is already there. So plus 1 upon s plus 1. Are we getting the same thing? 1 upon s minus 2 minus 1 upon s plus 3 plus 1 upon s plus 1. So we will get the same thing. What is that? S square plus 6s minus 1. S square plus 6s minus 1. Divided by s minus 2 into s plus 3 into s plus 1. Just let me know what this will say. U of minus t. That means it will say that sigma should be less than 2. What it will say? Again u of minus t. In the next one as well there is u of minus t. So they will say that look towards minus infinity. So this will also say that sigma should be less than minus 3, and this will also say that sigma should be less than minus 1. So I will draw the same kind of diagram. Minus 3, minus 1, and then 2. Right. So sigma should be less than minus 3. Sigma should be less than minus 3. What minus 1 is saying? Sigma should be less than minus 1. Sigma should be less than minus 1. And what this 2 is saying? Sigma should be less than 2. So what is the common area? The common area is this one. This is the common area. Right. So this is the ROC. What is the ROC? ROC is sigma should be less than minus 3. There you go. This is the ROC. Here it was sigma should be greater than 2. Here it is sigma should be less than minus 3. Okay. Let's see the next one. Next one will also have the same transfer function, or you can say same x of s. It will also have the same x of s. So here what you will see, 1 upon s minus 2, e to the power minus 3t ut. So minus 1 upon s plus 3, and here e to the power minus t u of minus t. That means u of minus t is already having a negative sign, so plus 1 upon s plus 1. So same thing you will be getting. So in the C as well, you are getting the same thing. 1 upon s minus 3, sorry, 1 upon s minus 2 plus 1 upon s minus 2 minus 1 upon s plus 3 plus 1 upon s plus 1. So s square minus 6s plus 1. S minus 2 into s plus 3 into s plus 1. What is the first one? U of minus t. So what u of minus t will say? U of minus t. This will say that sigma should be less than 2. So yes or no? U of minus t is there. Pole is at 2. U of minus t is there. That means you should look towards minus infinity. So it will say sigma should be less than 2. What it will say? Sigma should be greater than minus 3. Right? This guy will say that sigma should be greater than minus 3 because it is coming from ut. It is coming from ut and it is coming from u of minus t. That means it will also say that sigma should be less than minus 1. Sigma should be less than minus 1. Okay. So let's see what is the common ROC, what is the common area. Minus 3 minus 1 plus 2. One is saying that sigma should be greater than minus 3, greater than minus 3. Right? Another one is saying that sigma should be less than minus 1. Sigma should be less than minus 1. Less than minus 1. And another one is saying that sigma should be less than 2. Sigma should be less than 2. Sigma should be less than 2. Less than 2. So what do you think, which is the common part where all three colors are there? All three colors are there in this part only. All three colors are there in this particular part only. So what is the common part? This is the common part. This is the common part. So this is the ROC here. This is the ROC between minus 3 to minus 1. Okay. So don't feel like that, sir, we are passing the time. No, we are going towards a very, very interesting conclusion, which is written in most of the textbook. That conclusion is written wrong. Along with that, it is understood wrong as well. So we are going towards a very, very important point and a very, very interesting conclusion. So that is very important actually. So that's why I want to spend some time here. Arey yaar. Now for the D option as well, you will get the same transfer function. Okay, so not transfer function, you will get the same Laplace transform, because here you can see that e to the power 2t u of minus t, then another negative sign is there, so plus 1 upon s plus 2, e to the power minus 3t ut, so minus 1 upon s plus 3, because there is already a negative sign, e to the power minus t ut, so plus 1 upon s plus 1. So same transfer function you will, same Laplace transform you will be getting, and that Laplace transform will be, so here I am writing down 1 upon s minus 2 minus 1 upon s plus 3 plus 1 upon s plus 1, and that will result in the same thing. What about the ROC? What this guy will say? From where it is coming? First, this one is coming from u of minus t, and rest all are coming from ut. So this will say that sigma should be less than 2. This will say that sigma should be greater than minus 3. And this is also coming from ut, so this will say that sigma should be greater than minus 1. So let's see what is the common part. Minus 3, minus 1, and 2. Sigma should be less than 2. Sigma should be less than 2. Sigma should be greater than minus 3. Greater than minus 3. And then sigma should be greater than minus 1. Greater than minus 1. So what do you think, which part is having all three colors? The middle one, right? So this is the ROC. This is the ROC. So what was ROC? ROC is between minus 1 to 2. Okay, so this is the first question we have solved. As of now, we are not drawing any conclusion. We are just writing down what we have seen. Just writing down. So this was the rational x of s we got. This was the rational Laplace transform we got, right? This Laplace transform was rational. So from this particular Laplace transform can get you 4 time domain signal. From this particular Laplace transform, you can get a 4 time domain signal, but with the different ROCs. First, let me know what this was. This was your right-sided signal. Along with that, it was causal, and its ROC was real part of s greater than 2. You can check for the first one, real part of s greater than 2. For the second one, it was left-sided signal. It was anti-causal, and its ROC was real part of s less than minus 3. You can check real part of s less than minus 3. This was a both sided signal, because there is u of t as well, u of minus t as well, and since it is both sided, it has to be non-causal, and its ROC was between 2 points. Those 2 points were minus 3 to minus 1. This was also both sided signal. It was also non-causal, and its ROC was between 2 points, that was minus 1 to 2. So as of now, we are not drawing any conclusion. We will see another question. After that, we will see another question, and then we will draw any conclusion. Okay. So one question, then another, and then another one. After that, we will draw the conclusion. But as of now, you let me know what kind of ROCs we got. 4 kind of ROC we got, right? Basically, there were 3 poles. There were 3 different poles. Minus 3, minus 1, and 2. 3 different poles were there, and then we can draw a line from all the poles. So one ROC was this one for the first question. The second ROC was this one for the second question. The third ROC was this one for the third question, and for the fourth question, this was the ROC. Can you ever get this kind of ROC? Can you ever get this kind of ROC? That it is between -3 to +2. Can you get this ROC? -3 to +2. Can you get this ROC? No, not possible. This kind of ROC is not possible. You try making any conclusion, you try making any case that I want this kind of ROC. Can you get -3 to +2? So what -3 will say? ROC should be looking towards this side. What 2 will say? ROC should be looking towards this side. So yes, common area we are getting. But what -1 will say? -1 will say that either ROC will look towards this side or ROC will look towards this side. So if it is saying that it should look towards this side, then this will be the region. And if -1 is saying that ROC should look towards this side, then this will be the region. So it can never happen that your ROC would be between -3 to 2. That means ROC can never include any pole. A very, very important conclusion. ROC is never including any pole. Till this point, what we used to write down? Real part of s greater than 2 or real part of s greater than -1. Whatever we used to write down. Here we used to write down greater than, not greater than equals to. Right? There was never a sign of greater than equals to. That means we were never including the pole in ROC. Now here, in this case, there are 3 poles. And in these 3 poles, we got 4 kind of ROC. And in none of the ROC, we are including any pole. Are we including any pole here? No. Are we including any pole here? No. Are we including any pole here? No. Then we thought that what if this kind of region is coming? So we tried making this region, but this is not possible. If this kind of region was possible, that means it would include a pole which is -1. But -1 is creating the problem which is not making this kind of ROC possible. So ROC never includes any pole. What I am saying, ROC never includes any pole. ROC may be bounded by the poles. ROC may be bounded by the poles. It will never include any pole. It may be bounded by the poles. Between -3 to -1, there is a ROC. So it is bounded by the poles. Between the poles. Between 1 to 2, there is a ROC. That means ROC is between 1 to 2. So ROC may be bounded by the poles, but it will never include any pole. Okay. So this is the only conclusion we have drawn from this particular question as of now. But after this, after going through this question, the next one, and after going through this particular question, we will draw more conclusions. Okay. So this slide will be very useful later on. Now in this question, what I am doing, the same examples are there. It is same as previous example, only there is a shift of 1. What I am saying, same as previous examples. With right shift, not right shift, it is left shift, right? It is left shift because +1 means it will be shifted left with the left shift of 1. And shifting will not change its ROC. What do I mean by that? E to the power 2t ut. Let's solve the first one. E to the power 2t ut will have Laplace transform of 1 upon s minus 2. E to the power 2t ut will have a Laplace transform of 1 upon s minus 2. But in place of t, you are putting t plus 1. That means e to the power s will also come. Next, e to the power minus 3t ut will have a Laplace transform of 1 upon s plus 3. But in place of t, you are putting t plus 1. Next one, e to the power minus t ut will have a Laplace transform of 1 upon s plus 1. But in place of t, you are putting t plus 1. Now what you are doing, you can take e to the power s common. What you will get? 1 upon s minus 2 plus 1 upon s plus 3 plus 1 upon s plus 1. So aren't you getting the same thing which we have got previously? Yes, we are getting the same thing. S square minus 6s plus 1 divided by s minus 2 into s plus 3 into s plus 1. Yes, we have got the same thing. Just e to the power s is the more factor, right? This e to the power s is extra. Now just let me know what this will say. Since it is coming from ut only, so it will say that ROC should be real part of s should be greater than 2. What this will say? Sigma should be greater than 3. And what this will say? Sigma should be greater than -1. So nothing is changing actually. ROC will be the same for the first one, second one, third one, fourth one. Whatever the ROC was there, everything is same. What is changing? What do you think? So just let me know one thing. Arey yaar. Just 1 second, guys. Is it a right-sided signal? Yes. Ut will always look towards plus infinity. So surely it is a right-sided signal. There is no doubt about that. Right-sided signal, right? U of t plus 1, u of t plus 1, u of t plus 1. That means it will be starting from -1 towards plus infinity only. So it is right-sided. Is it causal? No. It has become non-causal. What it is? It is a non-causal signal now. Right? This signal is non-causal. What about this one? Is it left-sided? Yes, u of minus t. U of minus t. U of minus t minus 1. That means it will be starting from -1 and it will be looking here. So u of minus t minus 1, u of minus t minus 1, u of minus t minus 1. Surely it is left-sided. Is it anti-causal? Yes, it is anti-causal for sure. It is anti-causal for sure. Why it is anti-causal? Because for t greater than 0, it is 0 only. For t greater than 0, it is 0 only, and that is the requirement for anti-causal signal. So yes, it is anti-causal for sure. What about this one? This is both sided. Both sided means u of minus t is also there and u of plus t is also there. So u of plus t means it will be looking towards plus infinity, u of minus t means it will be looking towards minus infinity. So yes, it is both sided, and if it is both sided, it has to be non-causal. This is also both sided and it is non-causal. So in this particular question, is there any causal signal? No. Why? Because of this e to the power s. This e to the power s, what it did. Previously we were happy with this one. We got causal, anti-causal and non-causal. In the previous question, we got causal, anti-causal and non-causal. But just as this e to the power s came into action, what it did? It just shifted the signal. Shifted the signal towards the left hand side. That means whatever the causal signal was there, that causal signal became non-causal. Anti-causal was shifted left hand side, there was no issue. If you shift the anti-causal signal towards the left hand side, it will remain anti-causal only. But if you shift a causal signal towards the left hand side, then it may become non-causal, and it became non-causal. So for the first one, what is the ROC? ROC is still the same. Sigma should be greater than 2. For the first one, ROC is still the same. For the second one as well, ROC will still be the same. Third one as well, ROC is same. Fourth one as well, ROC is same only. But their nature might be changing because of the shift, because of this e to the power s. So what I am saying, I will draw all the ROCs. From first one to everything, I will draw all the ROCs. -3, -1 and 2. Here -3, -1 and 2. -3, -1 and 2, -3, -1 and 2. So only the ROC I am drawing, nothing else. Okay. So here it would be greater than 2. Here it should be less than -3. For the third one, it would be in between, and the fourth one, it would be in between. So this was your A, B, C and D. So first one will say this is the ROC, second one will say this is the ROC, third one will say this is the ROC. Since it is bounded, that's why I am showing 2 arrows. No other region is there. Okay. Since it is bounded, that's why I am showing 2 arrows. Okay. So ROC did not get changed, but the nature of the signal got changed. So here what I am writing down. The first one, what is the ROC? Here I can write it down. First one, what is the ROC? Real part of S greater than 2. It is non-causal and it is right-sided. Second one, real part of S less than -3. It is anti-causal and it is left-sided. For both sided there is not much issue. ROC will be in the strip form. What this is known as? This is the strip form. Strip means it is like a strip means, what is the meaning of strip in Hindi? In Hindi we call it patti. Okay, it is in the strip form. Basically it is bounded. The ROC is bounded between two poles. So this is what we call strip form. So this is in the strip form. So here what was the ROC? ROC was between -3 to -1, being a non-causal signal which is both sided. And here where was the ROC? It was between -1 to 2, non-causal signal, and it was also both sided. Okay, now what I am doing, I am shifting it towards the right. What we are doing is that we are shifting it towards the right, nothing else, nothing new. In the previous question we shifted it towards the left, now we are shifting it towards the right. So just let me know what kind of signal is that. It is right sided, for sure it is right sided, because there is ut 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 u of t minus 1, that means it will be starting from 1 towards plus infinity. Surely it is right sided. Is it causal? Yes, it is causal only. Previously when ut was there, then also it was causal only. Now u of t minus 1 is there, that means you have shifted it towards the right hand side. That means causal will become causal will remain causal only. So yes, this is causal only, right? What about this one? Is it left sided? U of minus t plus 1, u of minus t plus 1, that means it will be starting from 1 towards minus infinity. So u of minus t plus 1, yes, it is left sided, for sure it is left sided. Left sided, left sided, left sided, for sure it is left sided. But is it anti causal? No, it is non causal, right? This has become non causal. Are you able to understand this point? And what about this one? This is both sided, because ut is also there, u of minus t is also there, u of t is also there. Since it is both sided, it has to be non causal. Why it became non causal? You understood, right? Why it became non causal? Because it is starting from 1. That means for t greater than 0 it is non zero, and for t less than 0 as well it is non zero. And this is also both sided and non causal. Here also everything is same. It is same like the previous example. What is the different thing? The different thing is just that I have introduced a shift t minus 1. What does that mean? That your x of s would be e to the power minus s, rest all is same, s square plus 6s minus 1 divided by s plus 3 s plus 1 into s minus 2. And from where it would have come? It would have come from 1 upon s plus 3, or should I write it down completely? Let's write down completely, x of s. So if e to the power 2t ut was there, that means it would throw 1 upon s minus 2. But since there is a shift of 1, so e to the power minus s. E to the power minus 3t ut was there, then it would throw 1 upon s plus 3. S plus 3. But there is a shift, so e to the power minus s would be there, and then there is a negative sign. Plus, what it would throw? 1 upon s plus 1, but there is a shift, right? So e to the power minus s is common. 1 upon s minus 2 minus 1 upon s plus 3 plus 1 upon s plus 1, right? So what kind of a transfer function you are getting? The same one, s square plus 6s minus 1 upon s minus 2 into s plus 3 into s plus 1. What about the ROC for this one? Since it is ut, so it will say sigma should be greater than 2. What this will say? Sigma should be greater than minus 3. And what this will say? Sigma should be greater than minus 1. So ROC did not get changed. Here also the ROC is sigma greater than 2 only. Total ROC is sigma greater than 2 only. ROC did not get changed, but the nature of the signal is changing, right? So I can make the ROCs again. How will I make the ROC? I will just guys, background noise is coming, so I have to pause the video. Background noise is there. ये पता नहीं किस बात का डीजे बज जाता है यार सुबह सुबह. एक तो मुश्किल से मैं सुबह उठना चालू किया हूँ और डीजे बजा देते हैं सुबह सुबह. Okay, so I have to pause the video. Yeah, welcome back. So this was our x of s and these were our ROCs, right? So this is the ROC of A, B, C, D. ROC did not get changed, but the nature of the signal got changed. So if I write down the conclusion from this particular irrational transfer function, okay, if I find out, this is known as inverse Laplace transform. What it is known as inverse Laplace transform. That means from Laplace transform you are going to xt. So four kind of xt you can get. What this was? This was a right-sided signal. Along with that, it was causal as well. Causal as well. With the ROC being real part of s greater than 2. Here what was the ROC? Real part of s less than -3. This was a left-sided signal for sure because of u of minus t, but it was non-causal. It was not anti-causal. What about this one? This was both-sided signal, and if it is a both-sided signal, it has to be non-causal for sure. There is no doubt about that. And what was the ROC? ROC was between -3 to -1, and here the ROC is between -1 to 2, being a both-sided signal and non-causal. Any doubt about that? So three kind of questions we have seen, right? So these were the poles. Now I'm not saying that this is -3, this is -2, this is 1, nothing like that. Three poles are there. If this is the region, what kind of regions are possible? This region is possible, or this region is possible. Let me use different color of pen. Basically, what kind of ROCs are possible, that I am telling. So this kind of ROC is possible, or this kind of ROC is possible, or this kind of ROC is possible. So these kind of ROCs are possible. These four ROCs are possible. Just let me know one thing from looking at all three questions. No matter whether you are having rational transfer function or irrational transfer function, this was always the right-sided signal. Look, if it is a right-sided signal, that means it would have come from ut, right? If it is a right-sided signal, it would have come from ut. It could come from u of t minus 1 as well. It could come from u of t plus 1 as well. U of t minus 1 will start from here, u of t plus 1 will start from here, and ut will start from here. If it is right-sided, surely it will be coming from ut, right? And what ut says? Ut says that your ROC should be looking towards plus infinity. So this guy will say that ROC should be looking here. This guy will say that ROC should be looking here, and this one will say that ROC should be looking here. So what is the common part? This is the common part. So for right-sided signal, this will be the ROC. Do you agree to this point? For right-sided signal, I am not saying causal. Again, have some patience. I did not say causal. I just said right-sided signal. For left-sided signal, this will be the ROC. Because left-sided signal could be coming from u of minus t, or it could come from u of minus t minus 1, or it could come from u of minus t plus 1. So u of minus t will be somewhat like this. U of minus t will be somewhat like this. U of minus t minus 1 will be somewhat like this, and u of minus t plus 1 will be somewhat like this. But all are left-sided. And if it is left-sided, if it is coming from u of minus t, so u of minus t will say this should be the ROC, this should be the ROC, and this should be the ROC. What is the common part? This is the common part. So no matter whether it is rational or irrational, whatever it is, this will result in rational. These two will be irrational. This will result in rational. These two will be irrational. Why they will be irrational? Because there is a shift. Since there is a shift, so what it will result in? E to the power minus s. What this will result in? E to the power s. What this will result in? E to the power minus s. And what this will result in? E to the power s. But surely it will be left-sided, surely it will be right-sided, and surely it is both-sided. Surely it is both-sided. And you can check as well. In all the questions you can check. For this one, C and D were both-sided. C and D were both-sided. For this one, C and D were both-sided. C and D were both-sided. Here as well, both-sided, and both. This is right-sided, this is left-sided, this is both-sided, and this is both-sided. So these were both-sided, this was also both-sided, this was right-sided, this was left-sided. So no matter whether your transfer function is rational or irrational, this diagram is always true. That if ROC is left to the leftmost plane, sorry, if ROC is left to the leftmost pole, if ROC is left to the leftmost pole, what is this? This is the leftmost pole. Leftmost pole. And what is this? This is rightmost pole. So if ROC is right to the rightmost pole, then the signal will be right sided for sure. And if ROC is left to the leftmost pole, then the signal will be left sided for sure. And if ROC is in the strip form, or you can say if ROC is bounded by two poles, that means it will be both sided for sure. No matter whether your transfer function is rational or irrational, whether your Laplace transform is rational or irrational, this is always true. And one more thing is also always true, that a both sided signal will surely be non-causal. So this region will be of non-causal for sure. This region will be of non-causal for sure. Is that true or not? A both sided signal will surely be non-causal, because both sided signal means it will be going towards plus infinity as well, it will be going towards minus infinity as well. That means it is non-zero for t greater than 0 as well, for t less than 0 as well. That means surely 100% both sided signal will be non-causal, no matter whether it is rational or irrational. You can see both sided signal non-causal, both sided signal non-causal. Here both sided signal non-causal, both sided signal non-causal. In the previous one as well, both sided signal here, both sided signal non-causal, both sided signal non-causal. So a both sided signal will surely be non-causal. It can be finite duration as well. What I am saying, a both sided signal can be finite duration as well. No, sorry, it cannot be finite duration, really sorry. A non-causal signal could be finite duration as well. A non-causal signal could be finite duration as well, but for finite duration, ROC should be entire S-plane. That means there should not be any pole. So if there are finite poles, if the poles are finite, that means you will be denoting it somewhat like this. If the poles are finite, then you will be denoting it somewhat like this: 1 pole, 2 pole, 3 poles. So if your ROC is right to the rightmost pole, then your signal will be right sided. And if your ROC is left to the leftmost pole, then your signal will be left sided. And if ROC is in the strip form, then it will be both sided. And if the signal is both sided, it has to be non-causal for sure. Till this point it is clear to you, right? So let me see if there is any rough work. Okay, so this was for combined rational and irrational. But if I talk about only rational, so left sided, right sided, both sided, all fine. And this is non-causal, this is also fine. This is non-causal, this is also fine. If your x of s is rational, that means there is no shift. If your x of s is rational, that means there is no shift. So in your inverse Laplace transform, that means from x of s, if you go from x of t, since there is no shift, so either you will get all ut or you will get all u of minus t. Are you able to understand this point? Basically, if it is rational, that means there is no e to the power s, e to the power minus s. And if there is no e to the power s, e to the power minus s, that means u of t plus 1, u of t minus 1, these kind of things are not possible. Basically, either you will have purely ut or you will have purely u of minus t. U of t plus 1, u of t minus 1, these things are not possible. Say yes or no. Right? Are you able to connect the dots? If it is a rational transfer function, if it is a rational x of s, then purely u of t and u of minus t you will be getting. Shift is not possible. What does that mean? That means that a right-sided signal will surely be a causal signal. If I say that I am getting ut only, I am getting ut only, everywhere I am getting ut only, that means the signal will be starting from 0 to infinity. That means for t less than 0, it will be surely 0 only. For t less than 0, it will be 0 only. Where does the problem come? The problem comes when you get u of t plus 1. When you get u of t plus 1, the problem arrives, because it will start from minus 1. And when you can get u of t plus 1, when your transfer function or when your x of s is irrational, that means e to the power s is there. But I am saying that your x of s is rational. I am saying that your Laplace transform is rational, that means e to the power s term is not there. If e to the power s term is not there, then you will purely get ut or you will purely get u of minus t. And if you are getting purely ut, that means a right-sided signal has to be causal for sure. A right-sided signal could be non-causal. A right-sided signal could be non-causal, but it could be non-causal when there is a shift. If there is no shift, what does that mean? It has to be causal. So this signal will be causal for sure. This signal will be causal for sure. There is no doubt about that. And whatever the scenario that I explained for causal, the same scenario will go for anti-causal as well. this side will be anti-causal. Because if your ROC is left to the leftmost pole, if your ROC is left to the leftmost pole, that means everywhere you are getting u of minus t, u of minus t, and u of minus t, right? And it is rational, that means there is no e to the power s, that means there is no shift. So u of minus t, u of minus t, u of minus t will ensure that the signal is left sided, that's for sure. But u of minus t will ensure that for t greater than 0 there is everything is 0. U of minus t will ensure that for t greater than 0 everything is 0. That means it will ensure that your signal is anti-causal. Is that true or not? So this particular diagram is true for rational x of s. This particular diagram is true for rational x of s, and this particular diagram, let me erase it all. This particular diagram is true for rational or irrational x of s. Now what will happen in irrational x of s? Both sided signal will surely be non-causal, there is no doubt about that. Both sided signal will surely be non-causal, there is no doubt about that. But is it necessary that this part will be causal only? Is it necessary that this part will be causal only? Because now your x of s is irrational. That means there could be a term of e to the power s. And what e to the power s will do? What this part will result in? This part will result in ut only. This part will result in ut only. Since there is e to the power s, that means this ut will be changed to u of t plus 1, u of t plus 1, u of t plus 1. And what does that mean? It will be starting from minus 1. And this causal, which ut was supposed to be causal, but because of this shift, it has become u of t plus 1. Now this has become non-causal. So this part will either throw causal or it will throw non-causal. Are you able to understand this point? So this part will either throw causal or it will throw non-causal. Everything you can verify with these examples. With these three examples, everything you can verify. What this was? This was your right-sided signal. This was your left-sided signal. This was your both-sided signal. This was your both-sided signal. They were surely non-causal. This was surely non-causal. But here you can see that A was causal, but B was not anti-causal. This was supposed to be anti-causal, but this became non-causal. This was supposed to be causal, but it became causal only. Why is that so? This remained causal only. What is the reason behind that? Because the shift was u of t minus 1. The shift was u of t minus 1. That means it was shifted ahead. It was shifted towards the right hand side. So causal became causal only. But in the previous question, what really happened? This was supposed to be causal. This was right-sided signal, which was supposed to be causal, but it became non-causal. Why is that so? Because there was a right shift. Because there was a right shift. Sorry, because there was a left shift. Shift was left. That means ut went to u of t plus 1. That means starting point became minus 1. So it was supposed to be causal, but it became non-causal. This anti-causal remained anti-causal only. This anti-causal remained anti-causal only. What about this one? This was non-causal only. This was left-sided. This was both-sided. This was also both-sided. And this was also non-causal. But in the first one, what was the scene? Everything was ut, or it was u of minus t, u of minus t. So you are getting causal as well, you are getting anti-causal as well, you are getting non-causal as well, and you non-causal as well. So here, what was the scenario? This was both-sided. Since this was both-sided, this was non-causal. Here I can write down. Here I can write down. This was non-causal. This was non-causal. This was causal. And this was anti-causal. Right? This was both-sided. This was also both-sided. This was right-sided. And this was left-sided. Are you able to understand this point? Okay, well and good. So are you able to relate everything? Everything should be there in front of you in the notes, and you should be able to relate all the things. These things are very, very confusing. Okay, people just mug up that right to the rightmost pole, then it will be right-sided signal and it will be causal. No, it is not necessary that it will be causal. It can be causal or non-causal. And if your ROC is left to the leftmost pole, certainly it will be a left-sided signal, but it is not necessary that it will be anti-causal. It can be anti-causal or it would be non-causal. So do you remember our first lecture now? In the first lecture, what did we show? That there was an anti-causal signal, and then I asked you, can you make this anti-causal as non-causal just by introducing some shift? Then you said that yes, if I introduce a right shift, then an anti-causal signal will become non-causal. But then I said that there is a both-sided non-causal signal. There is a both-sided non-causal signal. Can you anyhow make it causal or anti-causal? No. This can never go to causal or anti-causal no matter whatever the shift you introduce. A both-sided signal can never go to causal or anti-causal no matter whatever the shift you introduce, because both-sided signal means it will be going to as plus infinity as well, minus infinity as well. So no matter whatever the shift you do, it will surely go to plus infinity and minus infinity. So both-sided signal will surely be non-causal no matter whether you are having a rational transfer function or irrational x of s. But a right-sided signal can be non-causal. A right-sided signal surely will be causal. That is wrong. It can be non-causal. Why is that so? Because of the shift. So if there is irrational x of s, then a right-sided signal could be non-causal as well. And if there is irrational x of s, then your left-sided signal can also be non-causal as well. But if there is rational, then surely right-sided signal will be causal and left-sided signal will be anti-causal. So conclusion is very, very short. A very short conclusion is there, right? These three diagrams are the only conclusion. So within 5 minutes, you will be able to revise everything. We took 50 minutes of the discussion, but within 5 minutes, you will be able to revise everything. And based on that, we have made a true and false. So these true and false tables are there. You let me know which statement is true, which statement is false. So for a causal signal, which is having finite poles, that means it is not a finite duration signal. For a finite duration signal, you have seen that there is no finite pole. The poles will be at infinity or minus infinity. So it is surely not a finite duration signal. So a causal signal, when I say causal signal, first statement, whenever I say causal signal, what should click in your mind? Causal signal. So causal signal could be of two types. Either it could be right-sided or it could be finite duration plus finite amplitude. Is there any other type possible? No. Either it could be right-sided or it could be finite duration and finite amplitude. So this option is gone, finite duration and finite amplitude. This option is gone, only right-sided signal option is left. So a causal signal which is right-sided, this is what they want to write. A causal signal which is right-sided, then the ROC must be right to the rightmost pole. So yes, for a right-sided signal, ROC will be right to the rightmost pole. There is no doubt about that. No matter whether your Laplace transform is rational or irrational. They are not talking about the nature of Laplace transform. They are simply saying that if causal signal is there, which is having finite poles, then the ROC has to be right to the rightmost pole. Yes, there is no doubt about that. Someone will say that, sir, it is not necessary that this part will be causal. Yes, it is not necessary, but they are saying that it is causal. They are saying that it is causal. So if it is causal, then causal can lie in this region only. The point is, this region could be causal or non-causal. But if I am saying that it is causal, that means causal has to lie in this region. Causal can never lie here, causal can never lie here, causal can never lie here. You can see all three diagrams. Causal can never lie here, here or here. Because if causal is there, then it has to lie here. Right? Are you able to understand this point? So for a causal signal which is having finite poles, the ROC must be right to the rightmost pole. Yes. Did you understand the difference? Read this statement. If ROC is right to the rightmost pole, then the signal must be causal. This is wrong. A and C. If ROC is right to the rightmost pole, then it is not necessary that it would be causal, because in case of irrational x of s, it can become non-causal as well because of the shift. Right? But if someone says that for a rational x of s, for a rational transfer function, for a rational Laplace transform, if the ROC is right to the rightmost pole, then the signal has to be causal, then this statement would be correct. But here they did not talk about the nature of Laplace transform. So if they are not talking about the nature of Laplace transform, that means I have to consider both of the cases. What both of the cases? Rational and irrational. So for the rational, it would be correct, but for the irrational, it would be wrong. Right? Right to the rightmost pole. Right to the rightmost pole. So surely the signal will be right-sided. If the ROC is right to the rightmost pole, surely the signal is right-sided. Signal is right-sided signal. But right-sided signal could be causal as well, it could be non-causal as well. Right-sided signal could be causal as well, it could be non-causal as well. So both of the possibilities are there. Right? So this statement is wrong. Same goes for this statement as well. If ROC is left to the leftmost pole, then the signal has to be anti-causal. No. If ROC is left to the leftmost pole, that means the signal is left-sided signal, but two possibilities are there. Either it could be anti-causal or it could be non-causal. So two possibilities are there. It is not necessary that it will be Anti-causal only. What about this one? For anti-causal signal which is having finite poles. For anti-causal signal, right to the rightmost pole. B. Anti-causal. Whenever I say anti-causal signal, what should click into my mind? Anti-causal signal. So what should click into my mind? That anti-causal signal will be left-sided signal, or it could be finite duration plus finite amplitude. So what I will say, if it is a left-sided signal, that means it would be left to the leftmost pole. And this possibility is not there. Why it is not there? Because it is having a finite poles. So it is an anti-causal signal which is left-sided. That means ROC will be left to the leftmost pole. This statement is true. Now read this one. If ROC is in the strip form, then the signal has to be both sided and non-causal. Yes. If ROC is in the strip form, then signal has to be both sided and non-causal. If the ROC is in the strip form, then the signal has to be both sided and non-causal. If the ROC is in the strip form, then the signal has to be both sided and non-causal. So no doubt about that. If the signal is non-causal, then the ROC has to be in the strip form. This statement is wrong. If signal is non-causal, if the signal is non-causal, the ROC has to be in the strip form. No. Here also you can get the non-causal signal. No. Here also you can get the non-causal signal. This statement would have been correct for rational Laplace transform. If your Laplace transform is rational, then if the signal is non-causal, what I am saying, if your Laplace transform is rational and if the signal is non-causal, then the ROC will be in the strip form. So this statement would have been true for a rational x of s. So here if it was written that for a rational Laplace transform, if the signal is non-causal, the ROC has to be in the strip form. Yes, that was true, but for generalization it is not true. And the last one, this is true only. For right-sided signal, ROC will be right to the rightmost pole. For left-sided, it will be left to the leftmost pole. And for both-sided, it will be in the strip form. So is this discussion clear to you? Roughly around 1 hour we have spent on this discussion, which is very, very, very important. And a lot of people either try to mug it up or they read it wrong or they study it wrong. Okay. So they will just mug up some method that this is how we will solve the problem. But these methods will not work in the examination. So rather than going for the methods, we should be conceptually clear that from x of s, let's go here. From x of s, if it is irrational, then I have to see the shift. If this was not there, then I would have got causal signal as well, non-causal signal as well, and anti-causal signal as well. But e to the power minus s is there. That means t minus 1 will be there. Ut will be changed to t minus 1. That means whatever the ut was there, that will be shifted towards the right. So it will not change my causality, but my anti-causality will be disturbed. So anti-causal will become non-causal. Since there is e to the power s, so it will shift u of t plus 1. That means it will be shifted towards the right hand side. So it will disturb my causality. So causal will become non-causal. And if there is no shift, that means if there is rational transfer function, then purely I will get causal, anti-causal and non-causal. And every conclusion is there in these 3 slides. In which 3 slides? In these 3 slides. So this slide will work for both rational and irrational. That if the signal is both sided, then it has to be non-causal. If it is right sided, then it has to be right to the rightmost pole. And if it is left sided, then ROC has to be left to the leftmost pole. But if the rational x of s is there, that means if ROC is right to the rightmost pole, that means the signal has to be causal. If ROC is left to the leftmost pole, then the signal has to be anti-causal. And if the ROC is in the strip form, or you can say if the signal is both sided, then it has to be non-causal. For irrational x of s, for irrational Laplace transform, if the ROC is both sided, then it has to be non-causal. There is no doubt about that. But if there is a right-sided signal, so this right-sided signal could be causal or non-causal both. And if there is left-sided signal, so this left-sided signal could be anti-causal or non-causal both. So complete conclusion is clear to you. So you can again rewatch the part. I would not say rewatch the part, but you revise the notes, whatever that we have studied in this particular 1 hour. Okay. So this is the conclusion. Let's move to the next topic. Here we study about LTI system. Okay. So whatever we were discussing for x of t, the same thing we are going to discuss for h of t as well. If I say my h of t is absolutely integrable, so what you can say? Your LTI system is stable. Do you remember? Do you remember the second chapter? Systems. So there we talked about LTI system. For LTI system, yt is equals to xt convolution ht. So LTI system could be stable, unstable, causal or non-causal. If LTI system is stable, or we used to call it BIBO stable, bounded input, bounded output stable. So if your LTI system is stable, that means ht has to be absolutely integrable. Has to be absolutely integrable. That means ROC of h of s, ROC of h of s has to include j omega axis. Say yes or no. And it will be unstable otherwise. Or you can say, if ROC of x of s does not include, ROC of h of s does not include j omega axis. Look, we are not studying anything new. What will be given in the examination hall? They can give you HT. They can give you that impulse response of an LTI system. HT is given as this. HT is given as e to the power minus 2t ut. You let me know whether it is a stable system or not. So one thing you can do, that you can calculate its this value. You can calculate its area, mode of ht dot dt you can calculate. Then you will find that it is less than infinity or it is a finite value, so you can say it is absolutely integrable. Or what you can do, you find its Laplace transform 1 upon s plus 2. What is the ROC? Real part of s greater than minus 2. Real part of s greater than minus 2. So it is including the j omega axis. That means yes, it is absolutely integrable. And if it is absolutely integrable, that means your LTI system is stable. So we have studied everything, just we are writing down with respect to LTI system, nothing else. And there were two kind of systems, right? Causal system and non-causal system. There were two kind of systems, causal systems and non-causal system, right? There is nothing called anti-causal system. There is nothing called anti-causal system, right? This is not correct. Basically, signal could be of three type. Signals are of three type. Signals: causal, non-causal, anti-causal. Causal, non-causal and anti-causal. So all three types are there, right? But what about the systems? System was of two type only. System was of two type only: causal or non-causal. So what was the condition for getting a causal system? If your LTI system is causal, then what was the condition on h of t? That h of t has to be a causal signal. H of t has to be a causal signal. And if the signal is non-causal system, sorry, if the h of t is non-causal system, then h of t could be anti-causal or non-causal signal. Look, h of t is not a signal. I know that h of t is not a signal, right? H of t is an impulse response of LTI system. This I told you, h of t is not a signal. But for causal system, if you remember, we derived one condition. Which condition we derived? That h of t should throw 0 for t less than 0. If this is the condition that is satisfied, that means your LTI system will be causal. Do you remember this condition? That if your h of t is 0 for t less than 0, that means if your h of t is causal signal, I said that it is kind of causal signal, right? So if your h of t is a causal signal, that means your LTI system will be causal. And if your h of t will throw a non-zero value for t less than 0, that means h of t can throw non-zero value for t less than 0. So h of t could be somewhat like this, or h of t could be somewhat like this, or h of t could be somewhat like this as well. It could be anything, right? Or h of t could be somewhat like this as well. So this is anti-causal, this is non-causal, this is non-causal, this is non-causal. But h of t cannot be causal. So all these things we have already seen in our chapter 2. In chapter 2, I said that the LTI system will be stable if your h of t is absolutely integrable. That means ROC of h of s should include j omega axis. and it will be unstable if ROC of H of S doesn't include j omega axis. Now LTI system will be a causal system. LTI system will be a causal system. It's if H of t is 0 for t less than 0, or you can say H of t is a causal signal, right? And your LTI system will be a non-causal signal if your H of t is anti-causal or non-causal. I hope you remember this discussion. Okay, this is something that I am picking up right from the chapter 2. Nothing new we are writing down here. So if you are forgetting it, that means you did not revise the chapter 2. In chapter 2, this is what I said. For causal system, H of t has to be a causal signal, otherwise it will be a non-causal system. So this is how you need to remember, that if H of t is a causal signal, then your LTI system will be causal, otherwise it will be non-causal. That's it. Okay, so based on that we will see some questions. So this question is there, a very good question. Have some patience and try solving it. Impulse response of an LTI system is ht. Ht is having a Laplace transform of H of S. The pole location for H of S is given in the S plane. These are the pole location. Now true or false you have to tell. If the system is causal, it has to be unstable. So if the system is causal, the ROC has to be right to the rightmost pole. If I am saying the first one, if I am saying, okay, let's take it to the next page. First one, A. What they are saying? If the system is causal, then where will be the ROC? ROC has to be this one. Now if I say if this is my ROC, then the system has to be causal. Is this statement true? If this is my ROC, then the system has to be causal. No, this statement is wrong. Because if this is the ROC, then system could be causal or non-causal. But if I am saying that my system, then I am saying that my signal is causal, then this has to be ROC. Yes. So if the signal is causal, then there is only one case, which is this case, right? What I am saying, if my H of t is causal, then there is only one case, which is this case. But this case does not guarantee that it will be causal only. This could be non-causal as well. But if I am saying that it is causal, then there could be only one case. So this could be the only one case. And if this is the case, that means ROC does not include j omega axis. Include j omega axis. That means H of t is not absolutely integrable. And what does that mean? LTI system unstable for sure. So first statement is true. If the system is anti-causal, it has to be unstable. If the system is anti-causal, this is the scenario. If the system is anti-causal, so if the system is anti-causal, it has to be left-sided and it has to be the ROC. Now if this is the ROC, does it guarantee that the system will be, or if this is the ROC, does this guarantee that the signal will be anti-causal only? No. But if I am saying that signal is anti-causal, this is the user is saying that signal is anti-causal, that means this has to be the ROC. So this has to be the ROC for anti-causal signal. It could be anti-causal or it could be non-causal as well. But if I am saying that it is anti-causal, then this has to be ROC, there is no other way. If I am saying that my signal is causal, then this has to be the ROC, there is no other way. So if this is the ROC, what does that mean? ROC does not include j omega axis, H of t is not absolutely integrable, and LTI system is unstable. So for both A and B, statement is true. If the system is stable, then it has to be non-causal. If the system is stable, that means ROC should include j omega axis. If the system is stable, then the ROC should include j omega axis. If I say this is my ROC, then ROC is not including j omega axis. So they are not talking about this particular thing. They are talking about the stable system. Stable system means H of t should be absolutely integrable. H of t absolutely integrable means the ROC of H of S should include j omega axis. So they are talking about this particular region, and this particular region shows that it is both sided, along with that it is non-causal as well. So if the system is stable, it has to be non-causal, no doubt about that. Next statement, if the system is non-causal, it has to be stable. No, this is a non-causal system, this is also a non-causal system. Okay, I am writing if the system is anti-causal. There is nothing called anti-causal system, no. So this statement does not make any sense. If h of t is anti-causal, then system has to be unstable. So this statement makes any sense, that if h of t is anti-causal, then the system has to be unstable. Then this statement would make sense, otherwise it would not make any sense, because there is nothing called anti-causal system, right? So systems are of two types only, causal or non-causal system. Signals are of three types: causal, anti-causal and non-causal. So if the system is stable, it has to be non-causal, yes. If the system is stable, it has to be non-causal. But if the system is non-causal, then it has to be stable, no, because this part will also result in non-causal system. What this part will result in? This part will also result in non-causal system. Non-causal system, mark this word, system. An anti-causal signal will be a non-causal system only. If I say h of t is anti-causal, if I say h of t is anti-causal, what does that mean? That means LTI system will be non-causal. Do you agree to this statement? Surely yes, because here I have written that for non-causal system h of t could be anti-causal or non-causal. So if I say h of t is anti-causal, that means LTI system will be non-causal. So this part will be in non-causal system only. So this part will also say that my system is non-causal, it is also not stable. This part will also say that my system is non-causal, it is also unstable. This part will say that my system is non-causal, but it is stable. So if the system is stable, it has to be non-causal. But if the system is non-causal, it doesn't mean it will be surely stable. Is that statement clear to you? So this statement is wrong. So I hope you would have got everything. If you are listening to the discussion carefully, then you will be able to understand. Otherwise, if you are studying it on a surface level, then nothing will be clear to you. Okay? And these kind of good questions, at least I will frame, and surely IIT can also frame. You might not find these kind of questions in some other test series, but in our test series, you will find tougher questions than this. I would not say tougher, it will require your brain and actual understanding. If there is no actual understanding, if you are just mugging up the things that right-sided right to the rightmost pole, left-sided left to the leftmost pole, right-sided means causal only, left-sided means anti-causal only, strip means non-causal only. So that means you are just mugging up the things on the surface level. But rational, irrational, both of the cases you need to take. In irrational case, what may happen, those things you should be clear. And if you are clear with all those things, then there is no chance that you will be struggling in these kind of questions. Surely you will be able to understand these kind of questions. Right? Let's go to the next one. क्या भाई ये सवाल आधा रहेगा क्या? This question is not even there. Okay, I guess this is the correct question. Which of the following statements are true? Again I am writing for an LTI, for an anti-causal LTI system to be stable, there is nothing called anti-causal LTI system, it would be non-causal. Okay, so let's see the first statement. For a causal LTI system to be stable, all the poles should lie in the left half of S-plane. What I am saying, causal LTI system, causal LTI system, causal LTI system. Causal LTI system means h of t should be causal. And if I say h of t is a causal signal, if I say h of t is a causal signal, what does that mean? It will be right sided, or it could be finite duration plus finite amplitude. This condition is gone. Why is that so? Because if it is finite duration and finite amplitude, then there should be no finite pole. But they are saying that there is finite poles. All the poles should lie in the left half of S plane. So let's check that. If I am saying that one pole is lying here and two poles are lying here, and if it is a causal LTI system, that means it has to be right sided, and right sided means ROC will be right to the rightmost pole. Right to the rightmost pole. That means where will be the ROC? The ROC will be here. That means it will result in unstable. unstable system. But if this pole was here, what I mean to say, if all the poles were in the left half of S-plane, all the poles were in the left half of S-plane, then where will be the ROC? Right to the rightmost pole. Which is the rightmost pole? This is the rightmost pole. And where will be the ROC? This will be the ROC. So if this is the ROC, what does that mean? Yes, it is stable. So statement 1, true. For a anti-causal LTI system, for a non-causal LTI system, all the poles should lie in the right half of S-plane. This is also wrong. Why is that so? Sorry, this is correct, this will be wrong. For a non-causal LTI system, non-causal LTI system, non-causal LTI system, what is the meaning of that? That H of t could be either non-causal or it could be anti-causal as well. Two possibilities are there, no? If I say for a non-causal LTI system, for a non-causal LTI system, that means H of t could be non-causal or anti-causal. If it is non-causal, so from non-causal, what do you understand? That it could be right-sided. Non-causal signal could be right-sided as well. Non-causal signal could be left-sided as well. Non-causal signal could be both-sided as well. So it could be right-sided, left-sided, both-sided, or it could be finite duration plus finite amplitude. This option is gone because finite duration and finite amplitude will not have any pole, but they are talking about the pole. And what about anti-causal? Anti-causal means the signal could be either left-sided or it could be finite duration, finite amplitude. So finite duration plus finite amplitude, this probability is gone. Now what do you want? You want the system to be stable. You want the system to be stable. What they are saying? All the poles should lie in the right half of S-plane. It is not necessary. Two poles are lying in the right half of the S-plane and one pole is lying here. What I will do now? What I will do now? If I say this is my ROC, if I say this is my ROC, what does this show? That it is a both-sided signal. Along with that, it is non-causal. If I say this is my ROC, what I am saying, if I say this is my ROC, so is it stable? Yes, it is stable. That means it is stable. Along with that, it is non-causal. So it is a non-causal system which is stable. And where are the poles lying? One of the pole is lying in the left half of S-plane. So this statement is wrong. So for a causal LTI system, if you want it to be stable, then all the poles should be lying in the left half of S-plane. But for a non-causal LTI system, there is no condition like that. In control systems, in a control system or in network analysis as well, all the systems are non-causal. Sorry, all the systems are causal. When you study control system, there also you will use Laplace transform. But there all the systems will be causal only. Every system, all the practical systems are causal only. Practically realizable system. If you are making any system with RC circuit or anything, all these systems will be causal only. And every practical realizable system is causal. So in control systems, you always study causal systems only. Right? So there we write down this line that if your system is stable, then all the poles should lie in the left half of S-plane. So that line is actually not completely true. But for control system purpose, that line is true. Why is that so? Because in control system, we are studying LTI system only, which are causal. So by default in the control system, you are studying LTI system which are causal. Okay, so in control system, what do we write down? We write down in a line that for a stable system, what do we say? For a stable system, we neither say LTI system, we nor say causal LTI system, nothing we say, for a causal system, because in control systems, the word system shows that it is causal LTI. Causal LTI. The word system will show that it is a causal LTI system. So there we say that for a system to be stable, all the poles should lie in the left half of S-plane. Why is that so? Because that is a causal LTI system. And if it is a causal LTI system, then the ROC will be right to the rightmost pole. And if ROC is right to the rightmost pole, what does that mean? That the pole has to lie in the left half of S-plane so that it should include the j omega axis. ROC should include the j omega axis. But for non-causal system, there is no condition like that. because in the non-causal system your h of t could be non-causal as well or it would be anti-causal as well. So if it is non-causal, then you can see that ROC is including the j omega axis with the pole being in the left half of S-plane as well, right? Let's see the statement third. ROC never include any pole. ROC may be bounded by the poles. This we have already seen, right? Where we saw it? We saw it here in the conclusion here. The ROC will never include any pole. It may be bounded by the poles. It is never including any pole. Never including any pole. Never including any pole. It will be bounded by the poles. So this statement we have seen. Now the next one you will think on your own. Next statement. Okay. Where is the next statement? Okay, this line was, this question is left. We will solve this question. This question is left. We are directly solving this question. This question is left. So we will solve this question. Okay, no need to worry about that. But as of now, you will solve this question. That for an LTI, for an oscillatory real signal xt, the pole of x of s will be complex conjugate. Is this statement true? And if it is true, then think about it. Oscillatory signals you know, right? Sin omega naught t, cos omega naught t, sin omega naught t ut, cos omega naught t ut, e to the power minus 2t sin omega naught t ut. All these are oscillatory signal. Then where will the poles of x of s will be lying, and they will be complex conjugate or not. So this you will prove on your own. I will take a pause and then I will come back. We will solve this particular option. For this particular option, we will take a lot of examples and then we will prove this particular option. And after that, we will solve this question which was left. And after that, we need to solve another problem, which is this one. Okay, so I will take a pause and then I will come back. I guess it would take roughly around 30 minutes more for this discussion. Okay, thank you. Yeah, welcome back, guys. So did you try the option D? Look, what do you mean by oscillatory signal? So let's take some example. Sin omega naught t, sin omega naught t ut. Is this a oscillatory signal? Yes. Can you draw the graph? Surely I can draw the graph. So they are only saying oscillatory signal. They are not saying it has to be stable. No. What did they say? For a oscillatory real signal, the poles will be complex conjugate. Right? So sin omega naught t ut. This will be the graph. So is it oscillatory? Yes. Oscillations are there, no? From 0 to 1, then 1 to 0, 0 to minus 1, minus 1 to 0, 0 to 1, 1 to minus 1 to 0, 0 to minus 1. In that manner, there are constant oscillations in this particular signal. You know that it is not stable for sure, right? It is not stable. It is not absolutely integrable. So the LTI system will not be stable. If this is your impulse response, then the LTI system will not be stable. That means you can say that this particular signal ft is not absolutely integrable for sure. But this is surely oscillatory, right? We are not talking about hair stable or anything like that, but we are just talking about whether it is oscillatory or not oscillatory. So surely it is oscillatory, right? Now what is your f of s? F of s is omega naught upon s square plus omega naught square. So where are the poles? Poles are plus minus j omega naught. This we have already seen. Plus minus j omega naught. So these are the poles. Are they complex conjugate? What do you mean by complex conjugate? 2 plus 3j and the other pole is 2 minus 3j. Basically, there should be a mirror image. Mirror image of pole should be there. That this is what you mean by complex conjugate. Mirror image. Mirror image around x-axis. Okay. You cannot say they are complex conjugate. No. 2 plus 3j and 2 minus 3j are complex conjugate. 1 plus 2j, 1 minus 2j are complex conjugate. Minus 1 plus 2j, minus 1 minus 2j are complex conjugate. So real part has to be same, but the imaginary part, if one is positive, other one should be negative. So this is the meaning of complex conjugate. Understood? What is the meaning of complex conjugate? So should be mirror image about x-axis, about sigma axis. So about sigma axis, they are mirror image. So yes, poles are complex conjugate. Complex conjugate. So this is just one example. We will see more example as well. And where is the ROC? ROC is sigma greater than 0. So it is not including j omega axis. That means this is not stable. Right? What is the ROC? ROC is sigma greater than 0. Sigma greater than 0 means it will not include j omega axis. That means this signal is not absolutely integrable. So yes, it is not absolutely integrable. There is nothing called stable signal. Okay. If I am saying the signal is stable, this does not make any sense. There is something called stable system. So if this is the impulse response of a LTI system, then that LTI system will be stable. So in conversation, in explaining, if I sometimes if I say this is a stable signal, that means I am talking about system. So I might sometimes say that this is a stable signal, but stable signal does not make any sense. If the signal is absolutely integrable, if that particular signal becomes the impulse response of that LTI system, then that LTI system will be stable. Okay. So here this signal is not absolutely integrable. So this is not absolutely integrable because it is not including the j omega axis. Not absolutely integrable. What about this one? This is the same only, not absolutely integrable. Okay, what kind of graph you will be getting? Just the same graph but in the negative direction. Just the same graph but in the negative direction. This kind of graph I will be getting. Surely it is also oscillatory only. Surely it is also oscillatory only. Okay, what will be your f of s? So first you will see sin omega naught t. For that what you will write? Omega naught upon s square plus omega naught square. Then you will see u of minus t. So another negative sign is there. So yeah, this is done. This is your f of s. Where are the poles? Poles are same. Basically poles are same. This is the same location of pole, right? Nothing different. Poles are same only. And this is also not absolutely integrable. This is also oscillatory only. Just the thing is here ROC will be sigma less than 0 because of this u of minus t. So both are oscillatory. For oscillatory what we are getting? We are getting complex conjugate poles. More example we can see e to the power minus 2t sin 3t ut. E to the power minus 2t sin 3t ut. Is it oscillatory? Surely it is oscillatory. Can you draw the graph of e to the power minus 2t sin 3 e to the power minus 2t sin 3t? Can you draw this graph? Surely I can draw this graph. How will I draw this graph? First I will draw the graph of e to the power minus 2t. So the graph will go somewhat like this, and then you need to take the mirror image as well. Mirror image as well. Now in this mirror image, what will happen? Sin 3t graph will be drawn. So sin 3t graph will be drawn. So you can say that values are oscillating here, right? Values are oscillating. But this graph is absolutely integrable because eventually it is going down towards 0. So this graph is absolutely integrable. But surely the values are oscillating. That means yes, it is oscillatory. Surely it is oscillatory. There is no doubt about that. It is absolutely integrable or not, that is a different thing. But surely it is oscillatory. So can I find f of s? Yes. Sin 3t will throw 3 upon s square plus 9. Similar in this manner. Omega naught upon s square plus omega naught. So sin 3t will throw 3 upon s square plus 9. But since there is e to the power minus 2t, so s will be replaced with s plus 2. So 3 upon s plus 2 whole square plus 3 square. Right? Where will be the location of pole? Minus 2 plus minus 3j. So this will be the location of pole. Can you show the location of pole? Yes. Sigma j omega. Minus 2 plus 3j, minus 2 minus 3j. So this point is minus 2 plus 3j and this point is minus 2 minus 3j. So are the poles complex conjugate? Yes. Poles are complex conjugate for sure. And along with that, what is its ROC? ROC is this one. ROC is including j omega axis. That means yes, your signal is absolutely integrable for sure. So ROC includes j omega axis. That means signal is absolutely integrable for sure. Right? So what is the ROC? Sigma greater than minus 2. But as of now, for this particular question, what was our target? Our target was, what was the target? Our target was to tell that for a oscillatory signal, our poles are complex conjugate. What is written? For a oscillatory real signal xt, the poles of x of s will be complex conjugate. So another thing, this is proven. Here also we can prove it. E to the power t sin t ut. What kind of graph you will get? What is the graph of e to the power t? The graph of e to the power t is somewhat like this. The graph of e to the power t is somewhat like this. Then what did I tell you? You need to take the mirror image. So I will take the mirror image like this. Now what I need to do? I need to draw the graph in between. So this is how I will be drawing the graph. And it will keep on going in this manner. Right? So the graph will keep on rising up. What does that mean? That this was absolutely integrable. Absolutely integrable. But surely this is not absolutely integrable. And this we can verify with the location of pole as well. So let's find out the pole. So what would be your If this is your gt, so what would be your g of s? So sin t ut would throw 2 upon s square plus 4. E to the power t is there, so what it will throw? 2 upon s minus 1 whole square plus 4. So what all are the location of pole? Location of pole is 1 plus minus 2g. So location of pole is coming out to be 1 plus minus 2g. So now you can surely see that in the ROC, j omega axis will not be included. So can I show the pole? Yes, 1 plus minus 2j, 1 plus minus 2j. So what you need to do? So poles are complex conjugate, surely it is complex conjugate. Complex conjugate. Complex conjugate. So they are also complex conjugate, right? What is the ROC? This is the ROC. So ROC does not include j omega axis. What does that mean? If ROC does not include j omega axis, what does that mean? That means it is not absolutely integrable. But our target was to tell that the poles should be complex conjugate. So for a oscillatory signal, poles are complex conjugate for sure. Have I written more example? I guess I have written more example as well, which you can do on your own as well. So this u of minus t example, so also you can do. Okay, so try doing it on your own. Can you draw the graph? Surely I can draw the graph. E to the power t sin t u of minus t. So first I will draw the graph of e to the power t. What will be the graph of e to the power t? So at t equals to infinity, it will throw infinity. So this will be the graph. This will be the graph. Right. Now what you need to do? Minus sin 2t. Minus sin 2t you need to draw. So this is how I will be drawing it. So you can clearly see that, and since there is u of minus t, that's why I am going here. So you can clearly see that values are oscillating, right? Here also values are oscillating, although the values are going down to 0. I don't care. Oscillations are dying down. Oscillations are dying down, and here oscillations are increasing only. But I don't care about that. Only thing I care is there should be oscillations. If there is oscillation, then the pole will be complex conjugate. If there are oscillations, poles will be complex conjugate. If there are oscillations, the poles will be complex conjugate for sure. And let's check that. Sin 2t omega naught upon s square plus 4. Where are the poles? Poles are at 1 plus minus 2j. One plus 2j, 1 minus 2j. Okay, 1 plus minus 2j. Okay, and since this is u of minus t, that means it will be looking towards minus infinity. Since it is u of minus t, it would be looking towards minus infinity. So yes, it is including the j omega axis. That means this particular signal is absolutely integrable, right? And the poles, you can see that they are complex conjugate for sure. Complex conjugate for sure. What about this one? What is the graph of e to the power minus t? At t equals to infinity, it would throw 0. So this would be the graph. And then sin 2t, but in the negative direction. So this kind of graph we will be getting. So here the oscillations will keep on rising up. In that manner, oscillations will keep on rising up. So it is surely not absolutely integrable, which we can verify as well, because what will be your g of s? G of s, directly I can see that e to the power minus t sin 2t. So 2 upon s plus 1 whole square plus a square. U of minus t, another negative sign is required. Yes, another negative sign is already there. So where are the poles? Minus 1 plus minus 2j. So what you can do? You can show the location. Minus 1 plus minus 2j. Minus 1 plus minus 2j. Okay. Sigma j omega. Right. And where will be the ROC? Since there is u of minus t, that means the ROC will be looking towards minus infinity. It doesn't include j omega axis. That means it is not absolutely integrable for sure. There you go. This is the answer. Right. So what was the conclusion The conclusion was, if you are having a real oscillatory signal, then the poles will be complex conjugate for sure. Okay, let's see this question. Whatever the information is given, collect that information, try doing it on your own. There are two questions in this one particular question. Let me explain you the question. What we are saying, that ft is oscillatory. Okay, ft dot e to the power 2t is absolutely integrable. This is the second information. Now, which of the following options represent the correct location of pole for f of t, or you can say f of s. Location of pole will be of f of s, not f of t. So correct location of poles of f of s, considering ft is a causal signal, and in the second case you need to consider it as a anti-causal signal. So what it is saying, that first you consider ft as a causal signal. You are saying that ft is a causal signal. Now if ft is your causal signal, causal plus oscillatory, causal plus oscillatory. Okay, and what they are saying about ft dot e to the power 2t, that it is stable, it is stable, and surely it will be causal as well. Say yes or no. There is a signal, is this causal signal? Yes. If I multiply it with any exponential signal, e to the power 2t, e to the power 2t, so basically this part will be multiplied with e to the power 2t. Are you able to understand this point? If it is causal, that means it is there, it is non-zero for 0 to infinity only. So in a causal signal, if I multiply any signal, this is causal, this is causal. Now I multiply any signal, it could be causal, it could be anti-causal, it is anything. So will this completely be causal only? Yes. If you multiply a causal signal with anti-causal, if I multiply causal with anti-causal, then the multiplication will be 0. But if you multiply any causal signal with another causal signal or with any non-causal signal, the multiplication will be causal only. Are you able to understand this point? A very simple point. So ft dot e to the power 2t, they are saying that it is stable, but from our side we have told that it will be causal as well. How it will be causal? Because if ft is causal, then ft dot e to the power 2t will be causal as well. No doubt about that. Okay. Now, which of the following option represent the correct pole location of f of s? So if ft is oscillatory, then this is not possible at all. Say yes or no. If ft is oscillatory, only by this information that ft is oscillatory, only by this information that ft is oscillatory, this option is wrong. Right? Now what they are saying, that ft is oscillatory, along with that it is causal as well. So causal signal can have any kind of pole location. Causal signal can have any kind of these pole location. This also it can have, this also it can have, this also it can have, this also it can have. But what they are saying, ft dot e to the power 2t is stable. What does that mean? Where will be the location of ft dot e to the power 2t? What I am saying, yt is ft dot e to the power 2t. So what will be the location of poles of y of s? What will be the location of poles of y of s? That would be f of s minus 2. Basically, previously f of s plus 2 was there. That means previously my pole was at minus 2. Now where will be my pole? In place of s, I will put s minus 2 equals to 0. So s will be equals to 0. So previously my pole was there at minus 2. Now my pole will be at 0. That means my pole is shifted right. So if I am given the pole location of f of t, can I draw the pole location of f of e to the power 2t? Can I draw the pole location of y of s? Basically that is ft e to the power 2t. So what will happen? Whatever the pole location of f of s was there, that will be shifted towards the right hand side. So this point minus 1 will reach at plus 1. This point minus 3 will reach at minus 1. This point 1 will reach at 3, and this point 3 will reach at 5. Are you able to understand this point or not? Right? So what I am doing, I am drawing the pole location of y of s. So what will be the pole location? This was your option B. Option A is already cut, so don't care about option A. So B, C, D, E. B, C, D, E. So what will happen? The pole location of f of s, this is the pole location of f of s, this is the pole location of f of s, this is the pole location of f of s, and this is the pole location of f of s. That will be shifted by 2. So minus 1 will be reaching to plus 1. This was option B, C, D and E. -1 is reaching to +1. -3 is reaching to -1. 1 is reaching to 3. Look, only the real part will be shifted. Imaginary part remains the same. If imaginary part here, what will happen? Only the real part will be shifted, no? Because S is sigma plus j omega -2. So sigma -2 plus j omega. So imaginary part remains there as it is. Only the real part will be shifted. And whatever the imaginary part value is there, I don't care. This value could be some plus minus j omega, I don't care. I only care about the real part because I need to show the ROC now. And now 3 will be shifted to 5. 3 will be shifted to 5. Now what do I know? That this is causal. Now if it is a causal signal, it has to be right sided. If your ft dot e to the power 2t is causal, ft dot e to the power 2t is causal, what does that mean? Either it could be right sided or it could be finite duration plus finite amplitude. This probability is gone because poles are finite. So it has to be right sided. And if it is right sided, then where will be the ROC? Right to the rightmost pole. So this will be the ROC. Okay, first let me draw all these points. Okay, these are very good question, guys. Okay, and if these questions are coming, this line I say again and again, forget about the students, even the teachers will struggle here. Okay, so a lot of conceptual understanding is required for solving these kind of questions. Now what they are saying, ft dot e to the power 2t is stable as well. So which of these are stable? Only this option is stable. So for the first one, what is the answer? Only option C. Let me explain this question again, once again, right from the zero. Okay. What was given that ft is causal and oscillatory. So from ft dot e to the power 2t was given that it is stable. Now it will be surely causal as well. So this information we have got. Now what is my yt? Yt is ft dot e to the power 2t. So what I am given? I am given the pole location of f of s. So what will be the pole location of y of s? The pole location will be shifted by 2 towards the right hand side. So here these pole locations will be shifted. So what I have got now? I have got the pole location of y of s. Now what they are saying that yt, what is yt? ft dot e to the power 2t. Yt is absolutely integrable. Yt is absolutely, here I should not write stable, I should write absolutely integrable. Yt is absolutely integrable. Yt is absolutely integrable. That means its ROC should include j omega axis. Now if I know the pole location, can I tell the ROC? Yes, I can tell the ROC. But you should know the nature of Yt. What is the nature of Yt? Nature of Yt is causal. And if it is causal, then it could be either right sided or finite duration, finite amplitude. Finite duration, finite amplitude is not possible. So for right sided signal, where will be the ROC? Right to the rightmost pole. So here only one pole is, here only two poles are there on one line only. So right side, you should look towards right side. So they are looking towards right side, right side, right side. So it is including only, this option is including only j omega axis. Rest all the options are not including j omega axis. In the similar manner, you will solve the part B as well on your own. In that, what is given? Ft is anti-causal, right? Ft is an anti-causal signal. Ft is anti-causal. And surely it is oscillatory as well. So what do you comment about ft dot e to the power 2t? So what is given? It is given that it is absolutely integrable. Absolutely integrable. But surely it will be anti-causal as well. There is no doubt about that. Why it will be anti-causal? Because you are multiplying any anti-causal signal with a non-causal signal. Anti-causal signal multiplied with the non-causal signal will become anti-causal only. Right? No doubt about that. Okay. What you will assume now? You will assume that yt is ft to the power 2t, ft dot e to the power 2t. So where will be the pole location of y of s? Pole location of y of s will be shifted towards right by the fact by 2. Okay. So can I draw the location? Yes, I can draw the location. Option B, C, D and E. So they will move, this will move to +1, 1, basically plus 1, minus 1, 3 and 5. So plus 1, minus 1, 3 and 5. Array yaar. Plus 1, minus 1, plus 1, minus 1, 3 and 5. Okay. Now I need to draw the ROC. How will I draw the ROC? How will I draw the ROC? Since it is an anti-causal signal, so where should be the ROC? ROC should be looking towards minus infinity. So here it should be looking. Here it should be looking. Here it should be looking. And here it should be looking. So which options are including the j omega axis? B, D and E. So you wanted your ft dot e to the power 2t as absolutely integrable. That means yes, only in BDE option you are getting it absolutely integrable. So what is the answer? B, D, E. So drop your pen and think about it. What kind of questions they have asked there? What kind of question they have asked? They have given ft is a oscillatory signal. That means the pole has to be complex conjugate. So option A is gone. Okay. Now ft dot e to the power 2t is absolutely integrable. Now you need to find the location of pole of f of s. So now I will comment on the location of pole of yt, which is ft dot e to the power 2t. So I will comment on the location of poles of ft dot e to the power 2t. So I can draw the location of pole of ft dot e to the power 2t that I have drawn. Now I need to take two different cases where ft is my causal signal. If ft is causal signal, that means surely my ft dot e to the power 2t will also be causal signal. And if it is causal signal, then where the ROC will look? ROC will look towards sigma equals to plus infinity. So if they are looking towards plus infinity, then does it include the j omega axis? If it is including the j omega axis, then it is good. If they are not including the j omega axis, that means ft dot 2t is ft dot e to the power 2t is not absolutely integrable. That means it is not falling in our category. So our category is saying that this should be absolutely integrable. That means it should include the j omega axis. So it is including the j omega axis, and here this is including the j omega axis. Okay, a very good question we have solved. Right now, one more question was there in between, a very basic question. This everyone should be able to solve. So pole location and ROC of some LTI system has been shown. H of s is a proper rational transfer function. Rational, what they have given? It is a rational transfer function, right? Rational transfer function. So what it will show? This part will show left-sided signal and anti-causal, because it is rational transfer function, right? Anti-causal. What it will show? Right to the rightmost plane. What does that mean? That means it is right-sided signal and causal. What does this mean? Left-sided signal and anti-causal. Left to the leftmost plane. And what does this mean? Left-sided signal and anti-causal. Very basic question it is. Right? Very basic, very straightforward. Since it is rational, then everything is satisfied. Left-sided, right-sided, both-sided will be non-causal, right-sided will be causal, and left-sided will be anti-causal. But if it was irrational, then both-sided signal will be non-causal only, but right-sided signal could be causal or non-causal, and left-sided signal could be causal. Left-sided signal could be anti-causal or non-causal, right? So which is the first option? Which of these are stable? Stable means should include j omega axis. So C and D are including the j omega axis. C and D are including the j omega axis. Next, which of these are causal? Which of these are causal? Option C only. Only C is causal. Which of these are non-causal? Will you say none? No. Non-causal system we are talking about. What we are talking about? LTI system. So what do you mean by non-causal system? Non-causal system means it would be non-causal or anti-causal. All will work. Right? So this is anti-causal, this is anti-causal, and this is anti-causal. So ABD. ABD. Causal and stable. So this is causal, along with that it is stable as well. Non-causal and stable, all these are non-causal, but which is stable? Only T is stable. There you go. This was very basic question, very straightforward. This should have been solved by everyone. So I hope you liked this discussion. Okay, this was a very good discussion, very in-depth discussion where we discussed about ROC, and this complete discussion will be helpful in inverse Laplace transform. So we will study about inverse Laplace transform in the next lecture. There this discussion will be very helpful. Okay. So in the next lecture again we will see some properties of Laplace transform and some questions also we will see. So next lecture will also be based on Laplace transform only, where we will see some properties of Laplace transform, along with that we will see some questions as well. Or it might happen that I can add that particular lecture in this lecture only. Okay, because this video is I don't think it has gone more than 2 hours. So if this video has not gone for more than 2 hours, then I can add up some part of that video in this particular video only. Right? Okay then, yeah. So I hope you enjoyed it. Thank you very much. Let's meet again and we will discuss more things about Laplace transform. Hi everyone, in this video we are going to discuss about Laplace transform only, but this video you will find in the section of jet transform, because whatever that we are going to learn here, that will be used in jet transform. That's why I am going to put this particular video in the section of jet transform. Okay, here we are going to discuss all those problems only which we have already discussed. We have already discussed this kind of problem, right? And this kind of problem as well, right? This kind of questions we have already discussed. So why discussing again? Because here I am going to give a different approach, and that particular approach will help you in the jet transform. Okay, so this particular topic is based on Laplace transform only, but it will set up a base, or it will set up a very good concept of jet transform. So we will solve this kind of question which we have already seen. X of s is given, you need to show the ROC and you need to comment on the nature of xt. You don't need to find xt, you just need to comment on the nature, that which particular ROC will result in causal, non-causal or anti-causal. Okay, so previously how I used to solve this particular problem, what I would see, sir, what are the location of pole? -2, -1. These are the location of pole. So now I can make my ROC. What I will do, sigma j omega, if I show the location of poles, -2, -1. From the poles I will draw a line, perpendicularly I will draw a line. I know that, sir, it is rational. So sir, this particular part will result in anti-causal, this particular part will result in causal, and sir, the middle one will result in non-causal. Since it is rational, that's why it is happening. Okay, so this part is this complete part, not only from here, this complete part is, sir, this part is non-causal, this part is causal, and this particular part is anti-causal. Sir, based on that I can get my answer. This is how I used to solve previously. So if you are making your own note, then leave a space of 10 lines. Okay, we will come back to it. Leave a space of 10 lines. Let's solve the next question. So next question, previously how we used to solve. Sir, I know that poles will be at -2 and -1 again. Sir, again I can make the diagram, the similar diagram I can make. Sir, again I will have the same ROC, but since it is irrational, then there would be some issue. What would be the issue, sir? I need to see the shift, sir. I will see the shift. Here what I would do, that, sir, this particular area is supposed to be causal. This area is supposed to be causal, but it may be non-causal as well. Why is that so? Because here there will be a shift of ut will be replaced with, there will be a shift of 1, ut plus 1, because if you apply this property, what it will become? E to the power s divided by s. So ut will be changed to u of t plus 1. That means this particular part was supposed to be causal, but since u of t plus 1, that means left shift, so this particular part will be non-causal. This we have already seen, all these concepts we have already seen. This was supposed to be causal, but it has become non-causal. Right? Now, sir, this particular part was supposed to be anti-causal. It was supposed to be anti-causal, but what is happening? U of minus t has been shifted to u of minus t minus 1, because t is replaced with t plus 1. So it will be u of minus t minus 1. That means it will be shifted towards the left hand side only. So if anti-causal signal is shifted towards left hand side, then it will be anti-causal only. So this particular part was supposed to be anti-causal and it is anti-causal only. And the middle part will always be, the middle part is will always be non-causal. There is no doubt about that. This part will always be non-causal. There is no doubt about that. So this is how we used to solve this particular problem previously. Say yes or no. Now what I am doing, these are my poles, -2, -1. When we studied the first lecture of Laplace transform, I told you that we will care about the poles, but we will care about only finite poles. We will not care about s equals to infinity and minus infinity. But now we are going to care about it. Okay, finite poles I can see -2, -1, these are my finite poles. But now I want to care about the poles at infinity and minus infinity. That means I will care here as well and I will care here as well. So am I having any pole at infinity or minus infinity? Let's check that out. So what I need to find, what is the meaning of pole? What is the meaning of pole? Meaning of pole is that your x of s at s equals to pole will tend to infinity. The meaning of pole is that at the pole your transfer function should go to infinity. That is the meaning of pole, right? Arey yaar. This is the meaning of pole. So if you put s equals to -2 here, it is going to infinity. If you put s equals to -1, it is going to infinity. Now if I put s equals to infinity, if I put s equals to infinity here, what will happen? S tending to infinity, so this e to the power s remains as it is. Now s plus 2 can be reduced to s. S plus 2, s is very high, so it can be reduced to s, and this can also be reduced to s, so it will become s square, s into s, right? And if I put infinity here, what we are getting? E to the power infinity divided by infinity. So infinity by infinity form we are getting, so we need to apply the L'Hopital rule. So how we will show, how we will solve it? Upper side differentiation, downward side differentiation. If I put again infinity, then again there is an issue, because e to the power infinity divided by infinity. So again I will differentiate. Now e to the power, again if I differentiate, what I am getting? E to the power s divided by 2, right? I have to do the differentiation twice, because infinity by infinity form I was getting. So now if I put limit s tending to infinity, so e to the power infinity divided by 2, that would be equals to infinity only. So if I put s tending to infinity, what I am getting? Infinity. What does that mean? That it is a pole. What about s tending to minus infinity? So s tending to infinity, it is a pole. Another pole is there, that is s tending to infinity. But let's check at s tending to minus infinity. S tending to minus infinity, e to the power s, s plus 1 into s plus 2. So if I put e to the power minus infinity divided by minus infinity plus 1 will be minus infinity only, and here also it is minus infinity. E to the power minus infinity is 0 and divided by infinity, infinity into infinity, infinity only. Now 0 by infinity, is it indeterminate form? No, 0 by infinity is equals to 0 only. So it is not a pole. If it was a pole, it was supposed to be infinity. X of s should have gone to infinity, but it is not going to infinity. That means it is not a pole. So suddenly in this particular lecture I am caring about poles at infinity as well. So now what all are the poles I am getting? I am getting the poles at -2, -1 and infinity. These are the poles I am getting. So let's make these poles now. -2, -1 and infinity. And from the poles, what I will do? I will draw a line, I will draw a line, I will draw a line. Now what we studied, what kind of region of convergence I can make? This ROC could be there, right? This ROC could be there, and another ROC between these two poles. This ROC could also be there. Can you make this is also ROC? Can you say this is also ROC? No. After infinity there is nothing, no? Infinity is the limit. Maximum you can go up to infinity only. So infinity is the limit. After that there is nothing. So this particular ROC will not be there. This is not a ROC. Only these are the ROC. In case of rational transfer function, what did we study? That if there is a strip form, then surely it will be non-causal, right? If ROC is left to the leftmost pole, left to leftmost pole, then it will be anti-causal. And if ROC is right to the rightmost pole, then it will be causal. What is our right to the rightmost pole? Right to the rightmost pole. Is it -1? No. Right to the rightmost pole. This is our rightmost pole. And after that, there is no ROC. What does that mean? That means causal signal is not possible. So this particular region, is it there between two poles? This particular region is there between two poles only, no? Are you able to understand this point? This particular region is there between -1 and infinity. That means this has to be non-causal. And were we getting the same thing here? Yes. Here we thought intuitively that e to the power s will come and then ut will be replaced with u of t plus 1. That's why the causal signal, which was supposed to be causal if this e to the power s was not there, if only this much function was there, then this was supposed to be causal. It was supposed to be causal, but because of this e to the power s, what really happened? There was a shift, and because of that shift, this causal signal became non-causal. But here, next task, what we did? My only task was that I am able to find out the poles. If I am able to find out the poles, I am going to locate it, and then I remember one thing, that if it is in strip form, then it will be non-causal. If it is in strip form, then it will be non-causal. If your ROC is left to the leftmost pole, left to the leftmost, are we having any pole at -infinity? No. So this is your leftmost pole. This is your leftmost pole, and your ROC is left to the leftmost pole. That means this particular region will be anti-causal. And can you get any ROC right to the rightmost pole? This is the rightmost pole. Can you get any ROC right to the rightmost pole? No. That means causal signal is not even possible. This particular region would have been causal signal, but it is not even possible. There is no particular region like that. Are you able to understand this point? So if you write down the ROC, how will you write down the ROC? One ROC is between -2 to -1, which is non-causal. One ROC is less than -2, which is anti-causal. Here I can write down the ROC as that it is greater than -1 but less than infinity. This is also non-causal. So can I say my ROC will be greater than -1 excluding s equals to infinity? Again, let me repeat the statement. For this particular region, what I will say, that ROC is greater than -1 excluding s equals to infinity, excluding this particular infinity part, because infinity is a pole and ROC can never include any pole. ROC can never include any pole. What is the meaning of ROC? Meaning of ROC is region of convergence. Region of convergence. That means your x of s should converge in that particular region. Your x of s should converge in that particular region. If I say my x of s is converging at s equals to infinity, then I am saying it wrong, because x of s at s equals to infinity is coming out to be infinity. That means your x of s is not converging at s equals to infinity. That means s equals to infinity can never be included in the region of convergence, right? So that's why I say that pole can never be a part of ROC. Poles can never be a part of ROC. If I say my x of s converges at s equals to -2, then I am saying it wrong, because at s equals to -2, if you put s equals to -2, your x of s is going towards infinity. So that means no matter whatever the values are there, s equals to -2, s equals to -1 and s equals to infinity can never be the part of ROC. So that's why we say that poles are never the part of ROC. The ROC will be bounded by the poles, but it will never be a part of ROC. Poles will never be a part of ROC, because at the poles your transfer function never converges. Your transfer function or your x of s will go to infinity at the poles. Are you able to relate the things? Now I have just given another method to think in this manner. If you don't want to think in this manner, that's e to the power s will come. You are comfortable with this method, go with this method. But why I am giving this particular method? Because everything will be related with jet transform. In jet transform, we are going to relate this particular thing from S plane to Z plane. And your most complex topic of jet transform, where people struggle a lot, that will just come to one line. and that one line will be strip form, non-causal, left to the leftmost pole, anti-causal, right to the rightmost pole, causal. People struggle a lot in jet transform. They don't even understand that, sir, when your causal will be converted to non-causal, when your anti-causal will be converted to non-causal. Here I told you that your causal can be converted to non-causal if there is a shift. This anti-causal can also be converted to non-causal if there is a shift. But that particular shift, that particular irrational transfer function will not come in jet transform. So there you will have to care about this infinity and minus infinity. There you will have to care about the poles at infinity as well. So that much care we need to put in jet transform. That's why after studying the complete Laplace transform, we are studying this particular topic. Are you able to understand this point? Because we are going to relate it with jet transform. So in jet transform, we will just remember one thing, that if it is in the strip form, then it is non-causal. Left to the left, anti-causal, right to the right, causal. That's it. Is that clear to you? Now let's come to the previous question. What is the value of x of s at s equals to infinity? If you put s equals to infinity, what you will get? 1 by s plus 2 will be s, s plus 1 will be s. So 1 by infinity, that would be 0, not a pole. And if I find at s equals to minus infinity, that is also not a pole. So both are not a pole. That means this particular ROC is right to the rightmost pole. That's why it was causal. It is left to the leftmost pole. That's why it was anti-causal, and this is non-causal only. Is that clear to you? But here another thing was coming into action. That thing was at s equals to infinity, you are getting a pole. Right? At s equals to infinity, you are getting a pole. That's why we first thought that it will be right to the rightmost pole. But no, it is not right to the rightmost pole. It is in the strip form. And since it is in the strip form, strip means non-causal. Let's solve the same question, ditto same question, okay, with respect to the new thing that we have studied. Previously, now we will solve it. First, we will solve it with respect to the older thing. What is the older thing? How we used to solve previously? Minus 2, minus 1, two poles are there. I only care about the finite poles. If I only care about the finite poles, what I'm gonna do? Screen lag कर रहा है guys? I guess screen is lagging. Charger is still on, still the screen is lagging. It feels like that. Minus 2, minus 1, right? So I know one particular thing, that middle area, no matter whatever it is, this middle area will surely be non-causal. But since it is irrational, then these areas can be disturbed. Which areas can be disturbed? Sir, these particular areas can be disturbed. So now I need to go and check the shift. What is the shift? Shift is e to the power minus s. That means ut would have been replaced with u of t minus 1. And u of minus t would have been replaced with u of t is replaced with t minus 1. So it would become u of minus t plus 1. So initially this was causal. Now what is this? U of t minus 1. That means there is a right shift. So it is causal only. So causal area is not disturbed. This will be causal only. But initially it was non-causal. Sorry, initially it was anti-causal. Now anti-causality has been disturbed. U of minus t plus 1. That means it will be starting from 1. So this has become non-causal. So this particular area is disturbed. So this is how we used to solve previously. A very good method, easy method. Everything is crystal clear here, and you can go with this method in the examination hall as well. No issue. But what if I want to do something else? That means I need to check at s equals to infinity. X of s. E to the power minus s, limit s tending to infinity. E to the power minus s. If you are putting s equals to infinity, that means this would become s square. E to the power minus infinity divided by infinity, because infinity square will be infinity only. What is e to the power minus infinity? That is 0 divided by infinity. What is 0 divided by infinity? 0 divided by infinity is 0 only. You are getting it 0. What you expected? At the pole, your x of s should have been gone to infinity, but it is not going to infinity. That means this is not a pole. Not a pole. So s equals to infinity is not a pole. Let's check at s equals to minus infinity. S equals to minus infinity. So e to the power minus s minus infinity, this will also be very larger, no? So s plus 2, you can ignore it. Let's just say minus 10,000 plus 2, this will be nearly around minus 10,000 only, no? So minus infinity plus 2, that could be replaced with minus infinity only. So s plus 2 can be replaced with s only, right? So what I can do, s plus 2, the other one can also be replaced with s only. So this became s square. If I put minus infinity, so e to the power infinity divided by minus infinity square, what we are getting? Infinity by infinity. That means I need to apply the L'Hopital rule. So what I will do, minus e to the power minus s divided by 2s. So what we are getting, e to the power infinity divided by 2 into infinity, this is infinity only. Again I need to apply the L'Hopital rule. So again let's apply the L'Hopital rule, because I know that downward I need to kill this. So I will again keep on applying the L'Hopital rule. What I will be getting, e to the power minus s divided by 2. So now if I put e to the power minus infinity, what I am getting, e to the power infinity divided by 2. Infinity divided by 2 will be equals to infinity only. So what you are getting, infinity here. Where? Here. That means this is a pole. So what all are the poles you are getting? Minus 2, minus 1 and minus infinity. Now if you make the diagram, minus 2, minus 1 and another pole at minus infinity. So from the poles, what I will do, I will draw the lines. Now what do I know? This is the region right to the rightmost pole. What is this? This is right to the rightmost pole. And if it is right to the rightmost pole, that means surely it will be causal. This particular region is in strip form. This is in strip form. If this is in strip form, that means surely it will be non-causal. And this particular region, this is also in strip form only, because what would be right to the rightmost pole? Sorry, what will be left to the leftmost pole? Leftmost pole is this one. So what will be its left? This particular area will be left. And there would be nothing lesser than minus infinity, because minus infinity is the limit. So there cannot be any anti-causal signal. So this particular region as well, it will also be non-causal only. So very easily here I need to use the brain, but here I don't need to use the brain. I just need to find out the location of poles. If I find out the location of poles, my job is done. Is that clear to you? Okay. So very good thing which we are going to relate with respect to Z transform. If question is coming on Laplace transform, then you can solve by this method as well. If you don't want to find out the poles at infinity, if you want to find out the poles at infinity, then this would be a very easy method. But why would we care about the poles at infinity? We will just make it and then we will see the shift and we can tell the answer. If I care about the poles at infinity, then I can find out this particular thing as well, and then I can tell that surely, since it is in the strip form only, this is a strip form, right? This is a strip form. So if it is in the strip form, that means surely it will be non-causal. Say yes or no, right? Let's solve more questions. This question is there, e to the power s, e to the power minus s. You need to comment on the nature and all these kind of things, right? I know that if I had solved by our method, so here I can see that there is a right shift as well and there is a left shift as well. Sorry, this will result in left shift, this will result in right shift. Say yes or no. So both shifts are there, that means no particular region will be causal or anti-causal. Everything will convert into non-causal, right? Because e to the power s, what it will do? It will convert the causal part into non-causal. What it will do? E to the power s. And what e to the power minus s will do? It will convert the anti-causal part into non-causal. Anti-causal into non-causal and causal into non-causal. This is what that will be happening here, right? This example we have already seen. Now let's solve with respect to our new understanding. Our new understanding says that you need to find the things at s equals to infinity and minus infinity as well. So two finite poles I can directly see, minus 2 and minus 1. But let's check at infinity. So e to the power s minus e to the power s divided by s square, right? At s tending to infinity, this part will become infinity only, but this part will go to 0, no? And this part will also come to infinity square. So although you are getting infinity by infinity, but I know that this part will go to 0 only. So I don't need to care about this particular part. I only need to care about, basically you need to find out the limit. You are getting infinity by infinity, so you will apply L'Hopital rule. So in any way you can apply the L'Hopital rule, but I am just saying that you can reduce your expression, that this particular part will be going to 0 at s equals to infinity. So why do I need to care about this part? This particular part will be going to 0 at s equals to infinity. This particular part is also going to 0 at s equals to infinity. So that's why I did not care about this particular part. Are you able to understand this point? So if you don't need to care about this particular part, then why should you even consider it here? And even if you consider, then no issue. You need to apply L'Hopital rule. So you need to differentiate upper side and downward side. So if I differentiate, what I am getting, this is what I am getting. Again, if you put infinity, e to the power infinity divided by infinity. So again you need to apply the L'Hopital rule. E to the power s, e to the power minus s divided by 2. Now if you put infinity, e to the power infinity, e to the power minus infinity divided by 2. Infinity minus 0, e to the power infinity is 0. Sorry, e to the power infinity is infinity, e to the power minus infinity is 0 divided by 2, infinity. So surely it is a pole. In the similar manner, s equals to minus infinity will also be a pole. In the similar manner, s equals to minus infinity. So e to the power s, e to the power minus s divided by s square. So what I will do, I will apply the L'Hopital rule twice. What I will do, I will apply the L'Hopital rule twice. So this is what I will be getting. And if I put minus infinity here, so I am getting infinity only. Although I am getting minus infinity, so it is the same thing. 0 minus infinity divided by infinity, so it will be minus infinity. Basically, x of s should not be converging at s equals to minus infinity. What does that mean? My poles are there at minus 2, minus 1, plus infinity and minus infinity. These are the location of my poles. These are the 4 poles I am having. These 4 poles I am having. If you are having these kind of 4 poles, what does that mean? That means everything will be in the strip form only. Everything will be in the strip form, because these are the poles. Right to the rightmost pole is this one. After infinity there is nothing. Before minus infinity there is nothing. So everything will be in the strip form. So everything will be in the strip form. So this is also stripped. This is also in the strip form. This is also in the strip form only. So everything is in the strip form, non-causal. This will also result in non-causal. This will also result in non-causal. This will also result in non-causal. Arey yaar, this will not be in a, this will not be a region, no. Only these region would be there, because after infinity there is nothing, and before minus infinity there is nothing. So these 3 non-causal signal would be there. So this particular signal will always result in non-causal signal only. Is that clear to you? Okay. Now some people would be thinking that, sir, if this kind of question is coming, then how we will find out how we will apply the L'Hopital rule? Sir, we need to differentiate this part. No, I told you one thing, that for applying the L'Hopital rule, what you will do, if s is tending to infinity, that means plus 3, 2, minus 1, plus 4, plus 2, all these things, let's write down plus, or let's write down minus 2 here. Okay, because plus 2 was already there. So all these things will be reduced to s only. So s to the power 5 you will be getting. Now you know one thing, that until this become a constant value, it will be a form of e to the power infinity by infinity only. Let's just say I differentiate one times, what I will be getting? 5s to the power 4. So e to the power infinity divided by infinity. If I differentiate another time, what I will be getting? Infinity by infinity. If I differentiate another time, what I will be getting? Infinity by infinity. If I differentiate another time, what you will be getting? Infinity by infinity. And then you differentiate another time, now you are getting something, e to the power infinity divided by 120. That would be equals to infinity only. So you need to keep on differentiating. So you know one thing, that this particular part, if I keep on differentiating, the lower part will go to a constant value, and this e to the power s will remain e to the power s only. So what do you understand from here? That I will not do all these calculation, I will not differentiate again and again. I know one particular thing, that this will be reduced to a constant value if I keep on differentiating. So what is the answer I am getting? Infinity only. That means this is a pole. This is a pole. And s equals to minus infinity e to the power s to the power 5. So e to the power minus infinity divided by infinity to minus infinity to the power of 5. So e to the power minus infinity is 0 divided by minus infinity. That is equals to 0 only, not a pole. So where are the poles? Poles are there at minus 3, minus 2, 1, minus 4, 2 and infinity. So I know one particular thing. The h of s is a transfer function. This is a transfer function because they are talking about the system. They are talking about the system. So if you want the system to be causal, that means h of t has to be causal. And if h of t is causal, that means it will be a causal system. Causal system. And if h of t is non-causal or anti-causal, non-causal or anti-causal, that means it will be a non-causal system. Now just let me know one thing. Can your h of t ever be causal? For causal, what is the scenario? For causal, what do you need? ROC should be right to the rightmost pole. That means what will be your ROC? Real part of s rightmost pole is infinity, greater than infinity, which is not possible. What does that mean? That h of t can never be causal. That means the system has to be non-causal. This is how you need to think. Just by looking at the question, if you are having okay, e to the power 2s was there, so no issue. Infinity will not care much about that, right? So if you have good enough practice, just by looking at the question, you will tell the answer. Here I would have gone with the previous method that I have studied in Laplace Transform chapter. That I know that poles will be there. Leftmost pole will be 2. This will be the leftmost pole. And after that I am expecting that I will get a causal part. That particular part, that ROC will result in causal. But what do I see? E to the power 2s. What does that mean? ut will be replaced with u of t plus 2. That means there is a left shift. So causal, this was causal. So what it will become? Non-causal. So the causal part was there, that has become non-causal. Anti-causal remains as it is. Strip form, non-causal as it is. The causal part was there, which was supposed to be causal. Because of the shift, it has become non-causal. That means there is nothing causal there. If nothing is causal, that means system will surely be non-causal. There you go. Just by looking at the question, just by looking at the expression, I will be telling the answer. Say yes or no. Do you agree to this point? Well and good. Let's see this question. I told you one thing. If there is an improper transfer function, that means in x of t, delta dash t would be coming. And if it is coming into the action, then non-causal. But let's solve it again. How we will solve it? Poles you can see. One pole is at minus 2. But let's check at s equals to infinity. Let's check at s equals to infinity. So s equals to infinity, that means s square will be very larger than 2s, very larger than 3. So the upper part can be replaced with s square. And downward part can be replaced with s only. This and this is getting cancelled out. Limit s tending to infinity, s will be equals to infinity only. And what about limit s tending to minus infinity? So upper part s square, downward part s, limit s tending to minus infinity is equals to s, that will be minus infinity. So where are the poles? Poles are at minus 2, infinity and minus infinity. These are the location of poles, right? So poles are at minus 2, infinity and minus infinity, and you can surely see that everything will be in the strip form. Everything will be in the strip form. This is also a strip form, this is also a strip form. So this particular part will also be non-causal, and this particular part will also be non-causal. So everything is in the strip form. That means you supposed this part to be causal, you expected this part to be anti-causal, but since there are poles at infinity and minus infinity, this particular part has become non-causal, right? So answer would be xt is non-causal for sure, right? So these are actually very good concepts which we are understanding in a very decent manner, in a very easy manner. Anyone can understand, even the first year student can understand this kind of concept, right? But not everyone will be able to tell the correct answer if these kind of questions are coming in the examination hall. Say yes or no, right? Let's see more questions. Find xt and then tell. I don't think you need the expression. I don't want you to find the expression, although you can find the expression as well, and then you need to tell whether it will be causal, non-causal, anti-causal, whatever it is, you need to tell that. Let me know one thing. Will there be any pole at s equals to 0? I say that at s equals to 0 there is a pole. Is there any pole? Because if I put the downward equals to 0, then what I am getting? S equals to 0 only. But at s equals to 0 there is no pole. Let's check that. Why is that so? Because if I put s equals to 0 here, what I am getting? E to the power 0 minus 1 divided by 0. So 1 minus 1 divided by 0. 0 by 0, which is indeterminate form. What does that mean? Upper side differentiation, downward side differentiation. E to the power 0 divided by 1. So at s equals to 0, you are getting the expression as 1. That means this is not a pole. So s equals to 0 is not a pole. So there is no finite pole. There is no finite pole. No finite pole. No finite pole. And if there is no finite pole, what does that mean? ROC is entire S-plane. ROC is entire S-plane. Right? This is the meaning of no finite pole, right? If ROC is entire S-plane, what does that mean? It is a finite duration signal. It is a finite duration signal. Finite duration plus finite amplitude. Finite duration plus finite amplitude signal. But what I am asking, I am not asking this particular thing, that it is finite duration plus finite amplitude. I am asking whether it is causal, non-causal or anti-causal. Because a finite duration signal could be causal as well, it could be anti-causal as well, or it could be non-causal as well. Right? A finite duration signal could be causal, anti-causal or non-causal. All three possible answers are there. So you tell that whether it will be causal, non-causal or anti-causal. So one thing you got to know that ROC is entire S-plane. But let's check about the poles at infinity and minus infinity. Because if I check the poles at infinity and minus infinity, I can get a very good information out of it. So let's check the poles at infinity. E to the power s minus 1 divided by s. So what I need to do, e to the power infinity divided by infinity, I need to apply the L'Hopital rule. So e to the power infinity, that is equals to infinity. So yes, it is a pole. You expected it to be a pole, and yes, it is a pole. And what if I check at minus infinity? E to the power minus infinity minus 1 divided by minus infinity. So minus 1 divided by minus infinity, that means 0. That means this is not a pole. So there was no finite pole, but there was a pole at infinity. What you are getting? You are getting a pole at infinity. You are getting a pole at infinity. There is no finite pole, but you are getting a pole at infinity. What does that mean? If you make the ROC, right? Now from this particular line, you can either go here or you can go here. Say yes or no. You can either go here or you can go here, right? There is no space here. After infinity, there is nothing. So ROC has to be this one. ROC has to be this one. This has to be ROC. ROC has to be this particular region. So ROC is the entire S-plane. What I can say, ROC is the entire S-plane. For sure it is the entire S-plane, but it will not include plus infinity, it can include minus infinity. This is the ROC. And can I say that my ROC is left to the leftmost pole? There is only one pole. So this will only be rightmost, this will only be leftmost. What I can say, can I call this as rightmost pole? Yes, because there is only one pole, no? And can I call it the leftmost pole as well? Yes, this is your leftmost pole as well. But where is the ROC? ROC is left to the leftmost pole or right to the rightmost pole? Or ROC is in the strip form? ROC is surely not in the strip form. ROC is not right to the rightmost pole because in the right there is no particular region. So ROC is left to the leftmost pole. And for which particular signal you get the ROC to be left to the leftmost pole? That particular signal is anti-causal. Right? Do you remember this particular thing? Let's just say I take a simple example. My pole is at -2. So if I get left to the leftmost pole, if this is the region, then it will be of anti-causal and this will be of causal. So my pole is at infinity, left to the leftmost pole. That means if this particular region is my region of convergence, so this particular region is anti-causal. So this signal x of s, what was your x of s? X of s was e to the power s minus 1 divided by s. That will result in anti-causal signal for sure, and you can check it as well. E to the power s divided by s minus 1 by s. This is your x of s. So x of t I can write down in two manners. One manner would be u of t plus 1 minus ut. Can you draw the graph of this one? What would be the other manner? Minus 1 by s is u of minus t, and this is your u of minus t. Basically u of minus t has 1 by s, minus 1 by s actually. If you need e to the power s, that means t should be replaced with t plus 1. So this will be minus of u of t minus 1 minus sign. Both are the correct expression. Both are the correct expression and both will make the same graph. You can draw the graph of both of them, you will get the same graph only. What kind of graph you will get? This kind of graph you will get, u of t plus 1. That means starting from minus 1. Starting from minus 1, there is a jump of 1 and then there will be a decay of 1. Starting from minus 1, there is a jump of 1, then there is a decay of 1. So this is your xt versus t. What kind of signal is that? Anti-causal only. Say yes or no. Are you able to understand the depth of the concept here? There is a pole at infinity. You know one thing, when you saw this particular thing, there is no finite pole. No finite pole means ROC will be entire S-plane. If ROC is entire S-plane, that means it will be a finite duration plus finite amplitude signal. There is no doubt about that. But then we checked another thing, because in this particular lecture we are talking about poles at infinity and minus infinity as well. When I checked the pole at infinity, I got the pole there, and then I saw that ROC is actually left to the leftmost pole. That means this signal has to be anti-causal. In the examination, what they can do, they will just draw this diagram. They will say that you are having a pole at infinity, and they will show this ROC, and they will ask you from this particular pole zero diagram what you can assume, what you can tell, that your xt will be causal, anti-causal, it will be finite duration, finite amplitude, it will be non-causal, and these kind of questions they can ask. So what will be your answer? Sir, answer would be, it will be a finite duration and a finite amplitude signal which is anti-causal. So in that manner you need to think. Well and good. Okay, right? Similarly, this question is there. Ditto same question is there. Ditto same. What will be your xt here? Xt you will get two kind of expression. 1 by s means ut, and a to the power minus s means u of t minus 1. Right? Another way would be u of minus t minus sign plus u of minus t plus 1. This would be the another way. But this is not how I am going to solve. I know one thing, that s equals to 0 is not a pole. Not a pole. Okay, you can check the limit. What you can do? You can check the limit of x of s at s equals to 0, s tending to 0. You need to apply the L'Hopital rule. So e to the power minus 0, that would be 1. So it is not a pole. Then I will check at infinity. So that will also not be a pole. because 1 minus e to the power minus infinity divided by infinity. What you are getting? 1 divided by infinity, that is 0. So this is also not a pole. If I check at s equals to minus infinity, s equals to minus infinity. So e to the power infinity divided by infinity, I need to apply the L'Hopital rule. What I need to do? I need to apply the L'Hopital rule. So e to the power minus s divided by 1. So e to the power infinity is equals to infinity. Yes, this is a pole. So you are getting a pole at, what all our poles? Our pole is there at s equals to minus infinity. If I draw the pole pole diagram on s plane, then I am getting only one pole which is at minus infinity. So now from minus infinity I am having only one region. What is that region? I cannot go below minus infinity. I have to go after minus infinity. Here I need to go. So ROC is surely the entire s plane. ROC is entire s plane, but it is right to the rightmost pole. This you can call as leftmost pole as well. You can call it rightmost pole as well. But where it is looking towards the right side. That means this has to be a causal signal. This has to be a causal signal. This has to be a causal signal. And you let me know, is this a causal signal or not? Yes, it is a causal signal only. You can draw the diagram ut t minus 1. So it is a causal signal only. Yes, both are causal signal only. Say yes or no. Well and good. Okay. So ROC is entire s plane. You will be able to tell it is a finite duration, finite amplitude signal. But what kind of signal? Causal, anti-causal or non-causal? So we have this. We have seen the example of causal. We have seen the example of anti-causal. If I need to make non-causal signal, what should be there? On the upper side, e to the power s minus e to the power minus s divided by s should be there. Because here the poles will be there. You can check on your own. Poles will be there at infinity as well and minus infinity as well. There is no finite pole. At s equals to 0, there is no finite pole. Okay. So there are no finite poles. Only the poles are there at s equals to infinity and minus infinity, which you will be able to check on your own. So you will know that here I am having a pole. Here also I am having a pole. That means two kind of poles I am having, at minus infinity, at plus infinity. One thing I am pretty sure that I cannot go ahead of infinity. I cannot go before of minus infinity. That means where I have to go? I have to go in this particular region. And this particular region is entire s plane for sure. But this is in the strip form. Strip form means between two poles. So this is a strip form. And if it is a strip form, what does that mean? This will be non-causal. And surely you can check what kind of xt you will get. E to the power s divided by s, what that would be? U of t plus 1. And e to the power minus s divided by s, what that would be? U of t minus 1. Another way could be u of minus t minus 1 minus sign plus u of minus t plus 1. This could be the other way. And both are non-causal for sure. All these concepts, everything, every single thing we are going to relate with jet transform. So when I teach jet transform, there I'm going to tell that, do you remember Laplace transform? Do you remember this particular video? So you will have to agree to my point that yes sir, I remember that particular video. Say yes or no. Well and good. Okay, so that's it. This is the end of our discussion that I wanted to do on this particular topic. Right? ROC. We have understood the ROC in case of Laplace transform. Ditto same analysis will be there for jet transform as well. But now you need to understand the relation between S plane and Z plane. So you will map some points from S plane to Z plane. Let's just say some point is there on S plane. So on Z plane where it will be mapped. If this particular point is mapped at this particular point in S plane, so in Z plane where this point will be there. So that you need to find out. Okay. Now you know the formula of Laplace transform, bilateral Laplace transform. This is the formula, right? When you want to go from continuous time to discrete time, what do? You do the sampling. That means after every ts second, you calculate the sample, or you can say that in place of t, I put nts. So minus infinity to infinity. In place of t, I am putting nts. Now this has become a discrete time signal, right? This has become a discrete time signal. So if it has become a discrete time signal, so here in place of integration, what will come? In place of integration, the summation would come. and here e to the power minus s and ts. So what you are getting? N goes from minus infinity to infinity, x of n ts e to the power s ts to the power minus n. And if I want to compare it to the Z transform, what is your Z transform? N goes from minus infinity to infinity, x of n z to the power minus n. So this is your discrete time signal, this is your discrete time signal. Then something is written here to the power minus n, something is written here to the power minus n. So if I compare now, so what you are getting, z is equals to e to the power sts. Do you agree to this point or not? Z is equals to e to the power sts. Say yes or no. And this can be written as, what is s? Sigma plus j omega. Sigma plus j omega. So what I am doing, let's write down. So this can be written as e to the power sigma ts dot e to the power j omega ts. So this is your z. What is your z? E to the power sigma ts e to the power j omega ts. You are not going to remember this, you are only going to remember this particular thing, that z is equals to e to the power sts. That's it. What is ts here? Sampling time period, right? Ts is the sampling time period. Now I am just expanding the expression of s. S is sigma plus j omega, so this is how I can expand it. So what will be your mode of z? Mode of z would be e to the power sigma ts. Here I am not putting the mode. Why is that so? Because e to the power sigma ts can never be negative. This value will never be negative. Look, ts could be a constant value. Let's just say ts is 1. So e to the power sigma, can this ever be negative? Can you draw the graph of e to the power sigma? E to the power sigma versus sigma. This is how the graph will go. So e to the power sigma can never be negative, and ts will be a fixed value, 1 second, 2 second, 3 second, 0.5 second, it could be anything. So what do you understand from here? That this value will always be positive. That's why you don't need to put the mode here. Okay. So mode of z, which is known as r. So it is e to the power sigma ts. And what is the angle of z? Angle of z is e to the power j theta. E to the power j theta. So what is the value of theta? Omega ts. So bottom line is, this is the conclusion we have made from this particular slide. Only thing you need to remember is z is equals to e to the power sts. After that, all the analysis you will be able to do on your own. Let's map some points from s plane to z plane. So this is your s plane and this is your z plane. So values of s are given. These are the values of s. So first you will map these points on s plane, then the same point will be plotted to z plane. Okay. So just a second, let me add a page here. Okay, let's start. So let's first map these points on s plane. So what is the point? Minus 1 by ts plus j pi by 3 ts. So minus 1 by ts would be somewhere here. Minus 1 by ts. In your mind, you will take ts value as 1 second. In your mind, you take ts value as 1 second. So this point is minus 1 plus j pi. Minus 1 plus j pi by 3. Minus 1 plus j pi by 3. This is the point, right? So minus 1 by ts is here. Now you need to plot minus 1 by ts plus j pi by 3 ts. So minus 1 by ts and j pi by 3 ts. This point would be somewhere here. Then minus 1 by ts plus j pi by 2 ts. Minus 1 by ts plus j pi by 2 ts. This point would be somewhere here. Then you need to plot minus 1 by ts plus j 3 pi by 4 ts. 3 pi by 4 somewhere here. And then pi by ts somewhere here. So these are the points. Next point is minus 1 by ts minus j minus pi by 3 ts. Minus pi by 3 ts would be somewhere here. Then minus pi by 2 ts would be somewhere here. Then minus 3 pi by 4 ts would be somewhere here. And then minus pi by ts would be somewhere here. Basically, I am saying that this particular point is j pi by 3 ts plus sign. This particular point will be j pi by 2 ts. This particular point will be j 3 pi by 4 ts. Similarly, this particular point will be j pi by ts. Similarly, in the negative direction, this point will be minus j pi by 3 ts minus j pi by 2 ts and so on. So basically all these points are coming on one line. All these points are coming on this one particular line. So this is how I am gonna map these points on S plane. This we already know. Now how I am gonna map these points on Z plane, that I need to see. So what is my Z? Z is equals to e to the power s ts, and I got to know that it can be written as e to the power sigma ts, e to the power j omega ts, where mode of Z is e to the power sigma ts and angle of Z is omega ts, right? So in the first one, what is the value of s? The value of s is minus 1 by ts plus j pi by 3 ts. So let's write down here again Z. The value of s is minus 1 by ts plus j pi by 3 ts. So what is the value of sigma? This is the value of sigma. And what is the value of omega? This is the value of omega. So what would be your mode of Z? From here if you see, what would be your mode of Z? So my mode of Z would be e to the power minus sigma, e to the power sigma ts. So what is the value of sigma? Minus 1 by ts into ts. So your mode of Z is coming out to be minus 1. And what will be your angle of Z? Angle of Z is omega ts. What is the value of omega? Pi by 3 ts. Pi by 3 ts into ts. So angle is coming out to be pi by 3, which is equals to 60 degree. So this particular point, minus 1 by ts plus j pi by 3 ts, minus 1 by ts plus j pi by 3 ts, this particular point on Z plane, this particular point on Z plane is somewhat like this. The magnitude is minus 1 and the angle is, magnitude is e to the power minus 1 and the angle is 60 degree. Say yes or no. So if your s was minus 1 by ts plus j pi by 3 ts, then your Z was somewhat like this. E to the power minus 1, e to the power j pi by 3. Pi by 3 means 60 degree. So magnitude is e to the power minus 1 and angle is 60 degree. So how will you plot it? Angle is 60 degree, magnitude is e to the power minus 1. So here the point will be plotted. This will be the point. This will be the point. If I call this as S1, S1, S2 and so on. So this point will be your S1. Right? All good. So this point is your S1, S2, S3, S4, S5, S6, S7, S8. So this is your S1. Similarly, you plot S2 as well. Similarly, you plot S2 as well. So this was your S1. What is my S2? S2 is again minus 1 by ts, because the real value is same, sigma value is same, plus j pi by 2 ts, right? Pi by 2 ts. So in the whole scenario, in the whole question, sigma value is not changing. Sigma value is same only, that is minus 1 by ts. That means this amplitude will not change. This amplitude will not change. Look, sigma value is not changing, that is my minus 1 by ts only. So if I put minus 1 by ts here, in place of sigma, if I put minus 1 by ts, what will be the magnitude I will be getting? Always I will be getting one magnitude, that is e to the power minus 1. You agree to this point or not? So what would be my mode of Z? Mode of Z is e to the power sigma ts. That would be e to the power minus 1. And what would be your angle of Z? That would be omega. What is the value of omega? Pi by 2 ts into ts. So angle will be pi by 2. So when your s was minus 1 by ts plus j pi by 2 ts, then your Z was e to the power minus 1, e to the power j pi by 2. So magnitude was e to the power minus 1 and the angle was j pi by 2. So where will be pi by 2? Pi by 2 will be here, and magnitude was the same, e to the power minus 1. Here also the magnitude was e to the power minus 1 only. This point was S2. Here also magnitude was e to the power minus 1. Here also magnitude is e to the power minus 1. In the next one, what will be the angle? What do you think? Here the angle was, first you got the angle pi by 3, then pi by 2. You got the angle pi by 3, then pi by 2. Then next angle will be 3 pi by 4. So where that would be? 3 pi by 4. What is the meaning of 3 pi by 4? What is the meaning of 3 pi by 4? 3 into 180 degree divided by 4. So what it would be? 180 minus 45. Basically 180 minus 45, 135 degree. So 3 pi by 4 is 135 degree. So magnitude is e to the power minus 1 only, angle is this one. So magnitude is not changing, magnitude is always e to the power minus 1. Next, what will be the angle? Angle will be pi. Next, what will be the angle? Minus pi by 3. Here, what will be the angle? In this scenario, what will be the angle? Let's take this point. This point is S5. So let's take S5. What is my S5? Minus 1 by Ts minus j pi by 3 Ts. You agree to this point? So what will be your Z? E to the power sigma Ts, that would be e to the power minus 1, and e to the power omega Ts. What is the value of omega? Pi by 3 Ts into Ts. Value of omega is minus pi by 3 Ts, and then into Ts is already there. So what you are getting? E to the power minus 1, e to the power minus j pi by 3. So magnitude is e to the power minus 1, angle is minus pi by 3. Magnitude is e to the power minus 1. This was the angle plus pi by 3. Now negative angle minus pi by 3. That angle would be somewhere here. This point will be your S5. Then for S6, what will be the angle? Magnitude is the same. This is the angle. This would be your S6. Next, your S7. And then S8 again here. And if I take another point, I call this point as S9, which is minus 1 by Ts only. What is my point? What is my S9? S9 is minus 1 by Ts. That means value of omega is 0. Right? So what would be your Z? Z would be e to the power sigma Ts, that means e to the power minus 1, e to the power j0. That means Z would be e to the power minus 1 only. That means angle is 0 degree and magnitude is 1. Angle is 0 degree and magnitude is e to the power minus 1. So on this complete line, what is my angle? Angle is going from 0 to 2 pi. On this complete line, the angle is going from 0 to 2 pi, but magnitude is same. And if I join all these points, here what I did, I joined all these points. First I plotted S1, S2, S3, S4, S5, S6, S7, S8 and S9. So here also I am doing the same thing, S1, S2, S3, S4, S5, S6, S7, S8 and S9, and now I am gonna join all these points. So if you join all these points, tell me what you will be getting. Let me know what kind of structure you will be getting. You will be getting a circle, because all are at the same distance. That means you will be getting a circle of radius e to the power minus 1. You are getting a circle of radius e to the power minus 1. So on S plane, when I used to mark the poles, when I used to find the ROC, what I used to do? First I would mark the pole and then I would draw a line. Right? I would draw a line like this. So this is what I used to do on S plane. So in Z plane, what I will do? First I will mark the pole, and passing from the pole I will draw a circle. So on S plane, this particular line has been mapped to this particular circle. This line has been mapped to this particular circle. Although here dotted it should be dotted, dots should come. But in this software you cannot make the circle in dotted manner. Oh, this will be dotted, no? If this line is dotted, so I need to make the circle dotted as well. So the circle should be dotted, but in this software you can draw the straight line dotted, but you cannot draw the circle as dotted one. So that's why I have to show like this. Okay, so this is the dotted circle. This line has been plotted into a circle of radius e to the power minus 1. So if I know this point, if I know this particular point, will I be able to tell that what will be the radius of my circle? Yes. Now second thing you need to see, what is the second thing? That you went from this bottom to upper side. You went from 0 to, what was this point? This was j pi by Ts. And downward as well you went from 0 to minus j pi by Ts. That means how much window you covered? What is the total window that you covered? What is the total window you covered? This total window. So this total window is j 2 pi by Ts. Upper side j pi by Ts, downward side minus j pi by Ts. So this total window is j 2 pi by Ts. And what is j 2 pi by Ts? What is the value of pi by 2 pi by Ts? Omega s. That means in one sampling frequency, If you cover the path of one sampling frequency, then you cover one complete circle. Do you understand what I am saying? You will say that, sir, this complete line is plotted at the circle. Yes, it is fine, but only in one window, no? Let's just say the other point was, j3 pi by 2 ts. The other point was minus 1 by ts plus j3 pi by 2 ts. That means the magnitude would have been e to the power minus 1 and the angle would have been 3 pi by 2, right? So magnitude would have been e to the power minus 1, angle would have been 3 pi by 2, that means this would be the angle. So again it will come on the circle only. So whatever the points are there on the line, all will come on the circle. But if I cover one cycle, what does that mean? If I cover one cycle, that means that I am working for 2 pi by ts window. If I cover one cycle on the circle, that means on this particular line I am working for 2 pi by ts window. Do you agree to this point or not? And if ts value is 1, that means I am working for 2 pi angle. Okay, although this point is not that important. Important part is that this particular line has been plotted as a circle on z plane. Is that clear to you or not? And the radius of this circle is, can I write down the equation of this circle as mod of z equals to z to the power minus 1. The equation of this circle will be mod of z equals to e to the power minus 1. Yes, I told you this thing here only. Where I told this thing? Here. The equation of this circle is mod of z is equals to 3. So similarly here as well, the equation of this particular circle is mod of z is equals to e to the power minus 1. You agree to this point? So a line in S plane has been plotted as a circle on Z plane. The window you cover in one cycle, the window you cover is 2 pi by ts. One more thing, if I work from S8 to S4, that means I am going down to up. Where is my S8? S8. This is my S8. I am going from S8 to S4. That means first I will go from S8 to S7, then S7 to S6, then S6 to S5, then S5 to S9, then S9 to S1, then S1 to S2, then S2 to S3, and then S3 to S4. So if I am going down to up, what does that mean? I am working anti-clockwise on the circle in Z plane. Another point, in S plane on a line, if I go from down to up, that means on S plane I am working anti-clockwise. So basically what you need to remember, let's just understand this particular line as this line. This particular line is this line. Or what you need to do, let's just consider this particular line, whatever the line this is given, this particular line as this line, So what you are doing, you are just bending this line into a circle. That's it. This straight line, when this straight line goes from S plane to Z plane, what will happen? This will bend into a circle. The straight line will bend into a circle. So on this line, if you are working upper direction, in the upper direction, that means on Z plane you are working anti-clockwise. This is anti-clockwise. So you need to hold this line and just bend it. Hold the line, bend it. Hold the line, bend it into the circle. Say yes or no. Is this point clear? A very, very good point. A very interesting point which will reduce the stress of ROC at all. Like ROC will be crystal clear. If you know this particular concept, then there is no point of getting stressed for ROC. Otherwise, ROC becomes very difficult. Okay. And we will surely see the conclusion. Conclusion will be in just 1 or 2 lines only. So things will be very easy for you if you just give me full concentration. You just need to give me full concentration, then everything will be crystal clear. Right? Let's go to the next one. Now the point is plus 1 by ts j pi by 3 ts. So here this time this is the point. Plus 1 by ts j pi by 3 ts, j pi by 2 ts, j 3 pi by 4 ts, j pi by ts. So basically again this time what you are doing, you are working in this particular line. You are working on this particular line. So this was our S9. Now S1 will be here. 1 by ts plus j pi by 3 ts. This point will be j pi by 3, then j pi by 2, then 3 pi by 4, and then pi. So pi ts, 3 pi by 4, pi by 2, and then pi by 3, and going downward minus pi by 3, minus pi by 2, minus 3 pi by 4, and minus pi by ts, going downward, and this is the line is there. Okay, now you let me know what will be the magnitude. The magnitude will be, basically this will be the scenario, right? Angle you can predict. Here the angle will be pi by 3, then pi by 2, then 3 pi by 4. Basically you need to put the value of omega. Omega is pi by 3 ts. So first the angle will be pi by 3, then pi by 2, then 3 pi by 4, then pi, then minus pi by 3, then minus pi by 2, minus 3 pi by 4, minus pi. Right? And what about the magnitude? Sigma value is same. For all of them the sigma value is same. Right? So what is the magnitude? Magnitude will be e to the power, what is the value of sigma? 1 by ts. Into ts, angle will keep on changing. So magnitude is e to the power 1, e to the power omega ts. So this is your mode of z. So here your mode of z is e to the power 1. So all the points will be having the same magnitude, but the angle will be starting from pi by 3, pi by 2, 3 pi by 4, pi, minus pi by 3, sorry, minus pi by 3 would be here, minus pi by 3, minus pi by 2, minus 3 pi by 4, and then minus pi. So again the circle will be made. This time the important part is the radius of the circle. The radius of the circle will be e to the power 1. So again there will be a circle. Again this line will be plotted into a circle. But the important part being is that the radius is, the equation of this circle is mode of z is equals to e to the power 1. If I plot the points, if this I call as S1, S2, S3, S4, and then S5, S6, S7, S8, then starting from here, this will be S9, this will be your, then S1 is having pi by 3 angle, so S pi by 3 angle will be 60 degree. So this would be your S1, then this would be pi by 2 angle, then S3, S4, S5, minus pi by 3 means minus 60, S5, S6, S7, and S8. S8. These will be the points, and if this line is dotted, so this line should also be dotted only. Okay, so this particular line has been plotted as this line with the magnitude of mode of z is equals to e to the power 1. Previously, what was the magnitude? Mode of z is equals to e to the power minus 1. This was the magnitude. E to the power minus 1, which is less than 1. And this is greater than 1. Now let's plot these points. That means value of sigma is 0 this time. So where will be these points? These points will be here. J pi by 3 ts, J pi by 2 ts, J3 pi by 4 ts, J pi by ts, minus J pi by 3 ts, minus J pi by 2 ts, minus J3 pi by 4 ts, and minus pi by ts. So, and this point I am calling as S9. S9 I am calling as 0. So this point is 0. Sigma is also 0, omega is also 0, everything is 0. Right? So S1, S2, S3, S4, S5, S6, S7, S8. From here what I will do? Draw a line. Now this line I need to plot on this particular circle. So what is the scenario? E to the power sigma ts, e to the power j omega ts. Angle you can see, angle will be going from pi by 3, pi by 2, 3 pi by 4, pi, then minus pi by 3, minus pi by 2, minus 3 pi by 4, and minus pi. What about the magnitude? What is the value of sigma? Sigma is 0. And what is the value of e to the power 0? That would be 1. So mode of z is equals to 1. So here, what is the radius of the circle? 1. The radius of the circle is 1. This circle will be made with the radius of 1. Right? And then points will be there. This point will be S9. This point will be S1, S2, S3, S4, S5, S6, S7, S8, S8, and S9 is already here, right? Angle you can see, and this is how it is plotted. So this will also become a circle, but mode of z is equals to 1. Now just let me know one point. If there is any line here, any random line, for this random line, if I plot it on the z plane, what will happen? It will become a circle. One particular line, you just need to bend it, it will become a circle. What will be the radius of that particular circle? It will be greater than 1 or less than 1. Here the value of sigma will be positive, right? Let us say the value is 2 pi by ts. 2 by ts. The value is 2 by ts. Value of sigma will be positive. What is mode of z? E to the power sigma ts. E to the power 2 by ts into ts. E to the power 2. And e to the power 2 is greater than 1. So if you are in the right hand side, that means sigma is positive. And if sigma is positive, that means this value will be greater than 1. Do you remember the graph of e to the power sigma versus sigma? This is the graph, no? So if sigma is positive, what is the value at sigma equals to 0? What is the value at sigma equals to 0? E to the power 0 is 1. So after this, if sigma is positive, then the value will be greater than 1. And if sigma is negative, the value will be less than 1. If there is any line here, so the radius of circle will be less than 1. And you have seen it here. If this line was there, radius of the circle was less than 1. If this line was here, then the radius of circle was greater than 1. And if this line is on j omega axis, then this j omega axis is plotted as a circle of radius 1. So in Laplace transform, I used to say that if your ROC includes the j omega axis, then your system will be stable. So in Z transform, what I will say, if your ROC includes the Z equals to 1 axis or Z equals to 1 circle, then your system will be stable. Again, let me repeat the statement. In S transform, I used to say that if my ROC includes the j omega axis, then the system will be stable. In Z transform, I will say that if my ROC includes the Z equals to 1 circle, then my system will be stable. So this j omega axis has been plotted to mode of z equals to 1. Whatever that was on this side, that has been also plotted as a circle, but the circle of radius lesser than 1. And whatever that was there this side, that also has been plotted as a circle, but circle of radius greater than 1. Is that clear to you or not? So let's write down as a conclusion. As a conclusion, did you understand what you need to do? So basically, if these are the scenario, if this is the scenario between the window of minus pi by ts to plus pi by ts, that means in the window of one sampling frequency, what will happen? All these lines will be converted into circles. All these lines will be converted into circle. But what is your mode of z? Mode of z is e to the power sigma ts. As of now, consider ts equals to 1. So here let's just say sigma value is minus 1. So this particular line will have a radius of e to the power minus 1. This will have a radius of e to the power minus 2. This will have a radius of e to the power 1. And this will have a radius of e to the power 2. So when you are going this side, the radius is increasing. And when you are going this side, the radius is decreasing. So what is the intuition now? The intuition is there are these lines. There are these 5 lines. What you will do? You will hold the lines from the right hand side. And just bend it in the circle. Hold the lines from the right hand side and bend it in the shape of circle. Are you able to understand what I am saying? From the right hand side, you need to hold it. And all the lines will be bent in the shape of circle. So this will give you the maximum radius. Then this will give you the radius. Then this will give you the radius. And then this will give you the radius. Are you able to understand? All the lines holding and then bend into the circle. So who will give the maximum radius? Who will give the least radius? You understood, right? Or you can simply understand by the concept. What does the concept says? The concept says that whatever the line which are in the left hand side, they will be having radius less than 1. And j omega axis will be having radius equals to 1. And whatever that lines that are there in the right hand side, they will be having radius greater than 1. So you will be getting circles. So let's make the circles in the same color. Red circle, then brown, then green, then blue, and then maroon, 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 maroon. Okay, this is the scenario, and all the lines will be dotted. All the lines are dotted. There you go. So this is your Z plane, right? So if I ask you, what is the radius of this particular circle? That is Z equals to 1, which is j omega axis. This j omega axis, this is equivalent to j omega axis, right? What is the radius of this particular circle? That would be greater than 1. And what will be the radius of this particular circle? If I am calling this as greater than 1, can I call this as greater than 1? Right? If this is greater than 1, so this I am calling as greater than 1. So this particular point is the right hand pole. Right hand pole 1. So this is your right hand pole 1. And this is your right hand pole 2. So this is your right hand pole 2. This is your right hand pole 2. What about the inner ones? So inner one, this would be your mod of z less than 1, right? Which is your left hand pole 1. Left hand pole 1. So this is equivalent to left hand pole 1. And if I am calling as mod of z less than 1, so this I can call as mod of z less than 1. So this I can call as left hand pole 2. So this will be your left hand pole 2. So in this particular region, all of them will have radius less than 1, and here all of them will have radius greater than 1, and this j omega axis will have the radius equals to 1. Is that clear to you? This is how we are going to plot it. Let's talk about minus infinity and plus infinity. What I need to talk about? S equals to minus infinity and plus infinity. So minus infinity, and then value of omega could be anything. Basically the line is here. The line is here. And let's talk about plus infinity as well. The line is here. The value of sigma is infinity. The value of sigma is infinity. The value of minus sigma, the value of sigma is minus infinity. Omega value could be anything. Basically the point is minus infinity plus j omega. Omega could be anything. Omega can vary. So what will be your z? Z will say I am sigma ts e to the power j, or let's go on the next page. Okay, let's go on the next page. So what is my point? My point is s equals to minus infinity plus j omega ts. This is the point. What is your z? Z is e to the power s ts, which you can write minus infinity plus j omega by ts, sorry, omega by ts, omega by ts, omega by ts into ts. So what you are getting? E to the power minus infinity, e to the power j omega. So e to the power minus infinity, 0. What is the angle? Some j omega. But radius is 0, no? So this s equals to minus infinity, this particular line will be plotted as a circle of radius 0. There you go. So let's make it on the next page. Here I will make, here I am having s equals to minus infinity and plus infinity, that I need to plot on z plane. So this is my S plane and this would be my Z plane. So on S plane, if I needed to plot this particular, pole or this particular line, which is S equals to minus infinity, value of omega can vary from 0 to 2 pi or from minus pi to pi, the value of omega can vary, but I got to know that the radius of the circle is 0. So this is how it will be plotted. This is your mode of Z equals to 0. Mode of Z is equals to 0, which is equivalent to S equals to minus infinity. And what about the plus infinity? What about the plus infinity? So let's do it. What about the plus infinity? So S is equals to plus infinity plus j omega ts, omega by ts, sorry. So Z will be e to the power sts, e to the power infinity, e to the power j omega. What is e to the power infinity? Infinity. And the angle could go on. So radius, circle of radius infinity. So what is your mode of Z here? Mode of Z here is infinity. Here what was your mode of Z? Mode of Z was 0. Here what is the mode of Z? That is infinity. So you need to draw a circle of infinite radius. So although I cannot show infinite because there is nothing infinite, so I will show the circle like this. Circle of radius infinite. Circle having infinite radius. Circle having infinite radius. Right? So same thing is there. You just need to make a circle. You just need to bend the line in a circle. So what will happen? This will give you the biggest circle and this will give you the minimum circle. Are you able to understand this point? Okay. So what I will say, this particular point is mode of Z is equals to infinity, or you can say S equals to infinity. So S equals to infinity has been plotted as mode of Z equals to infinity, and S equals to minus infinity has been plotted as mode of Z equals to 0. And where this is the scenario, j omega axis. So j omega axis has been plotted as a unity circle, which we have already seen. So 0, unity circle and infinity, and in between there will be these lines. Which lines will be there? These lines will be there. So is the mapping clear from S plane to Z plane? Say yes or no. I hope the mapping is clear. A very, very interesting point. From S plane to Z plane. Now let me ask you a question. I hope you guys will be able to answer. So this is the j omega axis which has been plotted as Z equals to 1 plane. Let me know this reddish area will be reflected where? In this S plane, this reddish area will be reflected in Z plane where? Where will be this reddish area? Think about it and let me know. What is the point about this reddish area? That here surely your mode of Z would be less than 1. But in this reddish area, the angle is positive, no? Angle is positive. Because what is the scenario? What is your mode of Z? Mode of Z is e to the power sigma ts. And what is your angle of Z? That is omega ts. So if omega is positive, here omega is positive. Omega is positive. What does that mean? That means angle of Z is positive. So here angle of Z should be positive. Positive means it should be there between 0 to pi. 0 to pi. So angle will be there between 0 to pi. And the radius will be less than 1. That means it should be inside the circle. It should be inside the circle. Inside the circle with angle being between 0 to pi. Here what is the scenario? Here also there is the same scenario, mode of Z less than 1. What is the angle? Or you can say, what is the value of omega? Omega is negative, right? Omega is negative. What does that mean? Angle will be negative, or what you can say, that your mode of Z would be negative, or you can say that it will be between 0 to minus pi. 0 to minus pi. So this particular region will be there. This particular region will be there. Here what will be the scene? Mode of z greater than 1, right? Mode of z greater than 1. Angle positive. That means between 0 to pi. So this will be the region. All the outer region, right? And what about this one? This will be the last region, this region, because angle is negative here, right? This region would be here. Say yes or no. You agree to this point? And just think about it. No, this line, this j omega axis, just consider this j omega axis as this line. This j omega axis, what I am doing, I am just bending it. So whatever the portion that was here, whatever the portion, this is the straight line, this is a straight line, whatever the portion that was here, when I bend it, so whatever the portion that was here, that will be reflected here only, no? Are you able to think it? This line, I am bending it in a circle. So the portion that was here, that has been made here only. And the portion which was downward, that this portion has been made here. And the line has been bent as a circle. So whatever the portion that was here, now this has become a circle. This has become a circle. So whatever the portion that was outside, previously what was the scene? This was the straight line. There was some portion outside. So whatever the portion that was outside, that has become in this manner. And whatever the portion that is here, that would come outside here. So either you can think by angle or just by rotating it. For rotation, you need to use your intuition. You need to have the visualization. But if you just write down the angle, then you will be able to point it out. So what they can do is that in the examination, they will just make the area like in this manner only. They will make the area reddish, and then they will say that if you map it from S plane to Z plane, then at which particular point you are going to map it. So this is this kind of question they can ask in the examination hall. Or one time the question has been come that the left half of S plane is mapped to Z plane for what? For Z less than equals to 1 circles, right? Left half of S plane, Z less than equals to 1. This we have seen, right? Here we have seen. Left half of S plane, Z less than 1. Z less than 1. So this question was there, which was pretty easy. You would be able to solve these kind of problems. So I hope you are able to understand the meaning of mapping now. Mapping from S plane to Z plane. Let's see some more kind of questions, what can be asked. But let's write down the summary here. That S equals to minus infinity. What does that mean? Z equals to 0. And S equals to 0, that means Z equals to 1. And S equals to infinity, what does that mean? Z equals to infinity. Now if your S is replaced to minus S, so where Z will go? What is Z? Now if S is replaced to minus S, so can I write it down as 1 by e to the power STS? Can I write it down as 1 by Z? Or can I call it Z inverse? So when S goes to minus S, Z goes to Z inverse. And you can see it here. You compare these lines. You compare this line. Here the value was S minus 1 by Ts plus j omega Ts. Now this can I call as minus S, because the real part here was minus 1 by Ts. Now it became plus 1 by Ts. Minus 1 by Ts to plus 1 by Ts. Right? So here the value of mode of Z was 1 by E. And here what it became? E. Just the reciprocal of E. Are you able to understand this point, what I am saying? 1 by Ts, the value of S was 1 by Ts. That means mode of Z, it came out to be e to the power 1. When it became minus 1 by Ts, when it became minus 1 by Ts here, when it became minus 1 by Ts, the value became minus 1 by Ts. So what was the radius now? 1 by E. 1 by Z. So when S tends, if S is changed to minus S, if S is changed to minus S, that means Z will be changed to Z to the power minus 1. Is that clear to you or not? S going from plus S to minus S, Z will go from Z to minus Z to Z inverse, not minus Z, okay, Z inverse. So this is the point which you can remember as well. S to minus S, Z to the power minus 1. Again we are going to see this point. So if you want to remember it, you can remember it. Otherwise, again it will come when we study this property that x of t will have x of s. So x of minus t will have x of minus s, right? Similarly, if x of n will have a z transform of x of z, then what do you think? What should be the z transform of x of minus n? X of minus z? No. If minus s is happening here, so here z to the power minus 1 will happen. Understood? S to minus s, z to the power minus 1. Okay. So this point may help you somewhere. So that's why I wrote it down here. Okay. Let's see some more kind of question. Let's solve this particular problem. X of s is given. Now xt is sampled at 2 Hz. You got x of n. Now the z transform of x of n is x of z. You need to find the pole location of x of z. So it is sampled at 2 Hz. So what is the value of ts? 1/2 second. Pole location of x of z. Can I tell the pole location of x of s? That is -2. So where this -2 will be mapped in z plane? This is in s plane, right? This is in s plane. Now you need to go from s plane to z plane. This is your target. I need to go from s plane to z plane. And if I want to go from s plane to z plane, what is the path? That z is equals to e to the power sts. So z is equals to e to the power -2. What is the value of ts? 1/2. So what that would be? -1. So there you go. The pole will be e to the power -1. That's it. This is the answer. This is the answer. Or there could be another method. What will be your x of t from here? E to the power -2 t ut. Right? It has been sampled at 2 Hz, or you can say 1/2 second. So it has been sampled at 1/2 second. So your x of n would be e to the power -2 1/2. So what you are getting? E to the power -n. Right? And for this z transform is z upon z minus a. Z transform is z upon z minus a. You don't know this, okay? A to the power n un. In the next lecture, you will understand the z transform for this one is z upon z minus a. Z upon z minus a. So what is the value of a here? This is your e to the power -1 to the power n. So value of a is e to the power -1. So z upon z minus e to the power -1. What is the pole? E to the power -1. Just I am telling you that what actually happened here. This is what I am telling. That there was a time domain function. It was sampled at half second. This is the discrete function you got. This was continuous time function. From continuous time function to you got a discrete time sequence. Z transform is z upon z minus e to the power -1. So from here you got to know that my sampling frequency, my pole is at e to the power -1. So don't go by this method, just go by this particular method here. Okay. Let's solve this one. H of s is given, sampled at 2 Hz. H of z is given. You need to find the value of k. Can you let me know what is k? How many poles will be there in H of z? 2 poles will be there. Do you remember one thing? X square minus x plus something is equals to 0. So what does it show? Addition of pole. And what does it show? Multiplication of pole. What is this? Addition of poles. And this is multiplication of poles. So here what I will do, for finding out the poles, what I will do, z square minus 0 point whatever it is plus k is equals to 0. This is how I will find the poles. So what this will be? This will be pole 1 into pole 2. So your target is to find the poles of z, and then you need to multiply them. This is your target. So if I am able to find the poles of h of s, then can I map it to the z plane? Surely I can map it to the z plane. So now my target became that you need to find the poles of h of s. So this is your h of s. 4 into 2, s plus 4 into s plus 2. So your poles of h of s is at -4 and -2. These are the poles. So this is your S plane. From S plane to you need to go to Z plane. What is the path? Path is e to the power sts. Value of ts is given. From here you can see that value of ts is given as 1 by 2 second. Value of ts already you can see, which is 1 by 2 second, right? So e to the power s by 2, z is equals to e to the power s by 2, z is equals to e to the power s by 2. What is the value of s? Minus 4. So z p1 would be minus 4. Here s values are minus 4 and minus 2, and zp2 will be, so e to the power minus 1, e to the power minus 2. What is your k? K is multiplication of poles. So e to the power minus 2 into e to the power minus 1. So k will be e to the power minus 3. So e to the power minus 3. Plus minus 0.049. There you go. Okay, this is the answer. So did you understand how we are doing it? Always the thing is, if h of s is given, h of z is given, that means you need to go from s plane to z plane. That means you need to use the mapping, and mapping is always based on one particular thing, which is z equals to e to the power sts. If you just remember z equals to e to the power sts, then you are able to map any point from s plane to z plane, or from z plane to s plane as well, right? So any mapping you would be able to do, just you need to remember z is equals to e to the power sts. This was I would say it was a kind of a practice problem, and then this was the actual gate PYQ. Okay, so from here I got the value of k. Well and good. So this we have understood about the basics of a jet transform. Next we are going to see some standard signals, some standard sequence, and their jet transform. So some of the things you need to remember there, and after that we will move to our concept of ROC. So let's meet in the next lecture. Thank you very much. Now this is not a property, you just need to tell me x of z, and you need to tell me the ROC as well. So what would be your x of z? X of z would be n goes from minus infinity to infinity, xn z to the power minus n. So n goes from minus infinity to infinity, delta n z to the power minus n. Do you remember this particular thing, that delta n minus n naught into x of n, what that would be equivalent to? This n naught goes here, x of n naught delta of n minus n naught. So similar thing we are going to do, n minus 0, so 0 goes here. So what you are going to get? Minus infinity to infinity, z to the power minus 0, what that would be? 1 only. So what you are getting? Minus infinity to infinity delta of n. And do you remember what is the value of this one? That is 1 only. So what is your x of z coming out to be? 1. Is there any pole? No poles are there. No poles are there. At 0, infinity, or any finite number, no poles are there. No poles are there. What does that mean? What is the ROC? ROC is entire z plane. Entire z plane. That means it is there from 0 to infinity, including the infinity as well, 0 as well, everything, entire z plane. So very good thing we have understood about impulse. Delta t, delta t, delta n, and delta n. Fourier transform, Laplace transform, Fourier transform, Laplace transform. Oh, sorry, jet transform. So continuous time Fourier transform. What was the continuous time Fourier transform of delta t? That was 1. What was the Laplace transform of delta t? That was 1. ROC, entire S plane. Okay. What is the discrete time Fourier transform? That you are going to study in the next chapter only. That will also be 1. It is absolutely integrable. Since this function is absolutely integrable, delta n is absolutely summable. Yes, delta n is absolutely summable. So if you want to find x e to the power j omega, what that would be? In place of z, you put e to the power j omega. So there is no z. So what will be the answer? 1 only. There you go. If it is a absolutely summable function, if it is a absolutely summable sequence, for finding the Fourier transform, what I can do is that in place of z, I can put e to the power j omega. So that thing I did here. There was no z. So x e to the power j omega is also 1. So discrete time Fourier transform is also 1. And z transform is also 1. And what is the ROC? Entire z plane. Complete z plane. So this is about your impulse function and impulse sequence. All clear? All fine? So delta n will have 1, ROC will be entire z plane. Well and good. Let's find out x of z for this particular function. 1, 2, minus 1, 3, 2. So can I write down my x of n as minus delta n, or let's make the graph first. Let's make the graph of x of n. Let's make the graph of x of n. Minus 1 is at origin, then plus 3, then plus 2, here also plus 2, and here plus 1. So can I write down my x of n as 1 into delta of n plus 2 plus 2 into delta of n plus 1, right? This is your 2 delta of n plus 1. I told you in the basics of sequence, in the basics of discrete time signal, I told you that every sequence can be represented in terms of impulse sequences. What is this? This is purely your 2 delta of n plus 1. If I ask you to draw the waveform of this particular thing, what will be that? That waveform will be this thing. So 2 delta of n plus 1 minus delta n plus 3 delta of n minus 1 plus 2 delta of n minus 2. Can I write it down in this manner? Surely, sir, you can write down in this manner. All clear? Delta of n plus 2 plus 2 delta of n plus 1 minus delta of n plus 3 delta of n minus 1 plus 2 delta of n minus 2. What would be your x of z? Remember the property. X of n, x of z. X of n minus n naught or n plus n naught, whatever it is, that would be z to the power n naught x of z. So n plus 2, z to the power 2, what is the Laplace transform of delta n? The thing is, delta n is having a z transform of 1. So delta of n plus 2 will have z to the power 2 into 1 plus 2 delta of n plus 1 will have 2 is already there, z to the power 1. So 2 z to the power 1 minus 1 plus 3 z inverse plus 2 z to the power minus 2. Z to the power 2 plus 2 z to the power 1 minus 1 3 z to the power minus 1 plus 2 z to the power minus 2. This is the x of z you are having. Is there any pole? There is no denominator. What is the denominator? Denominator is 1. Denominator is 1. So if I told you if there is no denominator, so needlessly you don't need to introduce any denominator. So you will not introduce any denominator. This is your x of z. So what is my task now? I will check at 0 and I will check at infinity. I will check at 0 and I will check at infinity. So limit z tending to 0, x of z, what that would be? This would be 0 plus 0 minus 1, but this would be 1 by 0. 0 square, basically it would be infinity only. And if you check at infinity as well, what does that mean? Infinity square or anything you add, now it will be infinity only. That means both are the poles. This is also a pole and this is also a pole. So pole are there at 0 and infinity. You are getting the poles at 0 and infinity. These are the two poles. Now I will add a page. What I will do is that I will add a page and now I will make the poles. What I will do? I will make the poles. Pole is there at 0 and pole is there at infinity. So pole is there at 0 and pole is there at infinity. Can you go after infinity? No. Can you go below 0? What is there after infinity? Is there anything after infinity? No. Is there anything lesser than 0? No. So whatever that would be happening between 0 and infinity only. So what will be your ROC? Between 0 and infinity. So what I will say, what is my ROC? My ROC is 0 and infinity. It will never include 0, it will never include infinity. This is the most important point. A very, very important point. For this particular signal, what is the ROC? ROC will never include any pole, because I told you at pole your x of z will go to infinity. And what is the meaning of ROC? Region of convergence. That means in the region x of z should never go to infinity. That is known as region of convergence. So you are saying that at z equals to 0 and at z equals to infinity, my x of z is going to infinity. That means these 2 points can never be in ROC. So ROC will be bounded by these 2 points. So this will be ROC. This will be your complete ROC. This will be your complete ROC. This will be your complete ROC. Everything is there in the ROC. Everything is there in the ROC. So what you will say, ROC is entire z plane excluding z equals to 0 and z equals to infinity. ROC is entire z plane excluding z equals to 0 and infinity. Now your ROC is in the strip form. Say yes or no? Isn't it in the strip form? Between 0 and infinity. The ROC is between 0 and infinity. That means it is in the strip form. So the signal has to be non-causal, or sequence has to be non-causal. Do you remember the things now? Z equals to 0. What is the meaning of Z equals to 0? Z equals to 0. Z is equals to e to the power s ts. If s is infinity, that means Z will be equals to 0. So Z equals to 0 means pole is at minus infinity, and Z equals to infinity means s is also equals to infinity. So this pole 0 diagram in S plane has been denoted as this pole 0 diagram in Z plane. So there I told you in the first lecture of this Z transform that ROC will be in the strip form. It will feel like that the ROC is entire S plane. Here also it feels like that ROC is entire Z plane. But these points are not included. And if these points are not included, then you can draw 2 lines and you kind of can say that my ROC is actually in the strip form. And if ROC is in the strip form, then the signal has to be non-causal. So this sequence will be non-causal, and you can verify here. You can verify here. It is non-causal. Is that clear to you or not? A very, very excellent point we have covered here. Just you related this particular scenario with the s equals to minus infinity and s equals to infinity. Now are you able to understand why I spent 1 hour in explaining that s equals to minus infinity and s equals to infinity thing? Because s equals to minus infinity has been mapped to z equals to 0, and s equals to plus infinity has been mapped to z equals to infinity. So if your ROC is lying between these 2 guys, that means it is in the strip form and the signal has to be non-causal. Is that clear to you? This is one of the most confusing point of a complete signal system. Not just for Z transform, complete signal system, people will never understand when to include Z equals to 0 and when to include Z equals to infinity, and when you should not include both. So they will mug it up that in non-causal we will never include both of them. In causal we will include infinity. In causal we will include infinity and we will not include 0. In anti-causal we will include 0 and we will not include infinity. So these kind of things they will mug it up. But you don't need to mug up. You have the concept. What is the concept that we will see? So first for non-causal we have already seen. Let's go and see for other thing, right? So if you are making your own notes, so somewhere you can write down this s equals to minus infinity and plus infinity thing as well, that you can relate both of them. Okay, so let's start here. What kind of sequence is that? Causal, right? This sequence is causal. You can see it is starting from n equals to 0, n equals to 1, 2, 3, 4. This will be n equals to 4. So how I can write down my x of n? So again and again you don't need to draw the diagram. X of n can be written as 3 delta n minus 2 delta of n minus 1 plus delta of n minus 2 plus 0 plus 2 delta of n minus 4. Is that clear to you? delta of n minus 4, delta of n minus 3, which is multiplied with 0, 1 is multiplied with delta of n minus 2, minus 2 is multiplied with delta of n minus 1, and 3 delta of n. So what is the x of z you are getting? 3 minus 2 z inverse plus z to the power minus 2 plus 2 z to the power minus 4. This is your x of z. There is no pole, but I will check at 0 and infinity. So if I check at infinity, let's check at infinity first. So 3 minus 2 by infinity plus 1 by infinity square plus 2 by infinity to the power 4. So this will be 0 plus 0 plus 0. Finite value you are getting, not a pole. So surely at infinity you are not having a pole. So let's check at 0. So 3 minus 2 by 0. Directly I can see that surely there will be a pole. 1 by 0 square, 2 by 0 to the power 4. So this is 3 minus infinity plus infinity, infinity, infinity. Surely it will be infinity only. So yes, it is a pole. So there is only one pole, and that pole is at 0. You are having a pole at 0. So what will be your ROC? Let's see it. So this is my z plane. I am having only one pole, that is at z equals to 0. Now if you are having one pole, that is z equals to 0. So this is the circle. Your circle is z equals to 0. Let's just say if circle was mod of z equals to 1, then you would have two paths, right? Either you can come inside or you can go outside. But z equals to 0, can you come inside? Can there be anything lesser than 0? No, you have to go outside only. What I have to do? I have to go outside only. So this would be my ROC. My ROC will be entire z plane. ROC will be entire z plane. Entire z plane. So what is the ROC? If I say my ROC is entire z plane, but excluding z equals to 0, because z equals to 0 is my pole. Excluding z equals to 0. This would be the way to tell the ROC. ROC is entire z plane excluding z equals to 0. Is that clear to you or not? And since your ROC is looking outer to the outermost pole, this pole could be innermost pole as well, outermost pole as well. If there is only one pole, so you can say that this pole is outermost pole, or this pole could be innermost pole as well. But if the ROC is looking outward, then there will be un, and if it is looking inward, then there would be u of minus n minus 1. So if it was looking inward, then it would have been anti-causal. If ROC is looking outward, that means it is causal. And is it causal? Yes. So are you able to relate the things? If this ROC is given, will you be able to tell me that what kind of signal I am having? ROC is looking outside, ROC is looking outward. What does that mean? That means surely un would be there, and if un is there, that means it is causal, right? ROC is not in the stripped form. ROC is outer to the outermost pole, outer to the outermost pole. And if ROC is outer to the outermost pole, that means surely it has to be causal. Say yes or no. So all the things we are relating now. What is z equals to 0? Z equals to 0 is equals to s equals to minus infinity. So only one pole is there, that is s equals to minus infinity. That means ROC will be looking here. And if ROC is looking towards plus infinity, that means u of t has to be there. It has to be causal. So similar thing we related with z transform in the discrete time. So s equals to minus infinity is mapped to z equals to 0. Now ROC is apart from z equals to 0 everything. So yes, apart from z equals to 0 everything. But in Laplace transform we don't care much about s equals to minus infinity and s equals to infinity. But in z transform we care about z equals to 0 and we care about z equals to infinity as well. Is that clear to you or not? Some very good level of questions we are doing. Very, very good level. Let's talk about this question. First, I am not telling that it is anti-causal signal. I don't know. I don't know if it is anti-causal signal or not. I will see from the ROC that whether it is anti-causal or not. So how I can write down my x of n? So this is your n equals to 0, 1, 2, 3, 4. Sorry, minus 4. Minus 1, minus 2, minus 3, minus 4. So minus 3 delta of n plus 4 plus 2 delta of n plus 3 plus delta of n plus 2 plus 2 delta of n plus 1 plus delta of n x of z is equals to minus 3z to the power 4 plus 2z to the power 3 z to the power 2 2z plus 1. Will there be any pole at z equals to 0? No. Directly I can see limit z tending to 0 x of z. If I put 0, this will be 0 plus 0 plus 0 plus 0 plus 1. Not a pole. But if I put limit z tending to infinity x of z, what do I get? Minus 3 to the power infinity, then infinity, infinity, whatever it is, surely it will be infinity. So yes, this is a pole. So I am having a pole at infinity. So if I make my z plane, pole at infinity is there. So pole at infinity is there, that means I will make a circle of infinity radius. So this is the circle of infinite radius. From infinity, can you go outward? No, you have to come inward only. So from infinity, you cannot go outward. You have to come inward only. So this will be your ROC. Everything will be in the ROC. So what you will write down your ROC as? That my ROC is entire Z plane, including 0 but excluding infinity. Entire Z plane but excluding infinity, because at the infinity I am having a pole. Infinity I am having a pole. Now tell me one thing, what kind of ROC you are getting? Inward to the innermost pole. This pole could be innermost as well, this pole could be outermost as well, because we are having only one pole. So it is inner to the innermost pole. It is looking towards inside. That means u of minus and minus 1 would come. So it has to be anticausal. And is it anticausal? Yes. So if your ROC was in the strip form, then it was non-causal. Why it is in the strip form? 0 to infinity. It is there between 0 and infinity, because there were two poles. Two poles were there, 0 and infinity were the poles. So your ROC was between 0 and infinity. It was in the strip form. Since it is in the strip form, non-causal. Here ROC was looking outside. ROC was looking outside. ROC was looking outside, 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 outside. So outer to the outermost pole. That means it was causal. And inner to the innermost pole, inside, then it is anticausal. There you go. So the bottom line is strip form means non-causal. In case of Z transform, strip form means non-causal. Outer to the outermost pole. To outermost pole. That is causal. And inner to the innermost pole. Anticausal. But this time pole will include 0 as well and infinity as well. So you need to take care about 0 and infinity. That's why when we were finding the poles of x of z, at that time I told you that you always need to check at 0 and infinity. So are you able to understand the importance of 0 and infinity? Right? You are able to understand the importance, because if I check at 0 and infinity, then I will be able to tell that it is inner to the innermost pole. Then surely it is a finite duration and finite amplitude signal. Surely it is a finite duration and finite amplitude signal or finite amplitude sequence, because ROC is entire Z plane. But if it is not including infinity, that means it is looking towards inside, so it has to be anticausal. If it is not including 0, that means it has to be outside, that means it has to be causal. And if it is not including both 0 and infinity, that means it will be between 0 and infinity, that means it will be non-causal. So if I just give you the ROC, will you be able to tell me that whether it is causal, non-causal, or anti-causal? Surely you will be able to tell me. If I give you the ROC, will you be able to tell me that the signal will be causal, non-causal, or anti-causal? Surely you will be able to tell me, right? So a very good concept we have seen. Just answer this particular question. For every finite duration signal, ROC is entire Z plane. This was finite duration signal, right? What was the ROC? Entire Z plane. Entire Z plane, excluding Z equals to infinity. excluding z equals to infinity. This was the ROC, right? Here what was the ROC? Entire z plane. Entire z plane excluding z equals to 0. Here it was entire z plane excluding z equals to infinity. Here it was entire z plane excluding z equals to 0. Here it was entire z plane excluding 0 and infinity. And here it was for delta n, it was entire z plane. What was the ROC? Here ROC was entire z plane. Entire z plane. This is also finite duration and finite amplitude. This is also finite duration plus finite amplitude. This is also finite duration plus finite amplitude. Finite duration plus finite amplitude. And this is also finite duration plus finite amplitude. And this is also finite duration plus finite amplitude. So for finite duration plus finite amplitude, we are having 4 kind of ROC. Delta n was having entire z plane. Then non-causal sequence was having entire z plane excluding 0 and infinity. Then your causal sequence was having entire z plane but excluding z equals to 0, and your anti-causal signal was having entire z plane but excluding z equals to infinity. So all 4 kind of ROCs are possible. So this statement is wrong. But if xn is equals to delta n, then ROC will be entire z plane. For a finite duration causal sequence, ROC will be entire z plane excluding z equals to 0, because z equals to 0 and then looking outward. Z equals to 0 looking outward, and if it is looking outward, that means it has to be causal. For a finite duration anti-causal sequence, ROC will be entire z plane but excluding mod of z equals to infinity. So you are not going to mug up anything. You are going to understand, okay, if I am excluding z equals to infinity, what does that mean? That at z equals to infinity there would be a pole. If there is a pole and you are saying that ROC is entire z plane, that means ROC would be looking inside. And if it is looking inside, that means it has to be anti-causal. And if you are excluding 0 and infinity, that means you are having poles at 0 and infinity. If you are having poles at 0 at infinity and you are saying that ROC is entire S plane, what does that mean? That means ROC is in the strip form between 0 and infinity. So if ROC is in the strip form, that means it has to be non-causal. Okay, so these are the correct statement. A very, very good question it is. 99.95% of the aspirant will fail here. I can guarantee you. Either they will mug it up or they will not even study it. So you are neither mugging it up and you are neither ignoring it, nor you are ignoring it. You are understanding the concept. And again in the next lecture we are going to understand about ROC more, so there it will be more clear. Now you need to find the Z transform of repeating sequence. Along with that you need to tell the ROC as well. Okay, so this kind of thing we have seen in our S transform as well, like in our Laplace transform as well, we have seen this kind of thing, like these kind of repeating signals were there. So what did we tell? That ROC was sigma greater than 0. So here what would be the ROC? ROC would be Z greater than 1. If sigma greater than 0, that means this particular ROC. So what is this axis? Mod of Z equals to 1, no? Right? But some another thing will come into action here. What is that thing? Let's check that. So what is happening here? 1 2 3 1 2 3 1 2 3, that is being repeated. So what I will do? I will assume a new function y of n which is 1 2 3 only. Right? Now can I write down my x of n as y of n plus y of n minus 3 plus y of n minus 6 and so on. Basically y of n is 1 2 3. So 0 1 2 1 2 3. Now what will be your y of n minus 3? That means it will be shifted by 3. So here this 0 will come to 3, this 1 will come to 4 and this 2 will come to 6. So 3 4 5, sorry, this 2 will come to 5 and this will be 1 2 3, and then y of n minus 6, that means this will be shifted by 6. So 0 will come to 6, 1 will come to 7 and 2 will come to 8, this thing and then this thing, right? And if you add them up, what will happen? 0 1 2 is 1 2 3, then 3 4 5 is 1 2 3, 6 7 8 is 1 2 3. Basically this is n equals to 0 1 2 3. So at n equals to 3 you are expecting that 1 should come. So at n equals to 3 1 is coming, but what you need to do, you need to add them up. If you add these samples, what will happen? 0 1 2 1 2 3 3 4 5 1 2 3. 6, 7, 8, 1, 2, 3, and so on. So this is how I can write it down, right? So what it would be equals to, your x of z would be equals to y of z plus z to the power minus 3, y of z plus z to the power minus 6, y of z, and so on, right? Now y of z I can take common, 1 plus z to the power minus 3 plus z to the power minus 6, and so on. Can I add it? I know the addition formula. What that would be? A upon 1 minus common factor. But when I apply the formula, what do I write down? The common factor should be less than 1. So from here what I am getting, that 1 by z to the power 3 should be less than 1, or you can say z to the power 3 should be greater than 1, or you can say mod of z should be greater than 1. So this is what you are getting. So this is the condition you are getting, which is your ROC. So in continuous time, what was the scene? Laplace transform was saying that sigma should be greater than 0. So sigma equals to 0 is mapped to mod of z equals to 1, right? Because if sigma is equals to 0, that means your mod of z would be equals to 1. There you go, right? But let's find out y of z as well, because y of z can create some problems. Because I only consider this particular thing, no? Let's see y of z as well. Let's once see y of z. So let's find out y of z. So what is your y of n? What is your y of n? This is your y of n. Y of n was 1, 2, 3, and there you go. So y of n can be written as delta n plus 2 delta of n minus 1 plus 3 delta of n minus 2. Say yes or no. Agreeing to this point, right? So 1 plus 2z inverse plus 3z to the power minus 2. This is your y of z. So now what will be your final x of z? So your final x of z is coming out to be 1 plus 2z to the power minus 1 z to the power minus 2 divided by 1 minus z to the power minus 3. This is the final answer that is coming. From here you can see that pole is at 1. This pole is at 1, because if you put 1 here, 1 plus 2 plus 3, and from here as well you are getting the pole at 1. But I always told you one thing, that always check at 0 and infinity. Always check at 0 and infinity. So if I put 0, what I will be getting? 1 plus 2 by 0, 3 by 0, 1 minus 1 by 0, because this is 1 by z cube. So you are getting infinity by infinity form, right? So what we can do is that, let's make it better. This is your x of z. So I can multiply with z to the power 3 on upper side as well, downward side as well. Why I am doing so? Because if I multiply with z to the power 3 on upper side, what I will get? Z to the power 3 plus 2z square plus 3z divided by z to the power 3 minus 1. This kind of expression I will be getting. If I put 0 here, what I am getting? 0 plus 0 plus 0 divided by 0 minus 1, 0. So z equals to 0 is not a pole. What I am saying is that this x of z in a better manner could be written as, this x of z in a better manner could be written as, upper side and downward side you can multiply with z to the power 3. So z to the power 3 plus 2z to the power 2 plus 3z divided by z to the power 3 minus 1. And if you check at z tending to 0, what you are getting? 0 plus 0 plus 0 divided by 0 minus 1, which is equals to 0 only. And if you check at z tending to infinity, then what you are getting? If you check at z tending to infinity, so this guy will be largest one, so everything else will be ignored. So these and these will be ignored. So z cube divided by z cube, what you are getting? 1. So both are not poles, not poles. So only one pole is there. Only one pole is there. What is that? Mod of z equals to 1. So what I will do? What I will do is that I will make a circle. This is another method that I am telling. From here as well you have got the condition. Second one is find out the poles. From here this condition we got. We are happy. But let's check the poles as well, right? Let's check the poles as well. Because poles could be there at 0 and infinity, and poles are there at 0 and infinity, then they have the ability of ruining the party. Because if there was a pole at infinity, then the scenes would have been different. Infinity would not be included. So answer would be written as mod of z greater than 1 but less than infinity. This sign will not be there, and this sign matters. In case of z transform, this sign matters. Okay, so they can ruin the party. That's why I checked at 0 and infinity as well. So I got to know that only one pole is there. So what I will do, I will draw a circle of mod of z greater than 1. Now there are two chances, outside or inside. You see the signal? What kind of signal it is? Causal, right? What kind of signal it is? Causal. That means u of n is there. What does that mean? ROC will be outer to the outermost pole. Outer to the outermost pole. So this would be the ROC. Okay. So okay, here I should have written mod of z equals to 1. So ROC is, in these kind of questions, if they want to ask anything, they will ask ROC only, nothing else. Okay, if they want to frame the question from this particular topic, they will only ask the ROC. So that would be mod of z greater than 1. Is that clear to you? Just one thing I have done now. The same question is there, just it is shifted. Now what kind of signal it is? Non-causal. What kind of signal it is? Non-causal. So do you expect your ROC to be mod of z greater than 1? No. Do you expect this ROC to be there? No. It would be mod of z greater than 1 but less than infinity, because it has to be in the strip form. It has to be in the strip form. Look, let me know what kind of signal it is. Right sided. You agree? Right sided. This is a right sided sequence. Right sided sequence. If it is a right sided sequence, so think about it. Right sided sequence. Right sided sequence. What was the ROC? Sigma greater than 0. That means what should be the ROC? Mod of z should be greater than 1. But here you wrote down sigma greater than 0 for causal signal, for non-causal signal as well, for causal signal as well. For both of them this was correct. But in z transform, what is the condition? In z transform you need to care of infinity as well. So if mod of z greater than 1 is your answer, if mod of z greater than 1 is your answer, that means you are saying that it is not in the strip form. And if it is not in the strip form, that means it could not be non-causal. But you can see the signal is non-causal. So it has to be in the strip form. And surely mod of z greater than 1 will also be there. That means there has to be a pole at infinity. So there has to be a pole at infinity. So that's why the ROC would be this. So without even calculating anything, I can tell the answer. If someone asks you this particular sequence is given, what would be the ROC? So you can see that it is a right-sided sequence. So I expect that ROC would be mod of z greater than 1. But wait a minute, it is a causal sequence. If it is a causal sequence, that means it is a non-causal sequence. If it is a non-causal sequence, that means ROC has to be in the strip form. And if you need the strip form, then mod of z greater than 1, so it has to be less than something. And what that something is there? That something is infinity. So that's why you will get the strip form. Is that clear to you or not? Let's check it out. You will see that you will get a pole at infinity. Surely you will get a pole at infinity. You can check out on your own. So what I would do, I will consider this as y of n. So same y of n is there. Same y of n I am going to consider. 1, 2, 3. Same y of n I have considered. So how I can write down my x of n? So this is your y of n. This is your y of n minus 3. This would be your y of n plus 3. Right? So y of n plus 3 plus y of n plus y of n minus 3 plus y of n minus 6 and so on. So what x of z you will get? Y of z, from here you will get z to the power 3. This is simply y of z only. From here you will get z to the power minus 3. From here you will get z to the power minus 6 and so on. So y of z a upon 1 minus r. What is the value of r? Z to the power minus 3. So this is your x of z. So from here it will look like that. Sir, if I apply the formula a upon 1 minus r, that means my common factor should be less than 1. So from here the condition is coming this only. So is this the ROC? No. I need to care about this y of z as well. and I need to take care about this z to the power 3 as well. From here, this is the condition that is coming, but this is not the final answer. I know one particular thing, that if it is a non-causal signal, so surely it has to be in the strip form, right? So now what will be your y of z? What is your y of z that we have already calculated here in the previous question only? Y of z is 1 plus 2z inverse plus 3z to the power minus 2. So 1 plus 2z inverse plus 3z to the power minus 2 into z to the power 3 divided by 1 minus z to the power minus 3. This is the condition, right? From here I calculated the y of z. Y of z would be the same, no? Because y of n I am taking the same only. The same y of n I am taking. So y of z would be the same. This y of z I have calculated. So 1 plus 2z inverse plus 3z to the power minus 2. So what you are getting? Z to the power 3 plus 2z, z to the power 3 plus 2z square plus 3z divided by 1 minus z to the power minus 3. So downward side I don't want z to the power minus 3. So what I will do, on upper side and on downward side I will multiply with z to the power 3. So upper side as well I am multiplying with z to the power 3. So what I am getting, and on downward side as well I am multiplying with z to the power 3. So this is what I am getting. Say yes or no? Okay. Basically I want it in this linear form. I don't want this z to the power minus 3 and all these kind of things. That's why I multiply with z to the power 3, because calculation will be easy. That's the bottom line. To make the calculation easy, that's why we multiplied. The answer could be given this one as well, it could be given this one as well, it could be given this one as well. But we need to check the poles now. So pole directly I can see, one pole I can directly see here, that would be z equals to 1 for sure, right? Z equals to 1 pole I can directly see here. Let's write down x of z. Just 1 second guys, just 1 second. Yeah, sorry for the interruption. So x of z is z to the power, x of z is z to the power 6 to z to the power 5, z to the power 6 to z to the power 5 plus 3z to the power 4 divided by z to the power 3 minus 1. Yeah, so now I am saying that one pole is at 1. From here you will get a pole at 1. Now some guys can argue that, sir, more poles could be also be there, no? Basically to find the poles, what you need to do, put this equals to 0. So z cube minus 1 can be written as z minus 1 into z square plus z plus 1 is equals to 0. So from here you are getting the pole at 1, and from here as well you are getting two poles, no? Minus 1 plus minus under root b square minus 4ac upon 2a. So what you are getting? Under root 3j divided by 2. So yeah, actually we are getting these three poles. This pole that is at 1, another pole minus 1 plus under root 3j by 2, and then third pole minus 1 minus under root 3j by 2. So these three poles we are getting, but for all of them mode of z is equals to 1 only, no? So basically if I make the ROC, if I make if I plot these poles, so one pole at 1, another pole at minus 1 plus under root 3 by 2, and minus 1 minus under root 3 by 2. So all these three poles will come on one circle only with the radius of 1. So what I mean to say is that if I make a circle of radius 1, if I make a circle of radius 1, then all the poles will be lying on this circle only. All these poles will be lying on this circle only. So this would be zp1, which is equals to 1 here, zp1 is equals to 1. Yeah, so here minus 1 by 2 plus under root 3j, somewhere here and somewhere here. All these three poles are lying on this unity circle only, which is mode of z equals to 1. But another thing is there, you need to check at 0 and infinity. So if you check at 0, z equals to 0 is not a pole. You can directly see if I put 0 here, 0 plus 0 plus 0 divided by 0 minus 1, I will be getting 0 only. So z equals to 0, not a pole. But if you check at z equals to infinity, if you check at z equals to infinity, what you will be getting? Z to the power 6, all these will be reduced to 0. So only z to the power 6 will left, because this is the maximum one, and here z to the power 3 will left. It will cancel down, and what you are getting? Limit z to the power infinity, z to the power 3. What that would be equals to infinity only. That means yes, it is a pole. So you are having these poles: infinity, 1, minus 1 by 2 plus under root 3 by 2j, and minus 1 by 2 minus under root 3 by 2j. Okay, so these poles are there. So these three poles are lying on mode of z equals to one circle only. These three poles are lying on mode of z equals to one circle only, but this pole is mode of z equals to infinity. So the other pole is mode of z is equals to infinity. This is the other pole. The pole is z equals to infinity, so circle will be mode of z equals to infinity. The circle will be mode of z equals to infinity. This would be the other circle, mode of z equals to infinity. Now what all are the possible region of ROC? There is nothing beyond z equals to infinity, so this region could not be there. So region could be this one. Basically this could be the ROC, or this could be the ROC. You know one thing, what do you know? That this is a non-causal signal, and if it is a non-causal signal, then this ROC is not possible. Why is that so? Because for a non-causal signal, ROC has to be in the strip form. If there was a 0 here, if there was a pole here at z equals to 0, then I could have said that yes, this ROC is possible, because it would become a strip form. But now there is no 0 here. At z equals to 0, there is no 0. So it is not becoming a strip form. If I say this is my ROC, so it is not becoming a strip form. So this has to be the ROC. Which has to be the ROC? ROC has to be in the strip form. So this has to be the ROC. This is necessary that this has to be the ROC. So this is your ROC. So what is your ROC? Mode of z greater than 1 but less than infinity. Infinity is not included. So I told you this answer we got even before doing the calculation. Even before doing all these calculation, this answer we already got. So you know that finding y of x of z will be very easy for me. I can find out x of z very easily. For finding out the ROC, I don't need to do all this process. I don't need to do all this process. For finding out the ROC, what I will think is that, okay, this is a right-sided sequence. If it is a right-sided sequence, in my continuous time it was sigma greater than 0, so here it would be mode of z greater than 1. But wait a minute, in continuous time there was not a issue of 0 and infinity. Now, what I would see is that this is a non-causal signal. If it is a non-causal signal, that means ROC has to be in the strip form. So it cannot be purely mode of z greater than 1. It has to be mode of z greater than 1 less than infinity. There you go, this is the answer. That's it. So this I will find out, and then this is the ROC I will be able to write down within seconds. And most probably, if they want to ask this question, if they want to ask any problem from this particular topic, then they will just mention this x of n, and then they will ask you what will be the region of convergence of x of z. So there you don't need to do all this process, you just need to think there. So here think and let me know what will be the ROC. So first what I will see, it is a left-sided sequence. It is a left-sided sequence. So in continuous time the condition was for left-sided sequence sigma should be less than 0. Sigma should be less than 0. That means here the condition would be mode of z should be less than 1. But the 0 may create a problem, because I told you in case of discrete time, z equals to 0 and infinity both are important, right? Then I will see that what kind of signal it is, anti-causal. And if it is anti-causal, that means it cannot be in the strip form. It has to be purely mode of z less than 1. That means the ROC will be mode of z less than 1 greater than equals to 0. That means 0 will be included now. There will not be any pole at z equals to 0. This is the conclusion we can make. just by looking at the sequence, I can make the conclusion that there will not be any pole at z equals to 0. Because if it is an anti-causal signal, it cannot have a pole at z equals to 0, because if it is having a pole at z equals to 0, then the ROC will not include 0. So ROC will become a strip. But for anti-causal signal, ROC cannot be a strip. If it is a strip, then ROC has to be, then the signal has to be, or the sequence has to be non-causal. So since it is anti-causal, so 0 has to be included. So this would be the correct ROC. Okay, in the options this will also be mentioned, and surely this will also be mentioned. So you need to click on this one, 0 included. Why 0 is included? Because it is an anti-causal signal. If it is an anti-causal signal, that means ROC will be inside. ROC will be inside. ROC will be inside this circle. It cannot be in the strip form, because if you are saying that you are having a pole at z equals to 0, then it will be in the strip form. So there is no pole at z equals to 0. That means this z equals to 0 will surely be included. All good? So directly I can tell the ROC, although let's do it with the concept. So what I will do, I will consider y of n. I will consider y of n as 3, 2, 1. This is my y of n. So y of n I can write down as delta of n plus 2 delta of n plus 1 plus 3 delta of n plus 2. From here y of z is coming out to be 1 plus 2z plus 3z square. Right? Now x of n can be written as y of n plus y of n plus 3. Right? If you shift this signal by 3, plus 3 means there will be left shift, and then plus 6, and in that manner you keep on adding it up. So what you will be getting, x of z as, this will be your y of z. Here z to the power 3 will come outward, here z to the power 6 will come outward, and it will keep on going. Basically this will throw y of z, this will throw z to the power 3 y of z, this will throw z to the power 6 y of z, and so on. So y of z will come outward, 1 plus z to the power 3 plus z to the power 6, and so on. So what will be your x of z? X of z will be a upon 1 minus r. R is the common factor. Right? Common factor. What is the common factor here? Z to the power 3 is the common factor. Z to the power 3 is the common factor. So mode of common factor should be less than 1. So what is the ROC you are getting? Mode of z should be less than 1. But this is not the final answer. Always you need to check at infinity and 0 as well. Right? So x of z, 1 plus 2z plus 3z square divided by 1 minus z cube. So I will check at 0 and at infinity as well. So infinity is also not a pole and 0 is also not a pole, because if you put z equals to 0 here, 0, 0, 1, 1 divided by 1, it would be 1 only. So z equals to 0 is not a pole, and z equals to infinity is also not a pole, because this will become infinity, this will become z cube, and upper side z square will be there. So this part and this part will get cancelled. 3 by infinity, that would also result in 0 only. So z equals to 0 and z equals to infinity, both are not the poles. You can check on your own. So what I am saying is that only pole is z equals to 1. Z equals to 0 and infinity are not poles. So only pole is 1, right? So if I make the ROC, what I will do, I will make this unity circle. Which is mode of z equals to 1. Now there are two chances. ROC could be outside, ROC could be inside. So you will look at the signal. Signal is left sided. If it is left sided, that means ROC will be inside. So this will be the ROC. ROC will be looking inside. So this will be the ROC. This will be the ROC. So mode of z less than 1, this is the ROC. Okay, well and good. Next signal is non-causal. This particular signal is non-causal. So let me know what will be the answer. You just directly let me know what will be the ROC. So what you will see first, this is a left-sided sequence. For left-sided sequence, condition was sigma less than 0. So it should be mode of z less than 1. But for continuous time it would work. But here what will be the scenario? That it is a non-causal sequence. And since it is a non-causal sequence, So for non-causal sequence, the ROC has to be in the strip form. And if it has to be in the strip form, that means surely there has to be a 0 at z equals to 0. So there will be, surely there has to be a pole at z equals to 0. So surely there will be a pole at 1, but along with that there will be a pole at 0 as well, for sure. Without even calculating, I can tell that. Because it is non-causal, and if it is non-causal, then it has to be in the strip form. If it has to be in the strip form, that means it cannot include 0. Are you able to understand this point or not? And let's check, you will get the same answer. Y of n is same only. So x of n can be written as y of n is same. There is left shift as well, there is right shift as well. So what I will write down here, y of n minus 3 plus y of n plus y of n plus 3 plus y of n plus 6. So left and right both shift are there. So what you will be getting, z to the power, this will give you z to the power minus 3 y of z. So y of z I can take common, z to the power minus 3 plus 1 z to the power 3 z to the power 6 and so on. Y of z a upon 1 minus r, right? This is your x of z. What is your y of z? Your y of z is 1 plus 2z plus 3z square. 1 plus 2z plus 3z square z to the power minus 3 divided by 1 minus z cube. When you applied this formula, what is the condition was there? That your common factor, what is the common factor? Z to the power 3 should be less than 1. That means this is the condition you got. When you applied this formula, when you applied the formula of a upon 1 minus r, this is the condition you were getting. But here, x of z is this. This is your x of z. What I can do? I can multiply with z to the power 3 upper side and downward side, because I don't want any negative power. I don't want any negative power, so I will multiply with z to the power 3 upper side as well and downward side as well. So what I will be getting? 1 plus 2z plus 3z square, z to the power 3 will be cancelled, divided by z to the power 6, sorry, z to the power 3 minus z to the power 6. This is what I will be getting. Now at 0, what is the condition? Are you having any pole at 0? So what you will be getting? 1 plus 2 into 0 plus 3 into 0 square divided by 0 minus 0. So 1 divided by 0, infinity. Yes, it is a pole. So surely you are getting a pole at z equals to 0 as well. You are getting a pole at z equals to 0. At infinity, you are not getting any pole. You can check that. Because at infinity, what will happen? 3z square divided by z to the power 6. So 3 divided by z to the power 4. If you put infinity, what is the answer you are getting? 0. So at z equals to infinity, you are not getting a pole. You should get a pole, then it should have been infinity. If it is not infinity, that means there is no pole at infinity. So there are only 2 poles. You got only 2 poles. One pole is at 1 as well, right? If you put the downward equals to 0, what you are getting? 1 minus z to the power 3. So 0 pole also you are getting. Along with that, you are getting pole at 1 as well, and then these poles as well. The same pole that we calculated here, minus 1 plus under root 3 by 2 j. All these poles you will be getting. Basically, mod of z equals to 1 you will be getting. Z equals to 1 you will be getting 1 plus under root 3j by 2 you will be getting, and minus 1 minus under root 3j by 2 also you will be getting. So all these poles you will be getting, all will be lying on unity circle only. So 2 kind of circle you will make. One circle will be infinity, other circle will be z equals to 0. So 2 circles are there. This circle and this is the another circle. So 2 kind of circles are there. Z equals to 0 and z equals to, sorry, I should have written mod of z equals to 0 and mod of z equals to 1. So 2 possible regions are there. This could be the ROC or this could be the ROC. So what will be the ROC? This is saying mod of z less than 1, or what you will do, you will go to the signal. You will see that the sequence is non-causal. If it is non-causal, it has to be in the strip form. So if I say this is the ROC, it will not be in the strip form. So if I want to make it in the strip form, the ROC has to be this one. This has to be the ROC. So if this is the ROC, that means there you go. Okay, sorry. This should not be included. So what is the difference in the ROCs here? Here 0 is not included, but here the 0 was included. You could have written down the ROC in this manner, less than 1, but 0 is included. So if non-causal is there, then he will create some problem. Anti-causal, no issue. It will be left, it would be inner to the innermost pole. Causal, outer to the outermost pole. But if it is non-causal, then there is an issue. It will be in the strip form. So it will be between 1 to infinity. Infinity will not be included. And here it will be between 1 to 0 to 1 with 0 not being included. Is that clear to you? Is this discussion clear to you? A very, very good discussion and a very, very important point as well. Okay. Let's move to the next one. Find the ROC of the following sequences. So following sequences are given: A, B and C. You need to tell the ROC. Think about it. This is your x of n. So how your x of n can be written? Can it be written as a finite duration plus finite amplitude sequence? Finite duration, finite amplitude sequence, which is non-causal. Which is non-causal. Plus u of n minus 2. This much, and this is un only, u of n minus 2. Finite duration plus finite amplitude. So this will say that my ROC is entire z plane. What this will say? My ROC is entire z plane. But you need to wait a minute. It is saying that it is non-causal. Non-causal means it has to be in the strip form. If you want the strip form, that means both 0 and infinity should not be included. Is that clear to you or not? So it was a finite duration plus finite amplitude sequence which was non-causal. So you saw that finite duration plus finite amplitude, that means ROC should be entire z plane. But since it is non-causal, so non-causal has to be in the strip form. Non-causal has to be in the strip form. So that means there has to be a pole at 0, there has to be a pole at infinity as well. So then only it can be in the strip form, no? It has to be in the strip form. Right? So 0 and infinity both are not included. And what this guy will say? This guy will say mod of z greater than 1, u of n minus 2. So u of n minus 2, z upon z minus 1. What is this? Un. U of n minus 2. That means if you multiply u of n minus 2, so z, this is your un. U of n minus 2, what you will do? Z to the power minus 2 into z divided by z minus 1. So 1 upon z into z minus 1. So you can see one more thing, that at z equals to 0 as well there is a pole. At z equals to 0 there is a pole, and there is a pole at z equals to 1 as well. So there are two poles, 0 and 1. But since it is un, so this will be the ROC. So for this one the ROC will be mod of z greater than 1. So u of n minus 2 is saying that ROC is mod of z greater than 1. Did you understand what is the issue here? U of n minus 2 is this one. U of n minus 2 is having a z transform of this one, because u of n is z upon z minus 1. U of n minus 2 means z to the power minus 2. So z to the power minus 2 into z, that would be 1 by z. So 1 by z into z minus 1. So what would be the poles? 0 and 1. 0 and 1. Since it is un, that means ROC has to be outer to the outermost pole. Outer to the outermost circle, or you can say pole. So what will be the ROC? Mod of z greater than 1. So this is saying mod of z greater than 1, and some guy is saying 0 to infinity, between 0 to infinity. So what will be the total answer? That it would be greater than 1 and less than infinity. There you go. This is the final answer. So for ROC for this particular sequence will be greater than 1 and less than infinity. And kind of you can think as well, because what it is, right-sided sequence plus non-causal. So if it is right-sided, if it is right sided, that means mode of z should be greater than, no, that concept will be wrong actually. You cannot say right sided. Right sided plus periodic has to be there, no. This concept that mode of z greater than 1 less than 1, right sided plus periodic, then only it would work, no. Otherwise, like let's just say the signal is 2 to the power n un. This is also right sided. So can you say ROC will be mode of z greater than 1? No. Right? Here the ROC will be mode of z greater than 2 because this is not periodic. So the answer that we gave, that sigma greater than 0, we compared with sigma greater than 0. Sigma greater than 0 means mode of z greater than 1. That was only valid for periodic one. Only valid for periodic signal. Right? Not for any random signal. Not for any random sequence. For random sequence, you know how to find the ROC. Find the x of z and then take the poles. Here also you can do the same thing. Find x of z, take the poles. But here also we can use our brain as well. How we will use the brain? We will use the brain in a manner that we will see causal, non-causal, we will see it is periodic as well. Then mode of z greater than 1, mode of z less than 1, these kind of things will be there. Along with that, causal, non-causal, anti-causal I need to check. If it is non-causal, that means it has to be in the strip form. If it is anti-causal, then it will be inner to the innermost pole, and if it is causal, then it will be outer to the outermost pole. Now what about this one? This is your right-sided sequence plus periodic plus non-causal, and this condition we have already seen. Right-sided sequence, that means sigma greater than 0, so mode of z greater than 1, but it is non-causal, so it has to be in the strip form. There you go, this is the answer. This will not be included, because if it is included, then it will not be in the strip form. So it cannot be included because it is non-causal, so you need the strip form. Is that clear to you? So this will be the answer of the second one. This is the answer of the first one. What about this one? It is diverging to infinity. Here also it is diverging to infinity. Basically it is keep on rising up, no? It is keeping on rising up. Here also it will keep on rising up. That means x of z does not converge. Basically, do you remember the 2 to the power mode of n? Here what did we say? That x of z is not converging. If you draw the graph, what will happen? It will keep on rising up. 1, 2, 4, 8, and similar here as well. So if graph keeps on rising up, that means it will never converge. The z transform will never converge. Say yes or no. Okay. In both of the direction, if it keeps on rising up, so your z transform will never converge. All good? All fine? So in both direction it is rising up. Here also it is rising up. Here also it is rising up. So x of z will not converge. So that's it. This is the end of. I guess this part I will add in the next video only. Like the previous video will be of 2 hours. Now this video is of roughly around 75 minutes. So in the continuation of this video, you will see some more part. In this continuation of this particular video, you will see some more part. There also we will do the discussion on ROC only. So mostly in this particular video, we did the discussion on ROC. So we will continue this discussion on ROC in this particular video. Okay then, yeah, thank you very much. Let's meet in the second part of this video. I will take a break now. Yeah, thank you. Yeah, hi everyone, welcome back. So you need to find the z transform of all the given signals, and you need to tell the ROC as well. Okay, so let's see the first one. X of z, z upon z minus 2 plus z upon z minus half plus z upon z plus 3 by 2. So for now you will forget the ROC. You just let me know what will be the z transform of the second one. This will also be z upon z minus 2 plus z upon z minus 1 by 2 plus z upon z minus 3 by 2. Same answer would be there, right? For the second one as well, for the third one as well, and for the fourth one as well. So all 4 are having the same x of z. All 4 are having the same x of z. This is how I have set up the problem, that all 4 will be same x of z. But the difference is, this is a causal signal, right? un, u of minus n minus 1, u of minus n minus 1, u of minus n minus 1, that means this is an anti-causal signal. And what is this? Here u of minus n minus 1 is also there, and u of n is also there. What does that mean? It is towards the plus infinity as well, and it is there towards minus infinity as well. That means it is there in positive side as well and negative side as well. What does that mean? It is non-causal. and this one will also be non-causal because un is also there, u of minus n minus 1 is also there, u of minus n minus 1 is also there. So this will be non-causal. So this is the scenario: causal, anti-causal, non-causal, non-causal. So both will have different ROCs, but x of z would be the same. For all of them, x of z would be the same. Let's find out the ROCs. So for the first one, un, un, un. So this will say mod of z greater than 2, this will say mod of z greater than 1 by 2, and this will say mod of z greater than 3 by 2. So mod of z greater than 2, mod of z greater than 1 by 2, and mod of z greater than 3 by 2, right? This is the scene. So what will be the common region? Common region would be mod of z greater than 2. So this is the ROC of the first one. What about the ROC of the second one? This will say mod of z less than 2. First one will say mod of z less than 2. Why is that so? Because of u of minus n minus 1. This will also say mod of z less than 1 by 2. This will also say mod of z less than 3 by 2. So mod of z less than 1 by 2 and mod of z less than 3 by 2. So what would be the ROC? Mod of z less than 1 by 2 only, right? And where are the poles? Let me know the poles. Poles are 2, 1 by 2 and minus 3 by 2. That means circles would be 2, 1 by 2 and 3 by 2. So 3 circles will be made. When I make the ROC, 1 by 2, 3 by 2 and 2. These 3 circles will be made, right? And based on that, ROC would be there. For the first one, it is outer to the outermost pole. For this one, it is inner to the innermost pole. What is this? Outer to the outermost pole. Just 1 second, guys. Yeah, this was outer to the outermost pole. Outer to the outermost circle, I would say. And this is inner to the innermost circle. Let's see for the third one. So for the third one, this will say mod of z less than 2. The second one will say mod of z greater than 1 by 2. And the third one will say mod of z greater than 3 by 2. Right? Because this is a scenario, mod of z greater than 3 by 2. So what will be the common region? Greater than 3 by 2 and less than 2. What is this? Strip. This is in the strip form. And you can check here as well that there are no poles at z equals to 0 and infinity. So these are the poles, but I always need to check at 0 and infinity as well. This I forgot here. So if I check at 0, so 0 divided by 0 minus 2, 0 divided by 0 minus 1 by 2, 0 divided by 0 plus 3 by 2. So there is no pole at 0. Z equals to 0 is not a pole. Not a pole. And then you need to check at z equals to infinity as well. Check at z equals to infinity. So if you put z equals to infinity, then this will be gone, this will be gone, and this will be gone. So z by z, z by z, z by z. So 1 plus 1 plus 1. So answer is 3. So z equals to infinity is also not a pole. Because at the pole you expect that your x of z should tend to infinity. But it is not tending to infinity. That means z equals to 0 and z equals to infinity. Both are not any poles. So only these poles are there. Only these poles are there, which are these one. Okay. So this is in the strip form. For the last one, what is the scenario? Mod of z less than 2, mod of z less than mod of z less than 2. Second one is saying mod of z greater than 1 by 2, and the third one is saying mod of z less than 3 by 2. So what is the region? It should be less than 3 by 2, it should be greater than 1 by 2, it should be less than 2. So it would be greater than 1 by 2 and less than 3 by 2. So again it is in the strip form, right? So outer to the outermost pole, it was supposed to be causal. Yes, it is causal. Inner to the innermost pole, it was supposed to be anti-causal. Yes, it is anti-causal. Strip form, non-causal, non-causal. Yes, everything is fine. Let's make the ROCs. So all the circles actually should have been, I should have made the circles in a good manner. If I do it for everyone, then it will take a lot of time. So what do I do? Should I pause the video once? Okay, I will pause the video once and then I will make the circle in a good manner. Yeah, so these are the circles. So for the first one, ROC was mod of z greater than 2. First one, ROC was mod of z greater than 2. Right? This is the ROC for the first one. For the second one, it was inner to the innermost pole. This was the ROC. For the third one, it was in the strip form. Third one, it was in the strip form. What was the 3 by 2 to 2? 3 by 2 to 2. So between 3 by 2 to 2. This was the region of ROC. And for the next one, this was the region of ROC. Is that clear too? So if it is in the strip form, that means non-causal. If it is inner to the innermost pole, anti-causal. And if it is outer to the outermost pole, causal. There you go. Okay. Let's see the next one. In the next one, what we have done, we have given a shift of 2. So left shift we have given. So let me know whether it is causal or anti-causal or non-causal, what it is. U of n plus 2. That means it is starting from minus 2. So this has become a non-causal signal, right? Because from minus 2 to infinity it is going. So this is a non-causal. What about this one? Minus n minus 3. Starting from minus 3 going towards minus infinity. It is anti-causal only. And surely this is having u of n as well, u of minus n as well. So surely it will be non-causal. And this is also non-causal. So this is the scenario here. Here there is no causal signal. Non-causal and anti-causal only are there. Let's find out x of z. So for all of them, x of z is the same. You can check on your own. For all of them, x of z is the same. What is x of z? 2 to the power n un. 2 to the power n un. What it would have given? Z upon z minus 2. But what we have done? N plus 2. That means z square will also be multiplied. So it will become z cube. Right? So z cube upon z minus 2 plus z cube upon z minus half plus z cube upon z plus 3 by 2. Well and good. So where are the poles? 2, 1 by 2 and minus 3 by 2. But you need to check at 0 and infinity as well. So if you check at z equals to 0, 0 divided by 0 minus 2, 0 divided by 0 minus half, 0 divided by 0 plus 3 by 2. So it is not a pole, not a pole. But if you check at infinity, what will happen at infinity? At infinity, z cube is as it is. The downward can be written with z only. Z cube divided by z plus z cube divided by z. So it will become 3z square. Limit z tending to infinity, 3z square. So if you tend to infinity, what is the answer you are getting? Infinity only. What does that mean? That's yes, it is a pole. So you are having a pole at 2, 1 by 2, minus 3 by 2 and infinity. So these are the poles. 2, 1 by 2, minus 3 by 2 and infinity. And it was expected as well. Because ROC could not be outer to the outermost pole. Now what is the outermost pole? This is the outermost pole. Outermost pole. And what is the innermost pole? This is the innermost pole. Innermost pole. So you can go inner to the innermost pole. Like z less than 1 by 2 is possible. But z greater than infinity is not even possible. So this would be the scenario, no? Just a second, guys. Yeah, so we can go one by one basically. We can go one by one. For the A, this will say that ROC should be mod of z greater than 2. But it will say that it should be greater than 2 but less than infinity. Because in this particular scenario, you can see that there is a pole at infinity. So it will say that ROC should be greater than 2 but less than infinity. Right? So first one will say that ROC should be greater than 2 but less than infinity. Second one will say that ROC should be greater than half but less than infinity. Everyone will say that it should be less than infinity. Why is that so? Why is that so? अरे यार ये क्या कर रहा हूं मैं? Greater than half, less than infinity. Why everyone is saying less than infinity? Because at infinity there is a pole, no? If you consider only this transfer function, or if you consider only this much z cube upon z minus 1 by 2. So you are having a pole at 1 by 2 and you are having a pole at infinity as well. So if you are having a pole at infinity, so what it will say that it should be less than that. You cannot go above that. Are you able to understand this point? Right? So mode of z greater than 1 by 2 but less than infinity for sure. Right? And here greater than 3 by 2 but less than infinity for sure. So what is the total answer we will get? Total answer we will get is that it should be greater than 2. Greater than 2 but less than infinity. And it is in the strip form. This will become a strip form only. So if I just make the diagram, so this was saying greater, this was also saying greater, this was also saying greater, but everything should be less than infinity. That means what would be the ROC? The ROC would be this region. This region would be the ROC. This particular region will be the ROC. Okay, so this region is ROC. So mode of z greater than 2 but less than infinity. If it is in the strip form, it has to be non-causal. And did we expect it to be non-causal? Yes, it was non-causal only. Are you able to understand this point? Okay. For the next one, B, everyone will say that mode of z less than 2. This will say mode of z less than 2. Next one will say mode of z less than 1 by 2 and mode of z less than 3 by 2. So what will be the ROC? Mode of z less than 1 by 2. Inner to the innermost pole. If there was a pole at 0, if there was a pole at 0, then there would have been something different. They would say that it should be less than 2 but greater than 0. But that scenario, there is no pole at 0, so there is no issue. So this would be inner to the innermost pole. Basically, if these poles are mentioned 2, 1 by 2, minus 3 by 2 and infinity, and you want your signal to be causal, is it possible? If you want it to be causal, that means your ROC should be outer to the outermost pole. What is the outermost pole? Infinity. So your ROC should be greater than infinity. Anything greater than infinity is possible? No, it is not possible. That means from these particular poles, you can never make any causal signal. That's it. Okay, very easy. So less than 2, less than 1 by 2, less than 3 by 2. So what will be the region of convergence? This will be the region of convergence. So this will be your region of convergence. And it is inner to the innermost pole. That means it is surely your anti-causal. Or you can say greater than 0 but 0 included. 0 included here. Here also we could have said the same thing, that ROC is greater than 2, less than infinity but infinity included. Right? Here also I could have said the same thing, less than 1 by 2 but 0 included. This is about the first question I am talking about. This question. The very first question, the first slide question. I am talking about the first problem. Here also what I could have, here it is in the strip form only. So between 3 by 2 to 2 and here between 1 by 2 to 3 by 2. C, third one. This will say mode of z less than 2. This will say mode of z greater than 1 by 2. Mode of z greater than 1 by 2 but less than infinity, not including infinity. And the next one will say mode of z greater than 3 by 2. Mode of z greater than 3 by 2 but less than infinity. So what will be the answer? One is saying greater than 3 by 2, one is saying greater than 1 by 2, but one is saying less than 2. So greater, greater but lesser. So what is the common region? This would be the common region. So your common region would be this one. So this would be the region of convergence. This would be the region of convergence. So this will also be non-causal between 3 by 2 to 2. And for the next one, for this one, this will say mode of Z less than 2. The next one will say mode of Z greater than 1 by 2 but less than infinity. And the next one will say mode of Z less than 3 by 2. So what is the scenario? Lesser, lesser, greater. So this will be the region of convergence. Lesser, lesser, greater. You can see the region of convergence. Lesser, lesser, greater. So this is the region of convergence. So what would be the region of convergence? This would be the region of convergence. Between 1 by 2 to 3 by 2. Non-causal. Okay. So here I could have written 3 by 2 to 2. 3 by 2 to 2. And here I could have written 1 by 2 to 3 by 2. This is also strip form. And this is also strip form. All are in the strip form. Okay, well and good. What about this one? 2 to the power n un would have given you z upon z minus 2. So 2 to the power n minus 2 u of n minus 2 would have given you z to the power minus 2 into z divided by z minus 2. That would be z to the power minus 1 upon z minus 2, or you can write down 1 upon z into z minus 2. So a, b, c, d, x of z 1 upon z into z minus 2 plus 1 upon z minus half plus 1 upon z plus 3 by 2. What do you think? Where are the poles? Poles are there at 2, 1 by 2 and 3 by 2 for sure, minus 3 by 2 for sure. 2, 1 by 2 and minus 3 by 2 is for sure. But you need to check at 0 and infinity as well. So at infinity if you check, what will happen to x of z? 1 by z square, 1 by z square plus 1 by z square. And if you put infinity here, and if you put infinity here, everything would be 0. So not a pole. But if you check at 0, so 0 into 0 minus 2 would be 0 only. 0 into 0 minus 1 by 2 will be 0 only. Anything multiplied with 0 will be 0, and that would be infinity. So yes, this is a pole. So you are having a pole. What all are your poles? Poles are there at 0, 1 by 2, minus 3 by 2 and 2. So 4 circles will be made. Where this will be the innermost pole. And this will be the outermost pole. So is it possible to go outer to the outermost pole? Yes, you can go mode of z greater than 2 for sure. This is possible. But is it possible to go inner to the innermost pole? Is it possible? It is not even possible. If it is not possible, inner to the innermost pole you cannot go. That means from these signals you can never get anti-causal signal. Inner to the innermost pole is not even possible. That means anti-causal signal will never be possible. So let's check. U of n minus 2, u of n minus 2, u of n minus 2. N minus 2, breakpoint is at 2. So from 2 to infinity it is going. What does that mean? Causal. Minus n plus 1. Minus n plus 1. Minus n plus 1. That means the breakpoint is at 1. So from 1 to minus infinity it is going. Non-causal. 1 to minus infinity. What about this one? Here u of n minus 2 is also there. From 2 to infinity is also there. And 1 to minus infinity is also there. So surely it is non-causal. and the downward will also be surely non-causal, because here there is a field of u of minus n as well, there is a field of u of n as well. So surely it will be non-causal. Here all the fields are of u of minus n only, but minus n plus 1. Minus n plus 1. What does that mean? That means you are starting from 1. So 1 to minus infinity you are going. That means surely it is non-causal. So you can see that causal, non-causal, non-causal, non-causal. So you are never getting any anti-causal signal. And by the poles as well you can determine it. By the poles directly I can say that I am never going to get any anti-causal signal. So what first one will say? Greater than 2, greater than 1 by 2 and greater than 3 by 2. So for the first one what will be the ROC? For the first one ROC would be this region, outer to the outermost pole, because there is no pole at infinity. If there was a pole at infinity, then there would have been some issue. But outer to the outermost pole. Second one, what it will say? Less than 2 but greater than 0. For the B, I am writing down for the B. What it will say? U of minus n is there, that means less than 2 but greater than 0. Why greater than 0? Because you are having a pole. You are having a pole at 0. If you are having a pole at 0, that means it has to be greater than 0. 0 cannot be included. So less than 2 but greater than 0. What next one will say? Less than 1 by 2 but greater than 0. Less than 1 by 2 but greater than 0. What third one will say? Less than 3 by 2 but greater than 0. So here what you will get? This will be the ROC. So from 0 to 1 by 2. So for the second one, what will be the ROC? This will be the ROC. This is the z, mode of z equals to 0. Mode of z equals to 0. This is the mode of z equals to 0 circle. So the ROC would be this one. This region will be the ROC. So this is also in the strip form only. This is outer to the outermost pole, but this is strip form only. This is your between 0 to 1 by 2. And if it is in the strip form, what does that mean? That means it will be non-causal. In the previous questions, it was anti-causal. In the previous question, if you notice here, anti-causal. Anti-causal. This was also anti-causal, inner to the innermost pole. But since now z equals to 0 is a pole, anti-causal is not possible. Now anti-causal is not possible, it will be non-causal. And here you will get to know that it will be in the strip form. So here it will say that mode of z less than 2 but greater than 0. This will say that mode of z greater than 1 by 2, and this will say that mode of z less than 3 by 2. Sorry, mode of z greater than 3 by 2. So greater than 3 by 2, greater than 1 by 2 and less than 2. So common region will be between 3 by 2 to 2. So you can directly see common region will be between 3 by 2 to 2. So this will be the region of convergence. These are the same for everyone, because these are in the strip form between two finite poles. So between 3 by 2 to 2, right? And for the last one, this will be between 1 by 2 to 3 by 2. Okay, so non-causal and non-causal. Well and good, understood everything, right? So if poles are given, or if you are able to find out the pole, you can let me know what all signals would be possible. So if this question is there, x of n is having a z transform of x of z. The poles of x of z are given 1 by 2 e to the power j minus 30 minus 3 by 2 e to the power j minus 60. You need to know that you need to let me know that how many causal, non-causal and anti-causal signals are possible. So here I have considered 0 as well and infinity as well. That means they are not the pole. 0 and infinity are not the pole. In the next question, infinity will be the pole. In the next question, 0 will be the pole. And in the next question, both 0 and infinity should have been the pole, but it is not there. So yeah, this is the question, that you are having these poles only. In the next question, infinity will also be a pole, right? So as of now, only poles are 1 by 2, minus 3, 3 by 2. So what would be your mode of z? Basically your poles are 1 by 2 e to the power minus j30 minus 3 by 2 e to the power minus j60. So mode of z's are 1 by 2, 3 and 3 by 2. So you can surely make circles. One by 2, 3 by 2 and 3. Right? Now, is it possible to go outer to the outermost pole? Surely it is possible to go outer to the outermost pole. What I am saying is that, is it possible to go outer to the outermost pole? Yes, it is possible to go outer to the outermost pole. And if it is possible to go outer to the outermost pole, what does that mean? That means this part will be of a causal signal. So mode of z greater than 3, this will be causal. Is it possible to go inner to the innermost pole? Yes, it is possible to go inner to the innermost pole. So mode of z less than 1 by 2, this will be your anti-causal. Next, ROC will be in the strip form. So if this is the ROC, this could be the ROC strip form between 1 by 2 to 3 by 2. So between 1 by 2 to 3 by 2. So this will be surely non-causal. And next one would be between 3 by 2 to 3. So this will also be between 3 by 2 to 3. This will also be non-causal. Is that clear to you? Is this concept clear to you? Now if I introduce another pole at infinity, so what will be my mode of z? 1 by 2, 3, 3 by 2 and infinity. So same diagram I will get, this ditto same diagram I am going to get, but the issue will be, what will be the issue? The problem will be that there is another pole now, and that pole is at infinity. So another circle should be made. There you go. Another circle should have been made, which is mode of z infinity. Is it possible to go outer to the outermost pole? This is the outermost pole, no? And this is the innermost pole. Is it possible to go outer to the outermost pole? No. That means this ROC previously it was outer to the outermost pole, but now this ROC would become in the strip form. So this ROC would be a strip form now. This ROC has become a strip form now. So there is no chance that you can get a causal signal. So this is not possible. Causal is not possible. Here causal was also possible, non-causal, anti-causal, everything was there. Now causal is not possible because you cannot go outer to the outermost pole. What does that mean? That mode of z greater than 3 but less than infinity. So this is also in the strip form, so this is non-causal. So you will get non-causal signal out of it. 3 by 2 to 3 less than 3 greater than 3 by 2. So 3 by 2 to 3, that is also non-causal only. Then 3 by 2 to 1 by 2, that is also non-causal only. But inner to the innermost pole I can go. Inner to the innermost pole, because innermost pole is 1 by 2. So inner to the innermost pole I can surely go. So mode of z less than 1 by 2, this I can surely go. Right? So this will be my anti-causal. So anti-causal is surely possible. Anti-causal is surely possible. What do you think what will happen in the next question? In this question here, so ditto everything I can copy. Just the point is, where will be the poles? Poles are there at mode of z. Mode of z is 1 by 2, 3, 3 by 2 and 0. So this is the innermost pole and this is the outermost pole. So first thing is that I need to remove this one. And second thing, I need to remove these ones as well, because 3 by 2, 1 by 2 and another pole I will have now. That will be mode of z equals to 0. This is the another pole you are having. This is the another pole you are having. So it is not possible to go inner to the innermost pole. Inner to the innermost pole you cannot go, but outer to the outermost pole you can surely go. Outer to the outermost pole you can surely go. So this is surely possible. So this will become causal now. Mode of z greater than 3. This will become causal. This will be non-causal only. This will be non-causal only. But here you are going lesser than 1 by 2 but greater than 0. So it is like a strip form. So this will become non-causal. And can you go below 0? Going below 0, not possible. Not possible. So inner to the innermost pole you cannot go. That means anti-causal is not even possible. I could have framed one more problem, which I did not write down here, but could be there. What would be that question? So that will have poles at 0 and infinity both. So what I will say, it is having poles at 0 and infinity both. So now this is my innermost pole and this is my outermost pole. So it is not possible to go below 0, it is not possible to go outside infinity. So there will be another pole, that will be infinity. Another pole will be there, that will be at infinity. So everything will actually be in the strip form only. So everything will become strip form. This is also a strip form only, right? So here also I will write mode of z greater than 3 but less than infinity, because outer to infinity you cannot go. So this is in the strip form, so this has to be non-causal. Between 3 by 2 to 3 this was non-causal only. Between 3 by 2 to 1 by 2 this was non-causal only. Between 0 to 1 by 2 this will also be non-causal. So here anti-causal and causal both are not possible, only non-causal signals are possible. So depending on 0 and infinity are very important. So depending on 0 and infinity our scenes are changing. Okay, well and good. You need to fill this table. Fill the table, think about it and fill this particular table. ROC is in the strip form? No, ROC is not in the strip form. 0 is included. So this can be written as mode of z less than alpha. That's it. So it is inner to the innermost pole. 0 is included. That means at 0 you are not having any pole. That means it is inner to the innermost pole. So x of n will be anticausal. What about this one? This is in the strip form. So this will be non-causal. Is it in the strip form? No. Yes, it is in the strip form because infinity is not included. Infinity is not included. That means at infinity you are having a pole. So it is in the strip form. But is it in the strip form? No. Greater than alpha, infinity included. So it is outer to the outermost pole. It has to be causal. Surely it is in the strip form between alpha and beta. So this will be, no doubt, it will be non-causal. Now in the next one you can see that ROC is entire S-plane. 0 to infinity, 0 to infinity, 0 to infinity, 0 to infinity. So surely there will be finite duration plus finite amplitude. There is no doubt about that. Finite duration plus finite amplitude. But you need to tell causal, non-causal and all these kind of things. So surely there will be finite duration plus finite amplitude. Finite duration plus finite amplitude. Now here 0 and infinity both are included. That means entire Z plane, 0, infinity, everything included. That can happen only when there is impulse sequence. I told you only one is there Only one possibility is there, that it has to be impulse sequence. Now second one, greater than 0 but infinity is not included. Sorry, greater than 0 but infinity is included. Greater than 0 but infinity is included. So greater than 0 but infinity is included. That means this kind of ROC you are having. So it is outer to the outermost pole. Outer to the outermost pole, that means it has to be causal. Is that clear to you? Infinity is included. That means it is not in the strip form. Outer to the outermost pole. Here 0 and infinity both are not included. That means you are having a pole at 0 as well. You are having a pole at infinity as well. So it is like a strip form. So if it is like a strip form, that means it has to be non-causal. And what about the last one? Greater than 0 but less than infinity. That means 0 is included. You are not having any pole at 0. You are having a pole at infinity. So it is inner to the innermost pole. It is inside. ROC is inside. And if ROC is inside, it has to be anti-causal. There you go. Okay. So this is the answer of everything. These are the answer of everything. ROC and X of n. All good. So this is the conclusion. If you just revise this slide, that means you have revised the complete Z transform. Next we need to study about inverse Z transform. So that we will see in the next lecture. We will see about inverse Z transform. We will solve some problems and then we will see some more concept related to Z transform. So let's meet in the next lecture. Okay, so in this lecture I discussed about ROC only, mainly about ROC, and some initial concepts also we saw. So ROC discussion is done. I hope you enjoyed it. Let's see inverse Z transform. So there as well I need to discuss ROC, because depending on the ROC we can get different kind of signals. Well and good. So let's meet in the next lecture.